So, but to meet that one, we need to have the same kind of technology which is suitable for at the ground level. And these are some of the advantages of the mechanization. So many of you may know this one. That is, actually we are saving the maximum time around, on an average we can save around 50 to 60% of the time. And when we talk about the manpower, so some of the operations are there where you can say 30 to 40%. In some of the operations are there, especially where we are involved in the drones, we are saving up to 90% of the time and around 70 to 75% of the manpower there. That much of savings can be done. And of course the lower input cost is there. So when we are reducing the input cost, we are reducing the operational cost. So when we reduce the operational cost, automatically it is going to help for improvement in the income of a farmer. So indirectly it is also going to affect the income of the farmer. And of course, since everything has been done at a perfect timing, means at the right quantity, already we know the precision farming. So anything which can be applied at the right quantity, right time and at right place. So if it is achieved by using the mechanization process, then ultimately we will be in the yield also. So that is the mechanization level in India, if you see. So usually the broad field operations, you can see. So in soil working or this seed bed preparation operations, almost 40% of the crops has been mechanized. Then in sowing and planting, 21% has been operations are mechanized. And in plant protection, 34% has been mechanized, irrigation 37%, and maximum we can say the harvesting and threshing, there is around 60 to 70% has been already mechanized. So only the, but in the, if you see in the other way, we can also say that if the 40% has been achieved, means still 60% scope is improvement. So that has to be explored and that has to be met in the short period of time. Of course, we have taken a large 40%, but I think within a short period of time, we need to achieve the remaining 60%. That is the major challenge. And that is the mechanization level in our India. So we can see high mechanization has been there in the Punjab and Haryana region, parts of the Haryana region. Medium mechanization in Maharashtra, Andhra Pradesh, Telangana, and some part of the UP. Okay. Then when we see our Karnataka, so we are having a low mechanization level. So low mechanization level means at our Karnataka level, we are having the power input was around 2 kilowatt per hectare. So it depends upon the how much kilowatt per hectare we are giving the power as an input for our field. So we are in Karnataka, recent estimation was around 2 kilowatt per hectare, which is comes under the low category. So there is a more scope for improvement of the mechanization level even for our Karnataka also. So this is the just I want to discuss about the evolution of agriculture. So how the agriculture has been evolved. So just like how we can discuss about our softwares. So updates of the softwares. Even we are using the mobiles which has been updated continuously. We will be getting the updates every year. Or earlier we used to get update for every 3 years or 4 years. Later on 2 years. Now we are getting 1 year. But when we see the present conditions, every 6 months we will get one update. So as the time is going on, so the period for the updates or period for improvement is because of the more competition in the world. So similarly, this is the first there are versions of agriculture are there 1, 2, 4. So there is the first agriculture version where only we are completely depend upon the small hand tools or small manpower, which is started from once the invention of the agriculture, practice of the agriculture, 10,000 BC. So that we can see later on. Then comes the agricultural second version, version 2.0. So when we started the introduction of the agricultural machines. So after the invention of the engine, that is it may be a steam engine, diesel engine or a petrol engine. So once the invention has been started, then how best we can utilize that power into the agricultural field, that has been explored. And whenever in the 19th century when we started using those agricultural machineries and usage of the chemicals for the increase in the crop yield and for controlling the pest, then that we call it as an agricultural version 2.0. So later on, next version comes is the where the there is since there is sudden decrease in the manpower who are going to involve in the agricultural sector. So there then the introduction of the computers and the deployment of partial robots, they have started. So where we are having already we are programming the things, The only thing is we need to give the command. One person has to give the command. So what has to be, what operation has to be taken place, and at what time. So everything has to be decided by a person, but he is not going to be going to for the field and do some manual things. Automatically it will be done by those mechanical computer programs. So that will be agriculture version 3. Today what we are seeing, agriculture version 4, where it is a completely smart systems and smart sensors have taken place, and the human power has been replaced. So in this system, the difference between these two is, here there is no intervention of the human is required. Automatically, for example, previous version, he has to see whatever irrigate. He has to decide. He has to just, we have seen the pump operation by a telephone. Just by calling or just sending a message, we can start and stop the pumps. So that decision has to be taken by a person. That comes in agriculture 3.0. But in this, we are already installed a smart sensors in the fields. It is going to sense the what is the moisture content is there. So when the threshold level is reached, automatically it sends a signal for the operation. The pump gets started. So everything will be done through the smart system itself. No decision making is completely done by the system itself. So only the human intervention is only installation and its maintenance. That's all. Even the person without having a proper knowledge of agricultural cultivation, he may take. Of course, it is very difficult for him. He has to understand the things, but he may take using with this smart system. Just like we person using this smart mobiles. But currently, if you see, can anyone guess in what versions our India is lying now? We are in between 2 and 3, sir. We are shifting about 3. We can say it's a 2.5. So just like our 4 networks, 1G, 2G, 3G, 4G, 5G. Similarly, we are at 2.5G, we can say. Our agriculture version is 2.5. And shortly, I think within 4 to 5 years, we will maybe completely shift into 3 also. And just what I said, you can see the difference here. 10,000 BC to 19th century, it took for one version this much of years. Then from 19th to 20th century, within 100 years, we are going for 3. Then within the span of around 10 to 20 years only, in the world, it has been shifted for agriculture 4.0. We are talking about this one now. But it will take some time, even for India also. I think within 10 years also, we may be completely shifting towards agriculture 4 also. Maybe, we hope for that. So that's why earlier we used to say sustainable agriculture. But what we are saying is, what we are to think that we need to go for sustainable agriculture along with the smart things. That's why I want to say we should go with smart sustainable agriculture. So there should be a sustainability in the agriculture along with some smart systems involving and for controlling the things. So where this agriculture evolves with, as I said, in the science and technology, and it is only a matter of time which requires these kinds of smart key elements. Okay, so these are the key elements which are required for achieving those aims. That is to optimize the production efficiency, and so whatever the quality is there, it needs to be optimized. Of course, by taking care with the environment, minimum environment impact, and whatever the risks that are associated with the production practices. Those things has to be achieved. So for achieving that, we require some key elements. So these are the vital key elements that are going to play an important role. That is remote sensing. Of course, we are already started using the remote sensing for our purposes. We are having the different satellites, we are taking those images and we are analyzing the things, and we are predicting and we are forecasting the things. That is, we are taking help of the remote sensing. Then of course the data processing and management, cloud computing, telecommunications, mechatronics, automation systems. Then IoT, we are talking about the IoT also. Then artificial intelligence and robotics. So these are the things which were already used and practiced in other sectors. Now it has been shifted to the agriculture sector. And of course, more than those sectors, as an agriculture sector, we are having the what you can say, the more scope compared to those sectors. So in this, one of the thing what we are discussing was about the drone technology. Okay, drone technology or UAV, unmanned aerial vehicles. So many names are there. Unmanned aerial systems, we can say. Unmanned aerial vehicles are there. Okay, so many names are there. But here the main thing is we are using one simple equipment which is going to fly in the air, which is without any pilot. Okay, so the operator will be on the ground surface. He is going to control the things. That's what we call it as a drone. Actually, the drone is a long form which is a dynamic remotely operated navigatory equipment. So this is we can see that it is a broad term. It is not fixed for only that one. Usually, when we talk about the drone, means the first picture comes into our mind is this one. It is not true. Of course, it is a drone, but drone is a broad term. We can say water drones. So which is operated in the waters, that is a water drone. So it is operated in a air drone, land drones. So everything. So which is dynamic, remotely operated navigatory equipment, which comes under this category, we can call it as a drone. Since it is a very fancy term and since we are new to this one, so usually drone and even we also use this drone only. When we talk about the UAV and when we talk about the drone, then everyone can understand. That's why we are using this term. So as I said, UAV, unmanned aerial vehicle, this is an aircraft without a human pilot on board. So pilot will be on the ground. He is going to operate through a transmitter. And again, the operation can be done completely manually, or he can go for an autonomous mode. In autonomous mode, just we need to have a geofencing. Geofencing means we are giving the boundaries and your drone is not going to cross that fence. Within that boundary only it is going to operate, and whatever the things and whatever the way paths or way points, so how best you can you can mark or you can prepare those things, that depends upon an operator. He can prepare it and he can give the command to do the required operations. So autonomously, so just from the takeoff point, it is going to go, it will go, do the operation, whatever the required is there. After the completion of the work, it comes back to the original position of the start point. So this is the autonomous mode, what you can say. And till now we have seen the applications in military and surveillance, because if you see any technology, maximum 90 to 95% of the technologies which has been now we are using, that was the invention was for the military purpose only. First they have used for the military purpose, later on that has been taken back for the civilian purpose. Best example is our GPS system. GPS is also meant for military purpose only. Now we are using it. You can take any technologies, maximum technologies they are meant for military purposes only.
I think even computers.
Yes sir, computers also meant for military purposes only, later on they have been used here. So everything sir, 95% of technology they have meant for, even the dried food what we are eating, that is also earlier meant for military purposes. Now later on now we are using it. The reason is, for development of the new technology we require more fund. So nobody is ready to invest in the research purpose for civilians. They are interested for military purpose. That's why new equipments will be developed in the military first. So if you see the history of the drones, as I said, it is used for monitoring and the military purpose. So this is not a new concept. So the first unmanned air balloons has been used by the Austrians in 1849 itself for military and surveillance purposes. So we know that Austria was one of the major military points where we have seen because it is having a very strong military during the earlier period. But Austria was one of the major military points. So 1849 they have started using that one. And after that, in the World War II, they already started using the radio planes. Radio planes, nothing but it is a remote controlled planes. So for bombing, for surveillance, for transporting some equipments, everything was being done by using those. You can see the figure also. This is a drone only, which has been operated by the transmitter, radio based transmissions. Then in 1983, so in Japan, they have started utilizing the drone for spraying purposes, aerial spraying purposes. Of course, we are using the aerial sprayers by using the aeroplanes, but it was having a human pilot on it. Unmanned. Unmanned was started using in 1983 for chemical applications. And this was the first, R-50 was the world's first unmanned helicopter. There you can see which is having a payload capacity of 20 kg. It is, and that was generally used for dusting purposes. So then after we can see after 2015, so a lot of work has been done and initiated where the drones has been utilized for agricultural purposes, and we can say the revolution of the drones has been started from the year 2015 onwards. Even in India also it has been started in 2015 onwards, and as a US Raichur we also started working on the drones from 2018. Then the value of the, of course, once the business has been started, so we can see there is a, earlier we used to have very handful of companies were coming forward for giving us the drones and components. But now we can see hundreds and thousands of companies within India only, the Indian startup companies only. So the huge potential is there even in terms of the marketing also. So this is just a classification of the drones. So broadly, as I said, in classifications it can be classified as per our requirement. So just this is a broad classifications which I have done. That is based on aerodynamics. So drones can be classified as a fixed wing. Okay, so that's a normal aeroplanes. What we are seeing in aeroplanes. So which is having a wings, it is fixed. Those comes in this category, fixed wing drones. Then flapping wing, just like a bird, it is going to flap its wings. Then a ducted fan, multi-rotor. So there is not much difference between the ducted fan and multi-rotor. Only thing is, in multi-rotor, in the drones, we are seeing the propellers outside. In ducted fans, so for around that propeller there will be one cover. That's all. That is the major difference. And again, unnecessarily these two are not used in our agriculture sectors, but we are widely using this fixed wing and multi-rotors for agriculture sectors. Then based upon how we are going to land and take off the drones, one is the HTOL and VTOL. So horizontal takeoff and landing and vertical takeoff and landing. Then based upon the number of rotors, so this is the classification for our multi-rotors and ducted fans. So depending upon the how many rotors and how many propellers we are using, it may be a single rotor helicopter, what we can say, single rotor, it may be a tricopter, a quadcopter, 4 rotors, a hexacopter, 6, octo, 8. Okay, so depending upon the size of the drone, depending upon the quantity of the payload, so we can opt the what kind of rotors we are required. So more number of rotors means well balanced unit. As we increase the number of rotors, we can go for more payload at a very balanced way. So we can right now we are using the quadcopters and hexacopters for our purpose, because we are only limiting the for agriculture purpose I am talking, because we are limiting the payload for around 10 to 15 or even for 20 up to 20 kg also. We are having a drone in our college, in our department. So where we are using the hexacopter only. If you want to go for the payload more than what you can say 50 kg payload, then they are going for the octocopter. Okay, till now it is not required. So quadcopter is most commonly used one. Tricopter is also used, but it is very difficult to operate. A normal person can't operate it. It requires more experience. And of course, if you go on increasing the number of rotors, the cost is also goes on increasing. It will be there. So I'm just taking a classification of the drone which we are using for the agricultural fields. So this one, HTOL, already mentioned, horizontal takeoff and landing. So these are the views of that drones, fixed wing drones, what we can say. So this is these aircrafts or these drones. So it can be used for wherever the requirement is there for coverage of larger area. So large area can be covered within a short period of time because the cruise speed is very high. The flying speed is very high. Okay. Then the payload or the battery, sorry, not payload, the battery backup is also better in these cases. But the problem is it requires a separate airstrip or airfield where it has to runway we require, what you can say runway, where it has to for taking off and landing it requires larger area. But it is difficult to find in our fields. That is an issue. So that's why these are having a very limited application. wherever for larger area monitoring and for larger aerial image capturing, we can use these kinds of HTOLs.
Maybe in abroad it is.
Yes, sir. Sir, no, sir. Even we also using that one, but only for surveying purposes. For covering, if you want having target of around more than 100, 200, 300 or thousands of hectares of area, then we are using that.
Clear sky, what I was wondering. The developer the fixed with the V2A.
Yes, sir. Next one, hybrid. Hybrid.
Hybrid is there.
Yes, sir. And this is the VTOL. So this has been found suitable for our agriculture. Because of its adaptability. Okay. So because wherever there is a small place, even with this on this tabletop also it can be landed, it can be taken. So that's why it is most commonly used for the small area coverages. So, but the issue is here, it requires more number of batteries because the battery backup is very less. Because while taking up, it needs to be self-balanced. For self-balancing, it requires more power. So continuously, it will be in a loop where it continuously taking the power, it is trying to adjust the speed of the propellers. So just like ನಾವು bike ಅಲ್ಲಿ accelerate ಮಾಡ್ತೀವಲ್ಲ, so ಯಾವ ತರ ನಾವು ಅದರಲ್ಲಿ ವೇರಿಯೇಷನ್ ಮಾಡಿದ್ರೆ ನಾವು fuel consumption ಜಾಸ್ತಿ ಆಗುತ್ತೆ. In similar manner, here also the fuel consumption will be more. Fuel means in terms of battery charges. So already ಜಾಸ್ತಿ ಆಗೋದ್ರಿಂದ we are getting the lesser battery backup in these things. That is the major reason. But we are not having any other options. It is the best suitable for the short period. Even ಸ್ವಲ್ಪ ಜಾಗ ಇದ್ರೆ ಸಾಕು ನಮಗೆ we can land ಮಾಡಬಹುದು. That's why it is popularly used. That too for the spraying purposes. Again, the same thing can be used for taking the images also, but for a smaller land. So of course I already said about this. So that was a tricopter. This is the quadcopter, hexacopter, and octocopter. So based upon the number of arms and number of propellers, we can decide it. So this is what we are talking. There is, sir was saying, it is a hybrid drone. So it is a combination of both. We can take the advantages of STOL and VTOL. So takeoff and landing can be done by using these propellers. So once it attains to our maximum, selected height, then it will act as a horizontal. So what are the advantages are there? That is battery requirement ella complete like a high speed cruise, area coverage will be more. So everything can be done. And again while landing, so that will be shut off. Then again these four propellers will start its operation. It will be landed. But again, its efficiency is also in between these two. ಅದು ನಮ್ಮ ಎಸ್ಟಾಲ್ಗಿಂತ ಕಡಿಮೆ ಇರುತ್ತೆ, ವಿಟಾಲ್ಗಿಂತ ಸ್ವಲ್ಪ ಜಾಸ್ತಿ. But again, the cost is also more than those two. ಅವೆರಡಕ್ಕಿಂತ ಕಾಸ್ಟ್ ಕೂಡ ಇದು ಜಾಸ್ತಿ. Actually, the cost of STOL is lesser compared to VTOL. So this is the another classification of the drones. So this has been classified by the DGCA. Because the DGCA is the governing body for the drone operations in India. So they have given the classification of the drones and they have given the guidelines in 2021. So as per their guidelines, so this is the classification. So they have made into 5 classifications: nano, micro, small, medium and large. So whichever the drones including payload, the weight of the drone plus its attachment. If the weight is less than 200 grams, then it comes under the category of a nano category. Okay. So then, so they have given only this much. So these are additional information I have given because what was the range? Usually those things maximum they can go up to 5 kilometer range. Very rare cases. Usually it will be within 100 meters only. Normally, for special purpose, if you want to use it also, that can be increased only up to 5 kilometers. That's all. Then usually it will be a fixed wing type or it may be a multi-rotor type. Then comes the micro category. So where the weight will be between 200 gram to up to 2 kg. and it will be having a range of 25 km, and there also the drones will be maybe a fixed wing or a multi-rotor. Then the small category 2 to 25 kg, 40 km range is the fixed wing or it may be a multi-rotor. For the agricultural purposes, we are using these drones, which comes under the category of small. And some of the drones are there which may be coming around the 30 kg, 27 kg, 20 kg, that will be falling in medium category also. So it is having a payload of 25 to 150 kg, 70 km range, and usually it is also will be a fixed range multi-rotor. But in case of the large drones, where the payload is more than 150, there the multi-rotor is not used. Only a fixed wing are more suitable, and those things are usually used for the military purposes.
But it will go beyond VLOS, so this range, visual line of sight, goes beyond
Yes, sir.
VLOS.
It will be going beyond something.
Is it permissible?
So that is the, what I am saying is, it is achievable. Achievable. But as per the rules, we need to follow.
Sir, but what is the battery range is also
Yes,
given.
battery power
Sir,
it will-
for 5 kilometers at a stretch, we can have a battery in that group.
That can be achieved in the fixed wing. Fixed wing ಅಲ್ಲಿ even 100 km ಹೋಗ್ಬರುತ್ತೆ.
With a single battery.
Yes, 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 yes. It is possible. Multi-rotor alle issue ಇರೋದು. Even with the multi-rotors also, the issue is because of the payload. If you reduce the payload, means automatically it is going to increase the battery backup exponentially, sir.
So any case studies where they have achieved this?
What?
High
Case
range,
studies.
that is long range, like
Long range.
5 kilometers or 20 kilometers.
So there are some things are there for surveying purposes they have used. Surveying ಈಗಲೂ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. Just ನಾವು ಇಲ್ಲಿ if you want to cover the complete district wise, especially for the planning for the road planning ಎಲ್ಲ ಮಾಡ್ತಿರ್ತಾರಲ್ಲ, ಸೊ ಅವ್ರು ಬಹಳಷ್ಟು ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ಇನ್ನು ನಾವು ಅಗ್ರಿಕಲ್ಚರ್ ಸೆಕ್ಟರ್ ನಾವು ಅಷ್ಟು ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. So these are some of the regulations they also given for the operations of these nano drones, micro drones, small drones, and medium and large drones. So for operation and holding of the nano drones, so no registration is required. So registration is just like vehicle registration what we are doing. So similar kind of registrations need to be done for the drones also. It is we can say nano drones are just like our bicycles, which does not require any registration. But and also no permit required for flying except in controlled airspace. So wherever already I think you people know the controlled airspace. Of course, next month I will show all that also. So where it says the red zones. So in red zones, no kind of drones is allowed to fly without permission. Then I must ensure you do not fly any nano drone beyond 50 feet of height. Then that's what 15 meters up to above HQ. Then comes the micro drone. So from the micro drone onwards, all drones needs to be registered, compulsory. And these micro drones are restricted up to 20 feet flying height from the ground level. Then no permit is required for the recreational use. If you are using for recreational purposes, no special permission is required. But the permission is required for the commercial usage and flights in controlled airspaces. Then regarding the small drones, medium drones and large drones, so the maximum, this is for the civilians, whatever the rules they have there. So maximum height 400 feet or 120 meters, above that we are not allowed to fly. Maximum is 120 meters. Then registration is compulsory. And for operation of these drones, we should have a DGC approved pilots. For these category, that is the micro and nano drones, no registered pilots are required. Even ಯಾರಾದರೂ ಸ್ವಲ್ಪ practice ಮಾಡಿದ್ರೆ fly ಮಾಡಬಹುದು. But for the operation of the small, medium and large drones, compulsorily we should have a licensed pilot. So this is the components of an agricultural spraying drone, because majorly we are working with this unit only. Of course, everything remaining, we can divide this unit into two parts. One is the drone part, another is the spraying part. So drone part will be common for all the drones. So that is the first unit. This is important thing. That is the propellers, where we will be having as per number of rotors are there. Those number of propellers will be there. And again the propellers, I think many of you know, there are two types of propellers will be there. Two sets will be there. One is the clockwise, another is the counterclockwise direction. Just by seeing them, we can identify them. Then drone arms which is going to support these motors and propellers. Arms are there. Then there will be central part which is known as a drone hub where the entire brain of the drone will be fixed. Then BLDC motors. So brushless DC motors will be there, which is connected with this ESCs, electronic speed controller. So which is going to control the speed of these. So speed of these motors that will be completely controlled by those ESCs, which is receives the signal from the flight controller. Then GPS system, which is going to monitor or which is going to identify the position of the drone system, and radar for the obstacle avoidance. So this is an optional. Some of the companies are providing. Of course, we are already having the drone here. We can see the radar sensors also. Many of you may have seen that one. So that can be very safety feature which is required. So that is one of the safety feature which is required. So the drone is going to stop before the hitting the obstacle. And that is a battery charger which is used for charging the batteries. So these are the batteries. Again, depending upon the type of the drone, the capacity of the batteries also varies. Usually for this drone, I think the same batteries are used, which is having around 16,000 mAh capacity. 2 sets of batteries are used for that purpose. And in some of the drones which requires higher capacity, we will go for 4 number of sets. And these batteries are connected in series. Then this is the power distribution board, PBD, what we will be saying, where depending upon the requirement, the power will be distributed and it will be fitted inside this drone. And of course, there will be two things. One is the receiver and transmitter. So those things will be paired, and these are having the unique pair, you can say. So the one transmitter is unable to communicate with the other receiver. It is having its own pair. Always it is going to communicate its own transmitter. So we have to know, very important. If any one fails, means entire system needs to be changed. We can't change any one part. So then coming for our spraying equipment, so there will be one tank for holding the fluid. Then comes the nozzles. Again, that depending upon the capacity, the number of nozzles may be 2, 4, 6, 8, 10. So how much capacity, depending upon the size of the drone and some operational parameters and application rates, we can decide that one. So there are drones which are having the rotary nozzles where only 2 numbers are required, and number of nozzles usually optimized for 4. You can see, I think this is also having the 4 number of nozzles, and we are having one drone which is having the 6 number of nozzles. So depending upon our requirement, it can be varied. And for operation of that sprayer, we require one spray pump also, so which is going to be controlled by the controller again. So this spray pump is there, it is not controlled with the flight controller, it is having some separate device which is controlled by this transmitter. And some of the things that okay, so again that of course these are the connectors which are going to be connecting for sprayers. And okay, so these are some of the components are there. And flight controller, I have missed this part. So flight controller, so this is the brain of the drone system. So flight controller is going to decide what are the decisions that drone is going to take depending upon the situation. So this is the important thing which is mounted here. And again we need to see the different types of flight controllers are there. So depending upon the their versions, so the decision taking capacity also varies. So regarding the maneuverability of the drone, so we are using this transmitter. You can see just taken an example of a transmitter which is having the different channels. And again, the transmitters may be different for different drones. So this is the one kind of a transmitter. Again, the transmitter is also having the different channels also. Channels means it is the what you can say, there is a pipeline for communication. So in one channel means we can only communicate yes or no, that's all. Another channel means we can say the drone to start or stop the spraying operation. Third channel, it may be to command the drone to move forward or backward. Fourth channel, it may be commanding to move right or left, like that. So each channel is going to send only one signal. So depending upon the requirement, so these are number of channels will be there. For example, if you see this one, so this is the two channels are there here. Joystick ಅಲ್ಲಿ ಎರಡು ಚಾನಲ್ಸ್ ಇರುತ್ತೆ, ಇದರಲ್ಲಿ ಎರಡು ಇರುತ್ತೆ, so 4 ಆಯಿತು. ಇಲ್ಲಿ ಎರಡು ಆಪ್ಷನ್ಸ್ ಇದೆ, 5, 6, here 3 options are there, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is a 16 channel transmitter we are going to say. It means we can send 16 types of signals or commands for the drone. So whatever the actions you want to actuate in the drone, we can give 16 types of commands. We can use maximum 16, less also it can be. But if you want to use for any more than 16, then this is not used. We need to change the transmitter and receiver. And I think yesterday I think that has been covered.
Yes.
So throttle, yaw, pitch, roll, I think it has been covered. So just these are some of the things. So DGC, as I said, so this is the main governing body or the regulatory body we can say, which is going to govern the rules. And in the year 2021, the drone rules has been given with some amendments in 2022. So where we need to follow the things, guidelines, detailed guidelines is there. And for the operations of the drones only, they have created a separate platform, that is the Digital Sky platform, where we need to do all the drone related activities. Even you can see the flying zones, whether it is coming under which category, that thing can also be done. And this is also one important thing, so geofencing of the drone is also required. So when we are purchasing the drone, we should see that this facility has to be provided. But of course, nowadays when we are purchasing the drone, if you are already purchasing a registered drone, so everything will be taken. It's not actually. So these are the drone zones which are green, yellow, and red zones. So these zones, it is not fixed for the particular region. So daily it is going to be updated in the website. So that's why they are suggesting that before taking a flight, we need to check the zones regularly. So you want to flight, just go to the website, check the zone, whether where we are flying it comes under which category. So it is always going to vary. Usually, generally, for the airports, for the international boundaries, and for the regions where the more importance is there, national importance is there, just like it may be a important temple, it may be a Vidhan Saudha, it may be some dam structure. So those are the structures of national importance. So usually those will be permanently red zones, and some of the things will be there where there may be some period. Suppose the PM is coming for Raichur. Raichur is usually it is a green zone. If he is coming means they may declare that as a red zone on that day.
For the time being.
For the time being, that will be updated. That's why we need to regularly check the zones. And this is the yellow zone. Where, red zone we can operate it, but it requires the permission from central ministry. Our authority. We know the process, it is very difficult. So now one apply better. Because it is very difficult. Then coming for the yellow zone. So in the yellow zone, so no permission is required up to 200 feet. That is the outer yellow zone and inner yellow zone. So from the red zone in the 5 kilometer radius, it is the inner yellow zone. So for the inner yellow zone, permission is required. It has to be taken by the local ADC. ADC in the air traffic controller in the permission. But after 5 kilometer, up to 8 kilometer, no issue. We can, without permission, we can fly. But the restriction is we can go up to only 200 feet. That is a restriction. We can't go beyond the 200. Then comes the green zone, which is a green means we can take flight anytime without any permission. And of course, the limitation will be 400 feet. So 400 feet will be there. That is the maximum ceiling what they have provided. this is the same thing what I have discussed. Directly we can say red zone means it is not at all allowed only. You need to forget it. It requires directly permission from the Home Ministry only. It's very difficult to get. So for yellow zone, it requires permit. That can be taken at ATC level only. And green zone, no permission is required. So just coming for the applications of the drone. So as I said, it is having a very wide applications in general. So among these, usually, so first one is the entertainment purpose. So it has been initiated with the entertainment purpose only for video recording, for making the movies, so for taking the different videos at different angles. So for that purpose only it has been meant, it has been used. Later on for taking the aerial photographies of the area. It may be a structure of national importance, or it may be a structure where we want to have some designs, or if we want to plan something for the roads or for the designing, even for the sites also, they are using that one for taking aerial photography. Then shipping and delivery purposes, so for transporting purposes also it has been used, can be used. Then for mapping purposes, so where we are having the giving more importance to map our area, to map our land, what are the situations are there, what are the cases are there. Then of course nowadays they are also using for disaster management. So in case of any disaster is there, to estimate how much area has been affected and what are the things that has happened. So what is the real situation is there, flood situation is there. Those things can easily monitored by using the drones without going there. Then of course in precision agriculture, in agriculture sector also it is having an importance. Then we can discuss in detail later on. Then search and rescue for searching in the forest area, in the hill stations where the persons are unable to reach there we can search by using the drones. And weather forecasting, just by flying in the atmosphere, we can have with some equipment, some sensors, we can forecast the weather also, what is happening with there, that can also be done. And another important unique thing is that it is a wildlife monitoring. So this has been used in wildlife monitoring also for counting how many, for example, to count the tigers. So many ways are there where they are taking the help of this drones also. It is very simple. Just by fitting one thermal camera, just fly it, we can easily count the number of animals which are present there. So anything which can be, which we want to monitor, which we want to control from the far away distance, we can use the drone. And of course in law enforcement also, we have seen some of the drone applications during our COVID lockdowns also. ಬಹಳಷ್ಟು videos ಎಲ್ಲ ಬಂದಿದ್ದಾವೆ ನೋಡಿರ್ತೀವಿ. The police were using the sirens, they are using the taking the videos, photos wherever who is roaming in here and there. Those things can also be done by using the law enforcement. And if you see the usage in terms of the sectors, so you can see the maximum sector, that is 42.9. So it is completely used for the photography purposes. So entertainment purposes. ಅದಕ್ಕೆ ಬಂದಿರೋದು ಮುಂಚೆ ಬಂದಿರೋದಕ್ಕೆ people are ready to invest that one because they can make money through that. That's why maximum of the drones can be used for the entertainment purpose only. And in case of the real estate purposes, so next is there. So for, because wherever money is involved, more investment will be there, more technology they are going to use. So for monitoring, for measuring the area, for seeing the site development activities, for planning the things, everything can be done by using the drones. So there it has been used. And if you see the agriculture here, 8%. So now we have started initiating it. Earlier it was very less. So this is recently we have seen that a significant rise in the agriculture sector is there. Then again there are different are there in the research, other scientific and conservation, government and insurance purposes. So everything is there which is very less in number.
So what is that 333 exemptions listed in the use of percentage association?
Sir, these are the sectors actually the US have given where they can use the drone applications. Sections sir. Sorry, 333 section for the operation of the drones. They have mentioned for what are the activities we can use the drones. Now we use one sir, but they have already used and they have already made the laws in the US.
No. If that is exemption means whether it is exempted from getting permission or something like that, what is it?
Exemption means it is exemption, the drones are given exemption for these operations. ಇದನ್ನ ಬಿಟ್ಟು ಮತ್ತೆ ನೀವು ಬೇರೆ ತರ ಏನು ಯೂಸ್ ಮಾಡಂಗಿಲ್ಲ. ಏನಾಗುತ್ತೆ ಸರ್, even though we are also, if you are not giving anything so here, just I want to show what are the data acquisition platforms which we are going to use. So these are the data acquisition platforms. Already some of them we are using. That is, it may be a satellite as a data acquisition platform, aircraft as a platform, drone as a platform, and manual surveying as a platform. So just for related to the acquisition of the data for the agricultural purposes. So of course, many of us are using already used, and it is, you can say, little bit age old about the satellite data. It has been, everyone know how to use, and what are the things that can be done. But here the pros are, more area can be covered in terms of thousands of hectares area can be covered in one image. And of course, since we are investing more and we are having a very wide spectral capabilities in the satellites. So hyperspectral imaging, number of 1,000 bands of the images, images in 1,000 bands can also be acquired through that satellites. But the cons are, if you see, so whatever the data is there, it will be a little bit expensive. Of course, some of the data is freely available, but it is many of the data is not much important for us, may not be used for us. After free, for very less precise works, it can be used. But if you want to have a maximum precise level, means it is very expensive, and resolution is very low. Resolution is very low. So at max, we can get 50 centimeter in 1 pixel. So we can roughly say half meter by half meter area can be represented in each pixel. So for precise applications, it is very difficult to use this one. And one more very important disadvantage is data acquisition is not in our control. If I want to have a data today, means it is not possible. We need to wait for the satellite. It has to pass through that area, then only we are able to get it. Unfortunately, if there is any clouds are there on that period, means again we need to wait for 1 month or 15 days. So that is a major issue what has been faced by the satellite images. So for that to overcome those disadvantages, so the aircrafts were used. So for even through this one also, we can have a larger flight coverage, high resolution can also be done, and wide spectral capabilities, because we are just fixing the different sensors and we can get the different data. But the problem is, it will be a very expensive one, because we can't cover a small area. Complete aircraft is required on aeroplane with the pilot, everything will be there, setup should be there, permission should be there, airstrip should be there. So it will be an expensive matter, and image timing will be controlled by the provider who is going to provide it. So actually these kinds of data is not available in India, but US or European countries, there are some providers, data providers are there who are using the aircraft, they are having their own company. Just like now satellite data procurement, in a similar fashion we can procure this aerial photography also. So these are some of the disadvantages. Then that's why we can see the advantages of the drone more. That is, image acquisition, whenever it is required, we can having our own drones, or we can hire the drone, we can fly it today itself, we can take the images of that particular area. Even there is a cloudy or something also, that can also be avoided, and we can have a clear picture of it. Then of course we can get a very high resolution, even 1 centimeter changes can be noticed using these aerial photographs taken by this drone, and completely unaffected by the cloud cover, and cost effect is also there. Then but the issues with these drones is, it is having limitations of area coverage. A smaller area can be covered using the drones, and of course the major is the drone regulations. We can't take the images as and when required and wherever required, because we need to follow some regulations as per our DGCA in India. And these operations are of course susceptible to the weather. If there is a rains or heavy winds are there, means we can't take the operation of the drones. Then of course the manual surveying, already we know it is a manual surveying, means it requires more manpower is required, works will be it's very drudgery is involved in the works. So those things are the which is not accessible. So again, but of course it is having a very high resolution, high excellent positional accuracy. Those things can be done, but shorter distance can be covered by using this manual method. So if you see all these things, so we can find the drone as one of the best option for accurate and quick data acquisition platform. So these are the potential areas for the drones which can be used in our agricultural sector. Okay. So previously you have seen a wide range of applications. So we will specifically talk about the agriculture sector where we can use the drones for its application. So these are the things we can say. So soil and field analysis purposes we can use. This I am going to discuss one by one how best we can use those things. Then seeding and planting. So even we also started developing one sowing equipment for the drones, because what happened is if you are purchasing a drone which is costing around anywhere between 5 to 10 lakhs only for spraying, means it is a waste of investment, we can say. For certain period only we are going to use it. To have multiple users, so we need to have some multiple equipments or multiple attachments. That's why we are planning for the sowing and planting purposes. Of course, it is a lot of difficulties is there. Ellargu nam mind questions barutte. Sowing use madre what will be, how to sow it, how to cover the seeds, how things XYZ. So many issues are there. So we are trying to find out what are the best options are there, or in some way under what situations, because some of the things will be there where some conditions can be compromised. So adi yav tara situations idave ellidave anta we are exploring the things and we are trying to develop one sowing equipment also. Of course, and especially in case of the forest areas. So forest areas even India thousands of hectares of area has been covered using the drones. Then comes the crop monitoring and management. So this is the important thing where just by sitting in the laboratory or in the room, we can easily capture the data, we can analyze the things in the lab and find out what is the situation of the crop is there, what is the requirement is there. Based upon those maps, whatever prescription maps we are saying, so based upon the prescription map, we can supply the inputs wherever it is required and in a required quantity also. Then of course the chemical spraying, so this is the basic thing which we are using. It may be a spraying of a pesticide, it may be a spraying of a nutrients or fertilizers. So any spraying operations required, that can be done by using the drone. Then for water management, and again for water management what we are doing, so we can take the images and we can measure the soil moisture distribution in the field, and depending upon the requirement and the water stress levels, so we can irrigate that particular area. At the same time we can also monitor the irrigation lines. Already irrigation lines is there, so wherever the blockage is there, wherever the proper irrigation is not taking place, that can be monitored. Somewhere it is there is a leakage of the water is there, that can also be rectified. Okay, so for smaller areas we may not find the importance of these things, but when we are going to manage the in thousands of areas for bigger irrigation projects like thing, there the importance is very much. We can find the its importance. Then mapping the weeds. So weed mapping to have a it can be used for many purposes, for controlling the weeds, for data generation of the weeds, to have a record of the history of the weeds, how it is going to affect the things. So different applications are there. Depending upon the weed mapping, we can see why the weeds are concentrated on particular region, what was the reasons, how to avoid those things, or if you want to go for a spot spraying like that, that thing also be done. Okay, so you can generate the weed maps. And crop damage and insurance. So nowadays we are seeing adverse climatic situations are taking place. It may be due to a flood, or it may be because of a drought. Many persons are claiming, even though some of the farmers we have seen that crop damage agide anta claim ಮಾಡ್ತಾರೆ, ಅಥವಾ ಡ್ಯಾಮೇಜ್ ಆದರೂ ಕೂಡ the persons who are responsible, they may not visit their field. They are saying it is okay, or without visiting it can be done. But again there may be a problem that there may be a shortage of even people also who may not cover that much of area. So for that reason they are taking the help of the drone persons or drone technologists. They are surveying the area, they are estimating it. Sir?
Sir, whether these crop surveys now are being done by manual labor, State Department officers,
Yes.
whether this drone technique will help doing crop surveys?
Yes, sir, of course.
Especially perennial crop surveys.
Yes sir, it can be used.
And also another thing is that land survey in farmers' land is the major issue And many files have been kept as it is.
That's what, sir.
And it has been used, ಮಾಡಿದ್ದಾರೆ ಸರ್ ಲ್ಯಾಂಡ್ ಸರ್ವೆ ಏನಾದ್ರು.
Sir, land surveying ಗೆ ಕೆಲವು ಒಂದೆರಡು ಇದಾವೆ, agencies ಇದಾವೆ. They are doing with the help of drones.
Private agencies.
Yes, private agencies. And now the government is also interested. They are contacting them, they are making some MOUs like that. They are using those technologies also. Some yellow advocate cases are killed, sir. They have used the drones for giving the crop damage benefits also.
ಅದೇ ಸರ್ ಮೇಜರ್ ಕ್ರಾಪ್ ಸರ್ವೆ ಈಗ ಸ್ಟೇಟ್ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಅಲ್ಲಿ ಸಖತ್ ಪ್ರೆಷರ್ ಇದೆಯಲ್ಲ, ಇದ್ರದ್ದೇನು ಪ್ರಪೋಸಲ್
Again, it depends upon the administration level, sir. ಏನಾಗಿದೆ ಅಂತಂದ್ರೆ ಲಾಸ್ಟ್ ನಮ್ಗೆ ಹೇಳ್ತೀನಿ ಸರ್, ಎಷ್ಟೇ ಒಂದು ಐ ಥಿಂಕ್ 1-2 years ಬ್ಯಾಕ್ ಅನ್ಸುತ್ತೆ, ಇನ್ ಅವರ್ ರಾಯಚೂರು ಏರಿಯಾ ಆಲ್ಸೋ ದೇರ್ ವಾಸ್ ಎ ಫ್ಲಡ್. ಅಲ್ಲಿ ಮಹಾರಾಷ್ಟ್ರದಲ್ಲಿ ಮಳೆ ಜಾಸ್ತಿ ಆಗಿತ್ತು, ರಾಯಚೂರಲ್ಲಿ ಆಗಿತ್ತು. ಸೊ ದ ಡಿಸ್ಟ್ರಿಕ್ಟ್ ಅಡ್ಮಿನಿಸ್ಟ್ರೇಷನ್ ಹ್ಯಾಸ್ ಆಸ್ಕ್ಡ್ us to have an images and to have some survey of that particular area. ಇಲ್ಲಿ ನಮ್ದು ರಿವರ್ ಸುತ್ತಮುತ್ತ ಏನಿತ್ತಲ್ಲ, ಎಲ್ಲಿ ಫ್ಲಡ್ ಸಿಚುವೇಶನ್ ಆಗಿತ್ತು, ಎಷ್ಟು ಎಕ್ಸ್ಟೆಂಟ್ ವರೆಗೂ ಆಗಿತ್ತು ಅಂತ ಕೇಳಿದ್ರೆ ನಾವು ಒಂದು ರಿಪೋರ್ಟ್ ಮಾಡಿ ಕೊಟ್ಟಿದ್ದೀವಿ. So they have taken that as an base thing. But again, sir, that needs to be approved by the government level. ಅಲ್ಲಿವರೆಗೂ ಹೋಗಾಗುತ್ತೆ. But we can generate those reports.
ಯಾಕೆಂದ್ರೆ ಈಗ ಪ್ರತಿ ಸೀಸನ್ ಕಂಪಲ್ಷನ್ ಆಗಿದೆಯಲ್ಲ ಸರ್, ಕ್ರಾಪ್ ಇನ್ಶೂರೆನ್ಸ್ ಇದಕ್ಕೆಲ್ಲ ಮ್ಯಾಚ್ ಆಗ್ಬೇಕು. ಈಗ ಕಬ್ಬೆ ಇದೆಯಾ ಅಂತ ಕನ್ಫರ್ಮ್ ಮಾಡ್ಕೋಬೇಕು. ಮ್ಯಾನ್ಯಲಿ ಎರರ್ಸ್ ತುಂಬಾ ಇದೆ.
It's a very yes, sir. Manually errors ತುಂಬಾ ಇದೆ sir. They are unable to reach there. ಎಲ್ಲ practical
ಮತ್ತೆ
problems
ಬೋರ್ಡ್
ಇದೆ.
ಎಲ್ಲ ತಪ್ಪಾಗುತ್ತೆ. 12 ಬಾರಿ 2 3 ಇದೆ.
Yes, sir. Yes.
ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್
Even now, sir, you have started,
That can be rectified.
so in the event OD and other things like started. Discussions are going on.
Sir, time shortage ಇದೆನಾ?
ಇಲ್ಲ ನೋ ಪ್ರಾಬ್ಲಮ್ ಸರ್.
No problem, sir. ಇನ್ನು ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಇದೆ, ಅವ್ರಿಗೆ ಕೇಳಿದೆ.
ಇಲ್ಲ ನೋ ಪ್ರಾಬ್ಲಮ್.
ನೆಕ್ಸ್ಟ್ ಸರ್ದಿಲ್ಲ ಸರ್ ಇರೋದು.
ಆಫ್ಟರ್ 11:30 ಸರ್.
ಅಂದರೆ ಓಕೆ ಸರ್, 11:30 is okay. Okay. Then comes the livestock management. So in livestock management is also, right now we are not using in our Indian conditions, but in especially in European countries where and in some of the countries where they are using the very big herds, ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, for they can't take care of each individual animal. So there they are using this drone technology for monitoring the health ಇರ್ಬೋದು, number of herd, number of animals in the herd ಇರ್ಬೋದು, ಅಥವಾ their movement also they are monitoring. Even they are controlling their movements also. They are making the boundary also. So ಆ ಕಡೆ ಏನಾಗುತ್ತೆ, ಕೆಲವು ಟೈಮ್ if they are going out of their range means they will just send their drone, it will make a hissing sound there, then the animals will come back. So ಈ ಥರನೂ they are controlling their animals within that area. So this is just a simple workflow that I want to discuss, because again it depends upon the type of work what we are doing. So this is the basic general workflow which is required for mapping purposes. Again mapping ಮತ್ತು analysis and ಮಾಡಬೇಕಂತ ನಾವು ಅನ್ಕೊಂತ ಇರ್ತೀವಿ. So for that this is the general workflow. So in that it can be broadly made into different steps. One is the data acquisition, data preparation, image pre-processing or processing, then applying the deep learning algorithms for classification purposes, and after that we are going to evaluate it. And these things already many of you know, because the same thing we are working with our remote sensing technologies also. Other technology, ಅದರಲ್ಲಿ ಏನು ಡಿಫ್ರೆನ್ಸ್ ಇರಲ್ಲ. Only thing is we are getting a better image, we are getting a more high resolution images, that's all. But remaining thing is same. So in data acquisition, so of course we know we need to collect the data through any of the platforms which are earlier discussed. So our platform, we can collect the data, or we can use the data which is already available in the public platforms. It can be taken. So any kind of data can be used. Then we need to prepare the data so that whatever that there is something is required. If you want to improve the images, by image augmentation we can go. We can label the data with the ground truth data. So what has happened there? What is your region of interest? Where is the weed? Everything. It can be labeling. We can say it as a labeling. So ನಿಮ್ಗೆ ಯಾವ್ದು ರೀಜನ್ ಆಫ್ ಇಂಟ್ರೆಸ್ಟ್ ಇದೆ, ಆ ರೀಜನ್ ಆಫ್ ಇಂಟ್ರೆಸ್ಟಲ್ಲಿ ನೀವು ವಿ ಕ್ಯಾನ್ ಗೋ ಫಾರ್ ಡೇಟಾ ಲೇಬಲಿಂಗ್ ಲೈಕ್ ದಟ್. ಆ್ಯಂಡ್ ಟು ಸೂಟೇಬಲ್ ಫಾರ್ ಯುವರ್ ಮಾಡಲ್ಸ್, ಎಂಡ್ಗೆ ಏನಾಗುತ್ತೆ ಅಂದರೆ ಎಟ್ ದ ಎಂಡ್ ವಿ ನೀಡ್ ಟು ಗೋ ಫಾರ್ ಸಮ್ ಅಲ್ಗಾರಿದಮ್ಸ್. ಸೊ ಫಾರ್ ದ ಡೇಟಾ ವಿಚ್ ಇಸ್ ಸೂಟೇಬಲ್ ಫಾರ್ ದ ಅಲ್ಗಾರಿದಮ್ಸ್ ದಟ್ ನೀಡ್ಸ್ ಟು ಬಿ ಡನ್. ಸೊ ಅದಕ್ಕೆ ನಮಗೆ ಏನೇನು ಕನ್ವರ್ಷನ್ ಮಾಡಬೇಕಾಗಿತ್ತು, ಕಲರ್ ಕನ್ವರ್ಷನ್, ಯು ಕ್ಯಾನ್ ಗೋ ಫಾರ್ ಎ ಫಾಲ್ಸ್ ಕಲರ್ಸ್ ಕನ್ವರ್ಷನ್, or if you want to convert that into, or if you already having a RGB image, we can split into different layers. R ಬೇರೆ, G ಬೇರೆ, B ಬೇರೆ, ಎಲ್ಲರೂ ಬೇರೆ ಬೇರೆ ಲೇಯರ್ಸ್ ಅಲ್ಲಿ ನೀವು ಸಪ್ರೇಟ್ ಮಾಡ್ಕೋಬಹುದು. ಅಥವಾ ಬೇರೆ ಅಂತಂದ್ರೆ ಯು ಕ್ಯಾನ್ ಕ್ಲಬ್ ದಟ್ ಥಿಂಗ್. ಸೊ ವಾಟ್ ಎವರ್ ದ ಥಿಂಗ್ಸ್ ಯು ವಾಂಟ್ ಟು ಕನ್ವರ್ಟ್, ದಟ್ ಥಿಂಗ್ ಕ್ಯಾನ್ ಬಿ ಡನ್ ಇನ್ ದಿಸ್ ಡೇಟಾ ಪ್ರಿಪರೇಷನ್. So ultimately, once the data has been prepared, so the next is the image processing. What we are doing in image pre-processing, we can say in image pre-processing. So if there is any noises are there, that can be removed. So wherever the data missing is there, that can be interpolated or extrapolated, and the data can be managed. It can be done. Just it is a what we can say.
It's just like editing.
Yes, editing thing can be done because you should not give any false information for these algorithms. Because everything, whatever the output is there, that depends upon how best information we are providing for the algorithms, we will get that good output. If we are feeding it a waste, it will give waste only. That's why as far as possible, we need to minimize the errors or we need to minimize the things by using these different technologies.
So the image pre-processing in which platform we are doing, sir? Whether it is like RJS or like thing or it is separate?
There are, yes, madam,
Other.
there are different platforms are there, it can be used. Maximum ಆಗಿ ಅದರಲ್ಲಿ ನಾವು ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಅದರಲ್ಲೆಲ್ಲ ಆಪ್ಷನ್ಸ್ ಇದೆ. ಏನಾಗುತ್ತೆ? These whole thing can be done within one software also. And again, there are some softwares are there which are specifically meant for each and individual units. Then of course, in deep learning, so whatever data is there, that will be sent for these different algorithms that needs to be selected based upon our end output. So based upon the learning, based upon the computation ability, what we have developed, so we will be getting the outputs, and those outputs can be evaluated. So these are some of the sensors, so which we may be interested to know, because as I said, the drone is just a platform. Okay, so it is just a platform. It is going to fly in and around, and what kind of information you want that we are interested, we need to decide it. So based upon that, we need to fit those drones with different sensors. So depending upon the sensors, its accuracy, its type, we can get the maximum information out of it. So these are the simple sensors. What we can see, it may be temperature sensors. If you want to monitor the temperature, light sensors, humidity sensors. So n number of sensors are available. Only thing is we need to decide for what is the purpose of your data acquisition and what kind the suitable sensors needs to be fitted up. And this is the complete light spectrum. We can see right from the gamma rays to the radio waves. We are having the different wavelengths. Everything you people may be familiar. And this is the visible range from 400 nanometer to 700 nanometer. And over this 400 nanometer only, we are more interested for our agricultural applications. And remaining thing, I think many of you know how you can get the feedback from the that is the whenever we interact with the some object, so we are able to see it because of its reflection. So once we try to find out the reflection, so depending upon the intensity of the reflection, we are able to differentiate between those things. Otherwise, if the reflection value or the reflectance is the same, then we are unable to identify the difference between those. That's why in dark room we can't see anything, because the reflection is almost zero. Or we can see the things, but we are unable to identify what is that. Because everything, whatever the objects are there, they are reflecting the same intensity and same wavelength. That's why we are unable to differentiate. So that's why we need to select the sensors in such a manner that which intensity we want to receive and which is the wavelength of light that is going to interact with that object. That has to be decided earlier itself. It has to be, those sensors has to be used. So one of the sensors is the RGB sensor. So it's a simple sensor which we find even in our mobile cameras also. It's a camera sensor, that's all. So whatever the things we are getting, so we are normal photographs. So those are will be in RGB bands only. So these are very least expensive and most commonly used passive sensors. So passive sensors means there are two types of sensors already, active and passive. Passive means which is depends upon the other source of light. In active sensors, it is having its own source of illumination. So this is the commonly used for the commonly used sensor, RGB sensor. So usually it captures the visible light in the range of 400 to 700 nanometers with the red, green and blue channel, the blue bands. So these cameras, what we are using usually, it will be in the range of 3 to 12 megapixels. These pixels can be used. Of course, we can go for higher pixels, but again, if you increase the pixel, again it will be more costly. Then the ratios of signal strength in the 3 channels is used to calibrate the color of each pixel. So we are playing with the reflectance values of those channels. Based upon those only, we are going to generate the indices. So in normal, some of the education indices such as it may be green leaf index, that can be calibrated by using this RGB sensors. But much information can't be we are unable to get with this RGB sensors. So we need to go for some special sensors also. In that, another one is a broadband infrared sensor. Here, I think, but it is just a simple modifications we are doing for the existing RGB sensors only. Only one band filter will be fitted. Band pass filters just we are using those band pass filters or non pass filters so that only the NIR near infrared rays which is emitting or which is getting from the plant, we are able to capture those things. Remaining thing we are not interested. So only which range you are interested, that band pass filters can be used, and only those lights that the filter allows to pass away, that can be captured, and that images can be taken or the data can be taken. So these are one of the most cost-effective method. Instead of going for a dedicated multispectral or hyperspectral sensors, we can only use a simple filter, just an add-on for the existing RGB sensor. The work can be done. So this is the multispectral sensor where we are having more than 4 bands. 3 bands will be there in the RGB. So 4, 5, 6, 7, up to 10 bands. We can go for a multispectral sensor. So this is a multispectral sensors, so which we are using for the drones. So it is a coming from a company known as Mikasense sensor, which is having a 5 bands. So RGB is there, and apart from RGB, one band will be red edge at the end of the red band. Then another one is the NIR. So we are having this facility, we are having this sensor, and we are using this for getting the crop information. Maybe in the afternoon session, we can see whatever the data we have collected from the RGB sensor. And whatever the images are there, so those will be stacked in this band. So this is the individual. What is the R band, red band, next wavelength band, next band, next band. So the whatever the reflectance values, for example, say there is a range of 700 to 800. You are interested only in 750, 850, 950 or something. So only 850 value plus or minus some bandwidth will be there. Only that reflectance value will be captured and it will be measured and entered into the pixel values. Aste band. This band is aste value. Only this information will be giving the reflectance values of only red. This will be giving only blue. Ether, whatever the region of interest is there, will be there. Here you can see this is the how the responses or the reflectance values are there in different bands. But here the issue is whatever the data we are getting, it will be in a discrete form, not a continuous form. We will be getting 750, 850. But if you want 800, we are not having it. It may be less or it may be more. We don't know. We can interpolate it, but it may not be highly accurate. So whatever data we are getting, it is a completely discrete one. So if you worked out to identify the things. So that's why the next is the hyperspectral we are seeing. Of course, after hyperspectral, next thing is there. That is the ultra. But we are not going up to there. Hyperspectral. So this is also where we can expect the continuous data. We can see here. So the reflectance value is a continuous one. Okay. So we can say it is a just like what we are getting in a digital platform. Okay. Then we can see there we are easily identifying the different stacks. So here there are no stacks. Is the data whatever is there, it is continuous. You can split it. And here the bands what we are getting, it may be in terms of hundreds of bands. Earlier we used to go for only 4 to 10 bands. Here we can get up to hundreds of bands and up to 200, 300, 500 of bands. Yes, sir, it is different. For if you want to measure for the temperature related things, then you can go for the thermal sensors. Thermal sensors are there, which is only captured. So again, we can't say this is the best for this crop health. Again, crop health means what you are targeting. Whether you are interested in identifying some pest infestation, or you are interested in identifying some nutrients deficiency. So because those are having their unique signatures. So based upon those signatures, so initial study has to be done. Then we need to identify the uniqueness there. So once you identify the uniqueness, so because everything is having their own signatures. So once you identify that, which is having the peak or some changes are there, that wavelength needs to be identified, sir. And only we can target that. We need to capture the data, we need to see the ground truth, we need to correlate these things. Wherever we are getting the maximum correlation, that can be taken care of. So for your question, this is the answer, sir. What you have asked. So this is just a review what we have collected. So for example, for identifying the weeds in a wheat. So in a wheat system, so this spectrum is that reflectance value you can see 720 to 850 wavelength. It is having a reflectance value of 0.4 to 0.45 R range level. So we can say that if the plant is reflecting that wavelength in that range, means we can say that is a weed. Sorry, a weed. So apart from that, it may be something else. What is something else? Again, it depends. If you want to concentrate on the broad-leaved weeds, so this is the range. So we need to identify this one. Based after identifying, you can use the different sensors or different filters, and you can concentrate on only particular wavelength. Hyperspectral actor, it is having a very wide range. There we can study the, if you want to have what is happening with 720, what is happening with 750, 800, 850, 900, 950. We need to go for hyperspectral for research purpose. Once the thing is established, the technology has been developed, everything means only we can concentrate on a particular wavelength. Band elation of the
To identify that particular wavelength, is it like coded with algorithms in order to keep it so that if you give the image, the algorithm is such a way
no, that we need to do.
that we have
That
to
we know to. That is the where the research we need to do.
expertise.
But of course, these again going for the review, it will give you an idea. Review will see it. We need to do those things. So what he was asking, that is regarding thermal sensors. So these are sensors which is going to capture the heat signals. So within the range of 7.5 to 13 micrometer wavelengths. So difference in the temperatures that can be identified, it can be mapped. So usually this can be used for livestock monitoring or for moisture content in the fields. So those things can be done. Another one is the LIDAR. So this LIDAR technology, which is used for mapping the surfaces. So if you want to even the precise level is very much even in terms of centimeter, variations in centimeters can be measured. So here easily we can monitor the height of the plants, or if you want to go for some many unique characteristics of the plants, whether it is the phenotyping, we can do by using these kinds of technologies. And of course, based upon whatever the data we are getting, we need to develop some of the indices. So just I have shown on everywhere, how many of you people may know what is everywhere. So just to know which is the green crop or non-green crop that can be identified, or healthy or stress crop based upon this formula, and the reflectance values what we are getting through that thing, that can be. So it is analyzed as a have a elevation modeling. So if you want to have the elevation, ground elevation in industrial bedroom, if you want to have the knowledge of those things. That's for visual inspection of the crops in the field, to have a photographs, to have identify something, anything is happening. You know, if there is any crop or the plants are missing in some area. So whatever the, you can say the general scouting can be done using these kinds of RGB sensors, RGB bands. Then in NIR bands also, where it can be used for water management, erosion analysis. So you can count the number of plants also. Then soil moisture analysis, crop health assessments. So which is very suitable for in that NIR band range that can be done. Then in a red edge band, so red edge band, there we can go for a water management, crop health assessment. So this is very where we are more interested in the red edge. Then thermal infrareds or irrigation scheduling for analyzing soil moisture content and for analyzing the plant physiology and yield forecasting. So like that we can use the thermal infrared. So this is what broadband, these are the broadbands. Then the multispectral, we can having around 4 to 10 bands. And in hyperspectral, hundreds of bands will be there. Now the technology is there with the satellites, we are getting this one, ultraspectral, where thousands of bands can be, data can be captured. So this is just an example for soil and field analysis, so whatever the data we are getting. So drones can be used for field analysis, especially for the nutrient management. So generally what the research is going on is that is nutrient management, they are more concentrating on the nitrogen management. So for that purpose they are already using it, and even apart from that we can go for NS field surveying also, what is the shape of the field, slope of the field, land use. So those patterns can also be identified by using this analysis. And in seeding, planting, already some of the things I already discussed in the previous slides only. So these are the special things we need to think. So we can say, as I said, a separate unit that needs to be done. So this is the for planting the forestry trees, where it is having a unit which is already having some pre-available nutrients, some media is already filled with that bullet or capsule, we can say, in the capsule, and that capsule will be shooted from the top so that it enter into the soil with some force. So already these things we can say it is a seed bombing, and we call them as a seed bombing. So already in many of these states also they have done the seed bombing. In Chhattisgarh they have taken, in Telangana also they have taken the seed bombing for forestry purposes, not for the our agriculture lands.
Seed ball can also be used.
Yes, madam. Any kind of media.
Seed ball.
Seed balls they are using. Yes, sir. Yes, madam. Other use ಮಾಡ್ತಾರೆ. Only thing is we need to see that it has to survive that hit. ಒಂಥರ ಅದನ್ನೆಲ್ಲ ಇಂಪ್ಯಾಕ್ಟ್ ಏನಾಗುತ್ತಲ್ಲ ಅದನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡೋದು ಏನಾದರೂ ಮಾಡಬೇಕು. And regarding the crop monitoring, as I said, we can see different types of applications are there. Either it may be a pest surveillance, it may be a disease surveillance, it may be a if you want to see the assessment of the seedling emergence, whether emergence has been taken place or not, what is the growth of the crop canopy or the biomass generation. So everything can be monitored and managed by using this drone technology. So this is one example where the diseases and the pest induced in the tea plantations is taken a case study for that. So it can be identified there. So here soil, which is wherever the red color is showing the soil, and this is the yellowish and orange color. You can say the disease stress is there, something stress is there, and in the green part there is the no stress is there. So these kinds of identification can be done, and it can proper appropriate steps can be taken. Then this is the here the maturity level can also be identified. So when to harvest the tea. So just because the tea estates will be in the larger area, and again it is very difficult to move into it. So just by flying a drone, we can say, so wherever the tea is more ready for harvesting. So it can identify, we can send the laborers to there, or some mechanization is there, it can be sent there, and the harvesting can be done. So this is the product study the paddy fields. So you can identify, so everything is okay, but these are some of the regions where the plant is not. So what are the reasons are there? That we can go to the ground level, we can take a note of. Used by identified by using the drone technologies. And as I said, in case of the water management also, just by flying it, we can see what is the so which are the areas are there where the moisture is less or moisture stress is there, that can be identified, and we can have a uniform. We can see whether the uniform distribution of the water is taking place or not. Those things can also be done. In weed mapping, so for mapping the weeds, so these are the things. So of course, complete the crop is there. So after processing the thing, we can only able to identify the weed patches. So if we feed these kinds of data into the drone for application of the weedicides, so only the precise applications will be there, or we can say the target applications can be performed. This is the crop damage and insurance. Already I have discussed about this one. Just by surveying purposes, we can see how much area is got affected, what is the extent is there, how much flood has happened. So everything can be estimated just by monitoring the things. So even by taking these groups, even the farmers can take some legal actions also. They can claim their whatever the things are there. That, what can I say? The insurance claims that can be easily claimed. So you will have the proof. In livestock management, as I said, we can count, we can have a monitor the number of animals within their reach, and they can have their own boundary, and also you can see they can measure the animal body just by if there is any variations in the body temperature of the animal, they can identify. So on 10, 20, 50 we can manually we can manage, but they are having in terms of thousands of animals will be there. So again they are unable to identify which is healthy animal, which is not healthy. So just by flying a drone with a thermal sensor, they can identify the body temperatures. So those temperatures can be identified. Some lesions will be there. So those things can be identified, and we can proper care can be maintenance can be done for those particular animals. Even some of the farmers they are using for sheep rearing, where they are trying to identify the quantity of the wool that is already that has grown on the sheep. So adr mele harvesting madake wool na idu madake use ಮಾಡ್ತಾರೆ. And of course the chemical spraying already this is the where we are more interested, and we are doing these things for applications of maybe for herbicides or pesticides and some even fertilizers also. Those things can be done, but here as we are seeing, it is not as simple as we thought. Simple again, normal spraying use madakagala. It should have some its own protocols. It should have their own parameters. That's why the SOPs needs to be developed, and we need to standardize the different operational parameters. So what I'm saying is optimization of operational parameters needs to be optimized for individual crops. So as a whole blanket, we can't give this one. And even for we have seen that for a particular crop also, at different stages are going to affected by this drone. So that's why even at least on the very critical stages now recommendations. So these are some of the comparisons between the conventional and drone spraying. So of course the conventional spraying, which is a labor is time consuming and less efficient, that is there. And here the important thing is, one of the main important thing is the hazards which is going to happen for the operator, that can be completely avoided. Physically the person has to go there, even though there is, as per the government, there is a standard rule that he has to wear the protective clothing. But yaru practice madala, it is very rare. Even they are not wearing the masks also. So adana inhale ಮಾಡ್ಕೊತಾರೆ, and they are having, it is causing some hazards to the person. So when we are using this kinds of technology, we can completely avoid those accidents. Again it will be a legal process. ಅವನಿಗೇನೋ ಮಾಡ್ಕೊಂಡಿರ್ತಾನೆ, again it will come to the owners, ಅವನ ಮೇಲೆ ಬೀಳುತ್ತೆ. He is saying that ನಾನು ಹೇಳಿದ್ದೆ ಮಾಡಿಲ್ಲ. Already we have seen these legal procedures already. Those things can be avoided. Okay. So again, even this is one of the important things, is the less water consumption. So here the liters per acre is also very less. So what we have seen, we have found out that for 1 acre, around 15 to 20 liters of water is sufficient. Of course, in commercial, whatever the commercial people are there who are doing this spraying operations, they are completing or they are covering 1 acre within 10 liters. But we have tried that one also. We have found suitable for 1 acre of area, it should be at least 15 to 20 liters of water. See, we are taking back from 200 liters per acre, 150 to 200 liters per acre to 15 to 20 liters. Means we are saving around 10 times of the water. So because water is one of the important resources nowadays. So this is the some of the status of the US Raichur, that we are having these kinds of drones. That is one 5-liter drone is there. We have started in 2018 with 1 liter capacity drone. Later on we have developed a 5-liter. And as per the farmers' demand, because the farmers were giving a feedback as that at least they should have the capacity of a knapsack sprayer, 20 liters, 50 liters, 20 liters. Then we have developed one 20-liter drone, which is an autonomous one, because as the drone size increases, it is very difficult to operate manually. It has to be applied autonomous mode only. So that's why it was made an autonomous. But again, some issues has been we came across. That is because of the heavy payload. Whatever the first generation was there, it was very high. So because of first generation, we observed some crop damages. So that's why now we can see that we have shifted from 20 liter to again back to 10 liter. So in recently only after 2020 only the 10 liters drone has came into existence. ಮುಂಚೆ ಅಷ್ಟು 10 ಲೀಟರ್ ಯೂಸ್ ಮಾಡ್ತಾ ಇರಲಿಲ್ಲ, ಓನ್ಲಿ 5 ಲೀಟರ್ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ರು. ಅದನ್ನ ಬಿಟ್ಟು 5 ಲೀಟರ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಇತ್ತು, 20 ಲೀಟರ್ನೇ ನಾವು ಫಸ್ಟ್ ಪೀಸ್ ನಮ್ಮ ಕಷ್ಟ. Then we are having a drone with the multispectral imaging system. So a supply system is there, which it is again it requires some high precise drone, which is costing we are having, which is costing around 25 lakhs. Then the drone with RGB sensor we are also having that. See, what I'm saying, the operational parameters. So these are the important operational parameters. One has to optimize, and these things has to be noted while performing the field operation as a researcher actually. So that is the height of spray plays a very important role, because if we vary the height of the spray, then it is having the effect on the spray distribution, it is having the effect on the crop damage also, and also it is having the effect on the area coverage and application rate. So almost all parameters gets affected if you vary this height of spray. This is very important. And next comes the forward speed. So for forward speed is very important in terms of uniform coverage. So whatever the spray droplets are there, if you want to cover it uniformly, then we need to optimize or we need to recommend some forward speed for it. Then operational pressure, nozzle discharge rate, nozzle type. So these are the pressure, these are the things, operational parameters related to the nozzles. It can be optimized earlier, or it can flying conditions it can be optimized for normal sprayer. Then those are the things that needs to be measured. That is what should be our application rate, what should be the droplet size, because the droplet size will be very fine. We can get from 200 microns to 300 or 400 microns. First variations are there. Then density even in the underside of the leaf. Actually, we can find more droplets in the under leaf compared to top leaf because of the air thrust. So there is a lot of shaking of the leaves. So shake agadilla, even the underside is covered very uniform. Then spray drift. So when we talk about the aerial spraying, so spray drift is the first thing that comes into our mind. But since we are dealing with the usually we will get confused with the aerial spraying and drone spraying. In aerial spraying, in earlier thing, what we are doing, we are using the aeroplanes, which is going to fly around very height, 100 feet ಮೇಲೆ ನಿಂತ spray ಮಾಡ್ಕೊಂಡು ಹೋಗ್ತಾ ಇತ್ತು. Under those situations, the droplets used to drift. ಅಲ್ಲಿ ಆಗ್ತಾ ಇತ್ತು. But ಇದರಲ್ಲಿ ಏನಿದೆ, of course the drift will be there, but what we have seen that at optimized parameters, the drift is not more than 3 meters. Within 3 meters only, the drift is happening. And this 3 meter of drift, even it happens with the normal sprayers also. More than 3 meters ಇರುತ್ತೆ. Especially when you go for the power sprayer, ಅಲ್ಲಿ ಇನ್ನೂ ಜಾಸ್ತಿ ಬರ್ತದೆ.
What's the height of spray, sir? 3 meters?
For 3 meter ಬಂದಿದೆ, the height of spray was around 1.6. Usually ಏನಿದೆ, the parameters has been optimized from 1.5 to 2 meters height of spray. Range.
It changes with the crops also.
Yes, it changes with the crop and crop stage also. So these are some of the demonstrations we have conducted in the last year. So this is the drone sprayer in the paddy crop we have fitted and evaluated. And detailed data will be presented by KSNUAHS, so he is going to discuss the things. So just I am showing the glance. Then go values ಎಲ್ಲ ಸರಿ ಇರುತ್ತೆ ನೋಡಿ. I think this is good one or two.
ಇಲ್ಲಿ no problem. Feedback ಇದೆ.
So this is the 20-liter drone, what I am talking about. So this was a 20-liter drone, so which was used for cotton. And this is the parameter which has been used for that operation. So you can see the operational speed was around 2 meters per second, and the height of spray was kept around 1.5 meter. Then we can see the droplet sizes was around 240 microns. Droplet density was around 67 number of droplets per centimeter square. And whatever the uniformity of the droplets you got is around 1.43. So this uniformity of the droplet should be near to 1. So we achieved 1.43. And the cost of operation was getting around 1700 rupees per hectare. And again it is going to change depending upon the crop and depending upon those parameters.
Droplets is per centimeter square.
Sir?
Uniformity of droplets.
Uniformity of?
What is the unit? That's 1.43.
Sir, that is a ratio. Ratio between VMD by NMD.
NMD, okay.
So the time required 0.47 means it is 47 minutes or time required to cover 1 hectare area. Number 50.
Sir, hours, sir, in terms of hours.
0.47 hours.
In terms of hours per
It is 47 minutes.
No, sir, 47 minutes per number, 60 years per 60 years.
Percent of
47%.
So spray volume.
Sorry?
Spray volume.
Spray volume application rate 80 liters per hectare. ನಾನು ಮತ್ತೆ ನಾನು ಅದನ್ನ ಹೇಳಿದ್ರೆ ರಿಪೀಟ್ ಆಗೋದಕ್ಕೋಸ್ಕರ ನಾನು ಕವರ್ ಮಾಡಿಲ್ಲ ಸರ್, ಕವರ್ ಮಾಡ್ತಾರೆ.
Location specific.
Yes, sir. So this is what we have done in the chili crop also. So whatever the major crops are there, and moreover in the last year, even the farmers are approaching us because they are unable to get into the field for spraying purposes. ಹೊರಗಡೆ ಹೋಗಿ ಸ್ಪ್ರೇ ಮಾಡೋದು ಕಷ್ಟ ಆಗ್ತಾ ಇದೆ. They are approaching us. They are more interested to adopt for this drone technology or for drone spray. So again, this is the data for the groundnut crop. Similar data is there for chickpea. And this is the field evaluation what we have done. So these are the droplet sizes what we have measured in the field conditions. So we are using this water sensitive papers which will be kept on top and the bottom of the leaf, and we have taken the observations for these kinds of things.
So is that uniform, sir? because at the top usually the more droplets will be.
That's what, madam. What we have observed in this drone sprayer is we are covering more in the underleaf compared to top. Underleaf alle ಜಾಸ್ತಿ ಕವರ್ ಆಗ್ತಾ ಇದೆ. At least ಆನ್ ಪರ್ ಅಂತೂ ಮಿನಿಮಮ್ ಇದ್ದೇ ಇರುತ್ತೆ, ಕಡಿಮೆ ಅಂತ ಆಗಲ್ಲ, ಜಾಸ್ತಿ ಆಗುತ್ತೆ ಹೊರತು ಕಡಿಮೆ ಆಗುತ್ತೆ. ಬಿಕಾಸ್ ನಮ್ಮ ಜನರಲ್ ಮೈಂಡ್ ಸೆಟ್ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಮೇಲ್ಗಡೆ ಹೋದ್ರೆ ಬರೀ ಮೇಲಷ್ಟೇ ಕವರ್ ಆಗುತ್ತೆ ಅನ್ಸುತ್ತೆ, ಬಟ್ ಅದು ಏನು ಏರ್ ಥ್ರಸ್ಟ್ ಬರುತ್ತಲ್ಲ, ಸೊ ಬಿಕಾಸ್ ಆಫ್ ಏರ್ ಥ್ರಸ್ಟ್ ಸೊ ಲೀವ್ಸ್ ಭಾಳ ಉಲ್ಟಾ ಆಗುತ್ತೆ, ಉಲ್ಟಾನೇ ಆಗಿರುತ್ತೆ, ಅದು ಮೇಲ್ಗಡೆ ಕೆಳಗೆ ಇರುತ್ತೆ, ಅಲ್ಲಿ ಸ್ಪ್ರೇ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. So these are some of the activities which has been conducted in the fields. We have already collaborations with some of the chemical companies also, so agrochemical companies. So this is a small comparison with which has been done with the farmers' practice. So we can say, so more area can be covered. That is in 2 to 2.5 hectares area per hour can be covered, which is compared to very less for the case of manual spraying, and even with the tractor operated sprayer having the booms. This is a boom sprayer. So if we are, even though we are having a booms of around 15 to 20 feet length, there also we are getting the lesser area coverage compared to drone. And as I talking about the savings in time, so 86% of the time can be saved, and compared to knapsack sprayer, and 72% can be saved with respect to the tractor. And this is the main thing. So it decreases the human drudgery and the human contact with the chemicals. So this is the major advantage what we can see. Okay, so these are some of the current activities we are doing at USRH. That is, we are going for SOPs for some of the crops which has been identified, and we are also going for a nutrient application through foliar spray studies also going on. Then herbicide applications for paddy we have done. Then we have changed the chemical dosage level. We want to check the effect of the chemical dosage at different dosages as per the recommendations. Already we have done that one also. It may be discussed by sir. Then some site-specific crop management and monitoring system. Since we are having the facility of the multispectral system, so we have also started the research for crop management purposes. In that we have started for studying the identification of the weeds and to predict the yield of the crop also. So by taking the images at different stages of the crop, we can whether we are trying to predict what will be the yield of it particular. So these are some of the benefits. Already I think it may have been covered in general class covered material also.
Sir, any impact study on the environmental issues?
ಮೇಡಮ್ ಇನ್ನೂ ಆ ಲೆವೆಲಲ್ಲಿ ಇದು ಮಾಡ್ತಾ ಇಲ್ಲ, ಬಟ್ ವಿ ಹ್ಯಾವ್ ಸೀನ್ ಸಮ್ ಆಫ್ ದ ಸ್ಟಡೀಸ್ ಹ್ಯಾಸ್ ಬಿನ್ ಡನ್. ಕೆಲವು ಡೇಟಾ ಇದಾವೆ, ಸೊ ಐ ಥಿಂಕ್ ಸರ್ ವಿಲ್ ಡಿಸ್ಕಸ್ ಅಬೌಟ್ ದೋಸ್ ಥಿಂಗ್ಸ್. ಸರ್ ವಿಲ್ ಬಿ ಡಿಸ್ಕಸಿಂಗ್. ಅದನ್ನು ಸ್ವಲ್ಪ ಡೇಟಾ ತೊಗೊಂಡಿದ್ದೀವಿ, ಅದನ್ನು ಸರ್ ಡಿಸ್ಕಸ್. So these are some of the benefits. As I said, it reduces the labor, human drudgery, that is important, because labor is not available to do these operations. Even they are available, their demands are more. ಅದು ಎತ್ತಕ್ಕಾಗಲ್ಲ, ವಜ್ಜಿಯಾರ ಹಾಕೊಂಡು ಓಡಾಡಬೇಕು, ಎಲ್ಲ ಇರುತ್ತೆ. So those things can be avoided now. It can be avoided, and for automation of the field operation can be done. And this is the most important. That is, we can reduce more occupational health hazards, and then it attracts the youth towards agriculture. So this is one of the attraction points. If you give something fancy things in their hands, if they are more attracted, they may involve in these agriculture activities also. And women empowerment, because it does not require any special what you can say, special requirements are not there. So any person can be operated. So we can say it is gender friendly also. But again, of course, there is some bottlenecks and limitations will be there. For any technology, it will be there. It is also there. Some of the technology, some of the limitations has been addressed, and it is some of them are still we are in the form of addressing. So first is the flight time endurance. So we are talking about that one. There is a major thing, because since we are dealing with the multi-rotor drones, so endurance is a major issue. So we are saying that with one set of battery we can fly up to 15 minutes. Okay, initially we can fly it, but later on it will be coming up to only 5 minutes. So that is an issue. It is there, and a lot of research is going on in that way also. Shortly, we can improve that condition also. Then initial cost, of course. So when we purchased that one initial earlier, it was purchased around 18 lakhs. So now it has been reduced. What I am saying is we can develop or we can purchase the drone with 3 lakhs also. Even with 3 lakhs we can purchase it, but again depending upon its capability, depending upon it may not be registered. Just like a mobile phone can be bought at 5,000 rupees also, 5 lakh rupees also. In similar fashion, depending upon our requirement, the rates of the drones are there. And connectivity, earlier the connectivity was an issue, even though when we go for the field, if it does not connect with the required number of satellites, then we are unable to fly it. That is also an issue. And of course, weather dependent, it can't be operated in very harsh weather conditions. It may be a rains or it may be a heavy winds are there, then it is very difficult to manage things. And a skilled operator, that is then a pilot is required for the operation. ಮುಂಚೆ ಏನಿತ್ತು ಸ್ಕಿಲ್ ಇದೆ ಜಸ್ಟ್ ನಾವು ಟ್ರೈನಿಂಗ್ ಕೊಟ್ಟು ನಾವು ಡಿಪ್ಲಾಯ್ ಮಾಡಬಹುದಾಗಿತ್ತು, ಬಟ್ ಸಿನ್ಸ್ ನಾವು ದ DGC is saying that for small category and above we require a license quality, so a license quality is a must for operations. And rules and laws, so of course in 2021 they have been done, but still lots of amendments are required, and every year the new amendments are coming. And in our Indian conditions, we very lack with some research data which is available, which reviews we can get for the foreign countries, but for Indian conditions it is very difficult, and still a lot of work is going on. Repair and service is a major issue. So this is what everyone is facing, even we also faced. Because the components of the drones is very costly. Even a small damage cost me lakh rupees. ಒಂದು ಸುಮ್ಮನೆ ಫ್ಲೈ ಮಾಡ್ತಾ ಇದ್ದೀವಿ, ಮೇಲಿಂದ ಕೆಳಗೆ ಬಿತ್ತಂತಂದ್ರೆ 2 ಲಕ್ಷ ರೂಪಾಯಿ ಅನ್ಕೋಬೇಕು ಅಷ್ಟೇ. So from where we need to meet out the 2 lakhs. So that was the difficulty what we have faced. But ಈಗ ಏನಾಗ್ತಾ ಇದೆ, even though we are ready to spend, then also we are unable to get the parts also. That is an issue. So ಅದಕ್ಕೆ ಹೇಳ್ತಾ ಇದ್ದೀನಿ, when we are purchasing the drones, we need to first see the repairs and service facilities. That too in ರಾಯಚೂರು ಪ್ಲೇಸ್ ಅಲ್ಲಿ ಇದ್ರೆ ಸ್ವಲ್ಪ ಸಣ್ಣ ಮಾಡಿಫಿಕೇಶನ್ ಸಣ್ಣದಾದ್ರೂ we need to run to Bangalore. ಅಲ್ಲಿಗೆ ಒಂದು ವೆಹಿಕಲ್ ತೊಗೊಂಡು ಬಂದ್ಬಿಡ್ತೀವಿ, ಒಂದು 2-3 days ಅಲ್ಲೇ ಹೋಗ್ಬಿಡ್ತಾವೆ. That is an issue. So of course this is the feature scope. So of course there is an improvement in the drone technology in terms of sensors, in terms of automations, in terms of parts availability, development in the indigenous form. Those things are going on. And as I said, many startups and even the big investors like Reliance, Tata's, they are also started investing in the drone technologies. They also put their leg in this field. And because of that, because of commercialization, even we can see further reduction in the cost of the drones. And flight and range of operation may be increased in future. And the use of drones will grow significantly in farming as they offer as you see a very wide range of applications. Even in agricultural, we can find many number of applications. So this is the financial assistance or you can say the support from the government we are getting. So many of you may know that this is the Rishi drone, where we up to 10 lakhs for the institutions, for government institutions, the government is providing the amount for the demonstration purposes. Up to 10 lakhs they are providing it for the purchase and the demonstrations of the drones. And for FPOs up to 75% they are providing. And for an agricultural graduate, I think they will be providing around just to 40% or something, 50%, 40% is there. Yes, 50% they are providing. They are providing 50% for agricultural graduates. So like that they are assisting for the development of this technology. And even though some of the agencies are interested for not purchasing the tractor, purchasing the drone, they are assisting. They are giving around 6,000 rupees per acre of the contingency for the demonstrations. So this is all about this topic. So anything is there?
Any questions?
What is the difference between like the satellite image and the drone image? Both are same.
No.
False color composite.
False color composite. Actually, I will discuss those things in detail in next session. But just to give an idea, there will be in the image there will be no color. Whatever the image it is taking, it will be a grayscale image. Only the digital numbers will be there. Only it is a grayscale image. So just for our understanding purpose, we are giving some color for it. Yes. there is the difference will be not in terms of color, but there will be a difference in terms of resolution, information, amount of information what that has been having in each pixel. That will be changed. We will be getting more precise in case of the aerial photography through drones.
If no more questions, so I thank Mr. Sunil Sherwal for excellent presentation with related to the drones in agriculture and its applications in a different fields, how we can able to utilize this drones as one of the major component for getting or increasing the according to him the smart sustainable agriculture, what he is saying. Really now in future we are looking forward for the smart sustainable agriculture. So sir will also be with us for the afternoon sessions. So now I am not going to give a vote of thanks in the afternoon session. After completion, I give a vote of thanks to him. So afternoon session is giving the talk on particularly this effect of drone mapping and the development of vegetation indices for the crop management. So he's presenting. So for this class, so yesterday we are into the basics of the drone parts and the engineering parts. So today's onwards, there will be most of application parts. Okay. So day 3 for this class. So from morning onwards, sir was also interested. So for this class, Dr. S. Patel, who is a Dean PGS, so he was there for this session. So sir, for this 10 days training program here with us during the migration time, also for the lecture schedule. So once again, I welcome you for this training, sir. So we have our Dr. A.J. Srinivas also. So Dr. Sharanappa will introduce. We'll take a quick break of 5 minutes. Your tea break is ready, so you can have it. And immediately, now in my watch it is 11:31. So we'll reassemble at 11:40. Okay, I'll take 8 minutes. Then beautiful lecture after the tea session. Thank you.
welcome Dr. A.G. Srinivas sir, who is serving as professor and head Department of Entomology, College of Agriculture, UAS Raichur. Sir did his undergraduate, postgraduate and PhD from UAS Dharwad, and in PhD he received the gold medal for securing highest marks. And sir completed 2 postdocs. One is at CIMIT and another one is at UK. Sir started his career in the year 1999 as an assistant professor, and he is having 22 years of rich experience, 24 years of rich experience in teaching, research and extension. If I read his biodata, it may take another 45 minutes to shortcut. So sir has actually involved in teaching. He received many awards, more than 17 awards he received. I am giving 2 or 3 very important awards what he received. One is last year he received Best Teacher Award from University of Agricultural Sciences, Raichur. And he received Best Teacher Award, Best Researcher Award, and Vasantraj David Award, one of the eminent scientist. He received Azra Eminent Scientist Award, and Young Scientist Award from NASA, and Eminent Scientist Award from NASA, that is National Environmental Science Academy, New Delhi. He received many awards, and he received many Best Poster Presentation Awards and Oral Presentation Awards at national and international awards he received. He visited many countries and mainly involved in pest management and also IRM, insecticide resistance management. His approach is farmers oriented. He always think about the farmers, what the farmers are facing and how to mitigate or reduce the problems associated with the pest management. Sir guided 14 MSc students and 5 PhD students. He published more than a century research papers in national and international journals. And sir visited many countries, and now he is heading the department, and he's made a department such a wonderful. And if you have a chance to visit the UAS Raichur, kindly visit the department. With this brief introduction, I welcome once again to Dr. A.G. Srinivas sir to deliver a talk on plant protection equipments. Sir, welcome.
Okay, thank you, Sharanam. Thank you very much for the brief introduction. So, Ellarigu Namaskara and good morning once again. So, I thank Naveen as well as Deshmukh for providing this opportunity. In fact, I was not knowing the Naveen also. So, the moment he called me, like, I accepted readily because some experiences which I have done it in the practically application of drone technology in the paddy and cotton ecosystem, so that I can share it to you people, like this is a kind of new technology which is a need of the hour, which I thought so that I can share it to you guys so that it will let it spread it, and also what our university is doing it as a prime institution to take drone technology, particularly in Karnataka, maybe South in general. So that is a kind of unique work which we have done it in the drone technology as such. In fact, I should thank my Agriculture Engineering College, the institute also, because they gave me the opportunity to work as an entomologist, as an applied the side of it. So the credit goes to the Dr. Viren Gowda and of course Sunil and my classmate Sushilendra. So they gave me opportunity. Otherwise, I would not have ventured into, I would not have known about even the drone, the meaning of drone itself. So that is actually the opportunity which came to me. Fine. So with this, I thought this lecture is a bit basic information, but since this group is an heterogeneous mass, comprising of entomology, pathology, agronomy, so many, plus including the industry people, maybe for my colleagues, my guys in the UAS system, it's a repetition. But for others, probably it is a refreshing information. I don't say that it is a new information, at least it's a refreshing information I thought of. Why exactly we are into now the drone technology, for which I need to tell this. the plant protection equipments. Right, so the challenges in agriculture is much more, and the climate change is a buzzword, isn't it? And of course, it's an inevitable event which is going to happen, and we are endorsing. Last year it was a complete drought, at least in Karnataka. This year it's okay. What will happen in next month also, we don't know, isn't it? So that is the situation. So much uncertainties, and our prediction levels are not so much accurate in terms of weather. Leave aside the pest and disease. Leave aside the pest and disease forecasting. Of course, I have put in 25 years of experience, but to my knowledge, we do not have right now the very best proven the pest prediction forecasting models. So at least except the locust, but other things are, I think, in the cold storage only, right? So that way, barring the climate change or other effect in the agriculture, we need to produce more and more. Our productivity has to increase, isn't it? So, of course, when it comes to the plant protection per se, even now also, even today also, we are talking of so many things, so many technologies, so many things, IBM, that, this, everything. But still, the pesticides are the dominating ones. Pesticides are the dominating ones. Probably the way in which we are progressing, probably still more years the pesticides are going to dominate. Maybe we have come down from red symbol to blue symbol, or even to some extent to the green symbol. But symbol is there, na? Symbol is symbol only, isn't it? Toxic is toxic only. I cannot say that red is very dangerous and blue is moderately, but the fellow is dangerous now, but it may take some time to kill me. Like red may take 1 minute, this fellow may take 5 minutes, but it will take away the life, na? So that is the problem. The pesticide and the chemicals are chemicals only. So but still, so what is required is that pesticides are the inevitable tools without which the pest management is incomplete, and we can't go ahead also, I'm sure. I'll give my practical experiences when I go through these slides and other things later part. So what is required is, though pesticides are inevitable, but how best we can reduce in terms of formulations, in terms of application technology. So that's the need of the hour. So I'll go back to this one. Of course, you can just look at, even now also, the BT technology, almost it is 22 years have been completed. We are entering in 23rd year. 2002, the BT technology, BT cotton came. 24, it is almost 22 years past, isn't it? But still, the amount of pesticide is going to the cotton is still number one. Still number one. Earlier it was 55, which I have written there, it is 50%. Now it has come to 30%. But still, it's number one. That fellow is not leaving its number one position because of the pest problem. Okay. So then followed by the vegetables. Of course, to name vegetables, the brinjal and the chili. People are so fancy. I should not say this word actually. The people are ignorant, and the farmers are so much, so much the pesticide they use it. Particularly if you take in my Raichur region, for 1 acre of chili, they spend almost 1.5 lakh. The total cost of cultivation is 1.5 lakh, out of which 60% is the pesticide cost. Then imagine, if you just take the chili, probably from small fruit to till it matures, it may be there almost for 3 months, or at least 2+ months. If you just take chili and have a salad then what will happen to your fate? Then imagine, isn't it? So most of the vegetables, of course, we just wash it, cook it and eat it. But some of the vegetables like cucurbits and chili, sometimes the people are fancy in taking it and directly So that is the problem. Vegetables and this one, of course, paddy is also not this one exceptional. That is also taking. Now, why I'm telling is all these pesticides, right from the beginning, early part of the green revolution to till now, they are dominating. And you can see the pesticide residues in all parts of the body, including the breast milk. Every day we hear the news and other things, isn't it? So that is the problem. Right. So the selection of the pesticides depends on 3 factors, right? One is pest to be controlled, whether it is a hidden pest, or it is a foliage feeder, or it is a sucking pest. So type of pest to be controlled decides what type of the pesticide appliance which I can use it. Then the second one is stage of the crop. What stage the crop is, and the formulation of the pesticides, whether it is a liquid formulation or granular formulation or the powder formulation. That also decides or depends for using the appliances. Of course, in general, we say the pesticide appliances are three categories like sprayers, dusters, and fumigators, isn't it? So what is sprayer? Right? So this is the equipment which is intended to spray, intended to distribute the spray particle, in the sense pesticide particles when they are in the liquid form. Similar is the dusters, which are in the dust or powder formulations, right? So then foggers, we say, it's a mechanical or thermal device which can disperse a liquid in the droplet size having VMD less than 50 microns. Okay, so we normally encounter these kind of words. That's the reason why I'm telling all these things, just to bring it to your notice. Aerosols like a mosquito, martin kill, and cockroach hit, all those things, we normally use it in the home, this one. So that is a droplet having a volume median VMD less than or equivalent to 50 microns. So based on the size of the particle, that is in terms of VMD, these foggers, aerosols, and the mist. So mist, anything the particle size VMD is between 50 to 100 microns, we normally call them as mist, right? So then fine spray. So we also use in spray technology, or this one, depending upon this particle size. So the droplet having VMD between 100 to 500 microns, we normally say fine spray. And between 400 to 1200, it is medium spray, and coarse is anything above 1200 microns. The VMD is normally said to be coarse spray. Then this is actually what is VMD is volume median diameter. It's the size of the droplet which the total volume of droplets found exactly in half. For example, so this is actually the information I got it from the Sunil only, because they only do all these particle size, density, all those things. So if this is the area wherein the total volume of the liquid, so half of the area, if it is less than 50%, the particle size is less than the VMD. And if it is more than, the 50% is more than the VMD, then with this, they just calculate the overall VMD of volume median diameter of the particle. So this is the one such measurement which we normally take into account. It's, measuring the size of the droplets or particles. Then we also normally use in a plant protection, the basal application. Even in agronomy also we use it, isn't it? These terminologies. It refers to the application of chemical at the base of the plants. Normally it is called as basal application. Broadcasting, of course, application of the chemical on entire area. Okay, it is broadcasting. And banded application, it is in between the row or the spot applications. Okay, all those things normally we use it depending upon the situation. Direct application, an application, the method in which the chemical is applied onto the specific area, normally site specific, like direct application. Wherever it is infested, we go for this direct application of the chemicals. And the foliar applications, in general, the target area, or normally we go for this foliar application in agriculture, spraying onto the leaves, stems, and the plants like. And of course, we also use some of the terminologies like pesticide application methods, pre-sowing or foliage treatment, then pre-emergent. Normally we use this word for the pre-emergent herbicide applications, right? Post-emergent soil application, foliar application, direct application, soil injections, spot treatments. These are the terminologies. So I thought it is a kind of refresh for the other people, except other than the UAS people like. Right. So what is deposit rate? It is nothing but it is amount of pesticide deposited per unit area. That is actually the deposit rate. And the drift, it is actually the movement and the deposition of the spray particles through air, to a non-target area. Other than the target area, whatever the spray particle which move, maybe by wind and other things, we call it as a drift. So that is the one which we need to take into account, particularly in the drone ecosystem. So that is what the people say normally without knowing the scientific reason. Oh, if you use drone applicators or drone mounted sprayers, the drift is much more. All those things. It is going to pollute aquatic ecosystem, all those things. But it is not, which I will show it with the facts and the figures. Droplet density is the number of droplets per unit area of a leaf surface is called as droplet density. Of course, everybody knows, we know that it is a leaf area index, which is normally commonly be used in agriculture. Like then, of course, formulation, we normally say formulation in entomology and pathology, of course, agronomy also. The formulation is a physical mixturing of active ingredient with the adjuvants or the carrier materials, isn't it? Because the amount of toxicant which is required to spray is very less, which has to be distributed throughout, because we need to use it, apply throughout the larger area. So that's what. The concentration is actually the active ingredient which is present, and the rest of the things is formulated product, in the sense active ingredients. Granular applicators, of course, I told you, this is also one such appliance which is intended to apply the granular form of the solid form of this one, except the dust, the granular form of the insecticides or the fungicides being. Herbicides, of course, it is intended for application of or killing the weeds like insecticides. I don't want to go in detail, just for information to you like. Then really coming to the pesticide appliances. So pesticide appliances are those equipments which are intended for application of the pesticides. And of course, the pesticide, it's a chemical which is intended for killing the or controlling the pests. And the what are pests? I just repeat for your benefit. The pests are the biological organisms which cause significant and economic damage to crops, crop produce, livestock and human beings. So these four segments are very important, not only to crops. So crop, then after that it is a produce, after that it is livestock, then to the human beings also. So that too significant and economics. Unless and otherwise, if it causes significant which is leading to economics, there is no point in studying it. So because if it is not causing any economic damage, the fellow will be taken care by natural agents. So that is the reason why we normally, to control or to use the pesticides, we need the appliances. Normally the sprayer has got these many parts, like, isn't it, right from the tank to even the sprayer and the lawns, all those things, just for the information. Like, of course, nozzle is the important part, isn't it, which helps in atomization of the particles, isn't it? So which has got several parts. I don't want to go. Normally in entomology, we use hollow cone nozzles, right? Of course, most of the time in drone applicators, we use flat fan kind of nozzles, because the thrust and the force which the particles are pumped out is making probably, if you use a flat fan, probably with that thrust it will distribute the particles, so small sized particles, very effectively. That is the reason we don't use normally hollow cone, we use the flat fan. And of course solid cone, depending upon the type of vegetation, we use this, and the flood jet nozzles also. So these are some hollow cone nozzle. I'll just show you the pictures. I don't want to go in detail. Yeah, this is what hollow cone nozzle with this one. You can see the solid cone. It covers the target surface area without leaving any in between. Like, it will cover fully. So in the hollow cone, in the center, it will leave the space, and in the periphery also it covers only. So if you just shift this nozzle, in the sense the lance, it will cover both, right? And normally in insect control and other things, we use the second one. Flat fan, of course, this normally in case of drones or even painters normally use this kind of things, or herbicide applications also normally use this, because the force with which the particle comes with this particular spray is less, particle size is more, hence it requires to wet this one. So you need to wet it, particularly for weedicide application. What is required? Not to spray surface, It should wet, it should drench it, so that to drench it, the flat fan kind of nozzles are very much required. Then triple action or adjustable nozzles are also will come, wherein you can have flat fan or you can also have solid cone. That is what that flood jet nozzles are. And of course, high volume sprayers, the name itself indicates it is volume of water which is used is high, right? Which I will come to the classification later part. So the manually operated sprayers are high volume sprayers because they use more amount of water. Yeah, low volume sprayers normally motorized sprayers like a knapsack, Aspi Bolo we say. So that is also which was very popular quite some 6-7 years before. Now it has also gone out, isn't it? What is in the popular is that the tractor mounted sprayers which are also under the low volume sprayers, but again the amount of water which it takes and the pollution which it takes and the availability, all those things also matters. This is all came just because of the labor availability. The labor availability is the one. Even if you get the labor also, getting work done from the labor is difficult because 11:30 to 3:30 fixed. And again from 11:30 to 3:30, getting work from them is very, very difficult. And again by 4 o'clock you should give net cash, isn't it? So that is the system. Otherwise they will not come next day, isn't it? So this is also one such a duster. Of course, the power sprayer, what I told you, if you just change the lawns and this one, you can make use for dusting also. Right, so based on the volume of water which is used, so normally the sprayer, in the sense the appliances or sprayers particularly are categorized as high volume sprayers, low volume sprayer and ultra low volume sprayers. It is based on the volume of water. Volume of water, right? So what is that category says? In case of high volume sprayers, normally the volume of water per hectare which ranges from 300 to 500. So for example, highest in the field crops normally we say around cotton and red gram, which they take almost 400 liters per acre. Even I have given a narrow range, like even for example for cotton, our university recommendation for cotton when the crop is around 90 days old is 400 liters per acre, which is almost 1000 liters per acre, per hectare, even for the red gram also. I have given the overall range for 300 to 500 liters, and the low volume sprayers anything between 50 to 150, and again ultra low volume is less than 50, right? Now, and droplet size you can see here, probably this is a general classification. Anything more than 100 microns or 150 microns, in between 100 to 150 microns normally the droplet size in the high volume sprayers. And the area coverage, of course, the size of the droplet is more means the loss will be much more, and it is normally operated by the manually operated ones, which requires more volume of water, which naturally takes more time to cover it. Hence, area covered per day is hardly 0.5 or maybe little more than that. So low volume sprayers, it comes to around 1 hectare. And of course, with the now drone technology, you can enhance it to 3 times or 4 times. So now my intention of all this information is that your drone mounted sprayer also belongs to low volume category. It is also low volume sprayer. No. Ultra low volume, the maximum amount of volume of water used is, yeah, even some literature says even maximum is 10 liters, not more than that, right? I'll clarify again, okay? So that comes under, our drone mounted sprayer comes under low volume spray, right? So there is a chance for reducing the, even what I said is 50 to 100 liters, na, there is a chance to reduce even the water use in case of drone mounted sprayer. So that is the need of the hour. So for which the experiments, lot of SOPs need to be developed. With my experiments, I'll just show you and convince you like. And of course, this is evaluate sprayers. We used to, way back some 15 years before, people used to use on red gram and cotton. Now it has been banned totally, right? Because of the drift effect, because of the high toxic effect, which normally causes hazards to the applicator itself. Leave aside hazards to the natural enemies and other things that will let us bother later part, because personal is important rather than the other things, isn't it? For the applicator itself, it is very hazardous, hence this has been removed, right? Any doubts, any information with regard to this small topic which I thought of covering it? Any information, any clarifications? So that next Ogipa. Now, probably you can also share with me your experiences also. I said that the drone mounted sprayer belongs to the low volume sprayer, anything between 50 to 150 liters per hectare, isn't it? So when the volume of water used in a drone mounted sprayer is still less, let me ask you the question, what you know about what is the volume of water which is used with your knowledge, as per your knowledge, volume of water required to spray 1 acre or 1 hectare with a drone mounted sprayer? Yes, to per acre 10. 16 liters, 10, 16, 20, maximum. Let me take one example of cotton. How much I can? 20 liters as per my colleague. Yeah, 20 liters maximum. 5? 80 per hectare. Where is 20 and here is 80? Acha. Question is out then. Question is already out. Acha. As Bartina, why I asked is that there is a wrong notion that only this much is the volume of water which is required to spray with a drone mounted sprayer for all the crops, irrespective of the crops. That has been fixed. But that is not the one. That's wrong information which it has been spread. So we need to do our own experiments and confirm, and SOPs need to be developed. I'll tell you the precautions or what we have to tell. We have to be careful before uttering to the public in respect of drone mounted sprayer at the end. Healthy none. So 2 case studies which I have done it wonderfully for almost 4 years. 2 years I have done it, and 2 years the PhD student has done. So Kavya has done with under the guidance of course I was also member, and Sunil and Sushilendra. She did it wonderfully. We did it both on cotton as well as on paddy ecosystem. This is actually the drone mounted sprayer which we have used. Of course, all the advantages has been already cleared off by Sunil. The major is that why the drone, the very purpose of bringing the drone to agriculture ecosystem is to avoid the human intervention, because health is wealth. Isn't it? How long we can, give our own salary for the medical bills? How much percentage, the medical bill that we spend it in general? Of course, youngsters will be less, but at least after 40, 35, 40, you need to invariably go in for your health insurance plans. ಅದು ಕಂಪಲ್ಸರಿ ಆಗಲೇಬೇಕು. ಪ್ರಾಬಬ್ಲಿ ಮೇ ಬಿ ಸಿಸ್ಟಮ್ ಮೇ ಟೇಕ್ ಅಲ್ಲ, ಎಲ್ಲರಿಗೂ ಕಾಮನ್ ಆಗಿ ಮಾಡ್ಬಿಡೋಣ ಅಂತಲೂ ಬರ್ಬೋದು, ಗೊತ್ತಿಲ್ಲ, ಬರ್ಬೋದು. ಹೌದು, 15 to 20% ಅಂತ ಹೋಗೇ ಹೋಗ್ತದೆ. ಸೊ ಪರ್ ಆ್ಯನ್ಯುವಲಿ ನಮ್ಮ ಟೋಟಲ್ ಸ್ಯಾಲ್ರಿ ಅಷ್ಟು ಹೋಗ್ಬೋದು ಅಂತ ಅನಿಸುತ್ತೆ. ಸೊ ಹ್ಯೂಮನ್ ಇಂಟರ್ವೆನ್ಷನ್, ಅಫ್ಕೋರ್ಸ್ cloudy weather or any inconvenient weather also within a short span. For example, if it is cloudy but not raining, whether to go for spraying or not, within a short span of that cloudiness, before the rain starts, I can finish off. Within 2 hours, I can finish off some hectares, 10 hectares, 20 hectares, tuck, I can finish off. Of course, saving the time. Nobody has time, including the farmer. Of course, isn't it? Cover a large area within no time, right? Accessibility to hard and to reach it. Yes, of course. Once flood came actually in our Raichur region, actually we used this drone to supply the medicines also to the other sides, So that is this one. In the sense, we can also use drone not only for the ritual functions, but also you can use it not only for the pesticide uses or weedicide applications, for even to the some urgency, you can also send emergency, you can send tablets and other things. We sent it actually. So one was stuck in the other side of the river, which was, flowing like anything, like it was flooded. So we sent the medicines and other things, and we saved that fellow later. Right. Small and the fragmental area also you can use it. Absolutely, there is no question. Okay, and the polluting other areas and polluting water bodies and other things, aram se you can do it. You can geotag it, fix it, the fellow will spray and come back. It will come back to your own position and it will go to his own position again, it will take and starts. So that's it, that is the power of the technology. Like, so this is what, to do experiment, because I have to compare the drone mounted sprayer with the normal sprayers, na? So what I did was, I took knapsack sprayer as a high volume sprayer, and also motorized sprayer as a low volume sprayer, because drone mounted sprayers also belongs to low volume sprayer only. I have to compare with the one. Then I also took another low volume sprayer is tractor mounted, because that is a very popular in Raichur region, because we have a lot of cotton and red gram. They use it even for the Bengal gram also they use it. For almost all the crops they use this tractor mounted. And of course another is with this one. Then, so this is the layout. Almost 1200, in the sense almost half a acre, 0.25 hectares. I just had one big blocks, and each blocks was divided or marked with, in the sense we have sown the bajra all around, just to avoid the drift and other things, so that we should not get erratic results. So I had the big blocks of almost 1200 square meter area, almost 12 gunta, right? Then like this, I had the replications also, like, right? So this was the completely randomized, the block design. And this I have done it 2021, 22 and 22, 23 myself. And of course followed by 2 more years of Kavya's experiments on cotton in the Raichur. These are all the dates pertaining to experimentation. We went for 4 applications in cotton, right, from 1 month old to 120 days, 1 month, 2 months, 3 months and the 4 months. So I wanted to check how much of volume of water that it takes. So can we really know that only the 10 liters is fixed? That I wanted to avoid the wrong notion, like. Right, so this was the chemical. Leave aside the chemical, not to bother about the chemical. This is a sponsored trial given by the Indophil Chemicals company. Cubico was one such chemical, which is a combi products, in the sense combination products, which is targeted for sucking pest, dimetaphyran and diphenturan, both for sucking pest. Okay, so the recommended dose is 625 gram. I thought, see, drone mounted sprayer, it belongs to low volume sprayer, wherein the amount of water which is being utilized is less. Let me use less amount of, is there any scope to reduce the load of the pesticide, in the sense quantity of pesticide? That way I just went for, hypothetically, this is 50% less and 25% less. You can see here, 25% less, 50% less, compared to knapsack sprayer 100% and high volume sprayer, 100%, power sprayer and knapsack sprayer 100%. Of course, compared with which is this recommended dose and all those things, we have done it. Just for phytotoxicity studies, double the dose we have done it, because as per their protocol I need to. They didn't give these 2 treatments. I only told them, let us do that. Maybe the data may not be required for them for registration purpose, for at least for my academic purpose, I convinced them, sir, let me have 2 more experiments, because my land will go, yours will not go. Then we convinced them, then we did this, right? So against thrips, whiteflies, leafhoppers, whatever the insects which we noticed, we took it. So most of the sucking pest data, we have done it, and you can see the droplet size. Before doing it, we counted the pest data, in the sense pre-count, the number of leafhoppers, number of thrips per 25 plants in each block we have taken, pre-count we have taken, and also before spraying we have placed water sensitive papers, both on the top leaf, top portion, middle leaf, top portion, lower leaf, top portion, likewise lower side also. In the sense, top leaf, lower surface, middle leaf, lower surface, lower leaf, lower surface. So on one plant, selected plants, 6 water sensitive papers we have placed. Like that we have placed almost 20-25 plants in a big block. We wanted to know whether the drone mounted sprayer, will it spray only the top portion? Will it not cover the lower part of the top, upper part of the middle, lower part of the middle, all those things we wanted. Plus buffer area. After my plot is over, so I placed the water sensitive papers at 0.5 meters, 1 meters, 2 meters, 3 meters, 4 meters. Just to want to see drift effect. Swath width, drift effect I wanted to check it. Okay, that also I have done it. This is how I just tagged it. You can see here. Upper, the lower, bottom, right? I have placed this. So the beauty of this paper is that once the droplet falls, it will stuck and it will not spread. So we have collected it, marked that treatment wise, replication wise, and used for counting the droplet density and size. Right? So this is how he is the representative from Indofil company also. The during sprays they came and we used this hexacopter. So I started using this when the crop is 25 days to 30 days old, just to check level of the amount of water that is going to be used. Likewise this, when the crop is almost 2 months plus, and even at the end of the crop also, cropping season also. So this is what the density of droplet size which was onto the water sensitive papers. This is we also recorded the wind direction, right? Then wind direction and of course wind speed also. Then we have used this instrument, the microscope, to measure the droplet size. This is actually the parameters. Of course Sunil might have told, but still. So the 20 liters was the hexacopter we have used, right? And the flying height, with which we have standardized, this is after feeler trials only. Don't think otherwise. I have fixed 1.2 meters height from the canopy. This we have done it after several feeler trials. Okay, so 1.2 meters from the canopy, not the 3 meters and the 4 meters which the people tell. Please be aware. Okay, 1.2 meters, right? Then the swath width was almost 2.86. The spray, the width, the swath width that it covers is almost 2.86 meters. Then the flying speed which we have fixed is, we have tested 6 meters per second, 4 meters per second, and finally we came to conclusion that 2 meters per second speed is okay. Okay, 1.2 meters, 2 meter per second, the speed will cover beautifully, which is much better than or equivalent to any other sprayers, which I will prove with the data. Right? So the buffer zone, it has, the drift effect also gone up to 3 meters. 3 meters. Yeah. So this is what other the parameters and all those things we did it. And one interesting is that when the crop is almost 1 month old, the first spray, 25 days to 30 days old, what was the load? What was the spray, the amount of 30 liters. Again, when it has gone to the second month, the 2 months old crop in the second spray, almost double. What I mean to say is that don't fix yourself that it is 10 liters, 4 minutes or 6 minutes per acre fixed. Now we are all scientists, na? We should know that at least the research which has been done somewhere, literature, or research which we ourselves do it. So that's what I wanted to emphasize, right? So accordingly, you can see here 30 liters, then for 60 liters. When the 90 days it was almost 80 liters. 120 days it was 106 liters to 102 liters to 106 liters per hectare for cotton. I repeat, when the crop was 120 days old, there it was almost 102 liters or 106 liters per hectare. Now tell me, is that 20 liters is fixed always? No, please. Okay. So, but still, we have saved almost 50 liters of water. Suppose, as per the classification I am talking about, 50 to 150 liters per hectare is the volume of water used for low volume sprayers. But still here, a crop like a cotton, where it maximum, that too with 2 meters per second, the speed, not the 4 meters per second, 2 meters, and the height is also less. With that, maximum that it took is 100 liters. Maximum, say approximately 102 to 106, but still let me take it as a round figure, 100 liters. 100 liters matlab it is almost 40 liters per acre. Right? So it varies from crop to crop, of course, stage of the crop age, the density becomes, isn't it? Foliage. You can see the,
Why there is difference in droplet size? In the first spray, there is spray droplet size is 208 micrometer, and in the below it is 192 micrometer.
Performance parameters. Sunil?
Yeah, above in the same it is above.
Yeah, here na 192,
192 and above it is
108, 208.
Sir, it is because the
Discharge rate.
because it is 2.8 liters per milliliter,
Hmm.
it is 2.72 liters.
There is no much difference.
Not much difference actually, numerically, but
Actually, it is an average value what we have taken. So when we see the droplet sizes, we will be getting right from 150, 160 to up to 400 we will be getting. Some of the droplet sizes
In
will
the
be there.
first column itself, the 208 micrometer is there, and below it is 192.
No,
So what is that?
First one is
Specification. In the operational
I have already measured sizes.
this is drone specific. Yeah.
Sir, flying height is from ground level or canopy level?
It's crop. How can it be from the ground level? You have to measure only with the crop canopy, not ground. And even one doubt, the people asked me,
I think it is around 3.2 or 3.5.
okay. The one doubt the people asked is that, even if with that pressure, the thrust, will the cotton, branches will break. So we did that, nothing will happen. It will bend completely, but still it will not break. That much guarantee I can give. Yeah, that's what I'm telling you. A crop like a cotton, which is normally, if you just push it, in the sense if you just bend it normal, this, the branches will break. But still the fellow will not. At this height, nothing has happened. The physical injury, nothing has happened to the crop like. Right? And even for the paddy and other things, easily can use it because it is so flexible, isn't it? So you can go still downside for the paddy like maybe 1 meter height. Yeah, you can go for. You can see here. So this is in case of the first spray, and the same is the case in the second spray of the first year. Same trend. And of course, first spray in the next season, 2022-23, again the same trend. The droplets size is less in case of drone mounted application compared to the normal sprayer. Then again the second spray in the second season, second year, the same trend. Droplet density, yes, size we have noticed, and the density also same pattern, like you can see the density is also less in case of all the drone mounted treatments. Then when it comes to my bioefficacy trial for against the insects, the thrips, you can just see here, right? So let me come to the, where is that 25% less? Second one, na? This one, na? Okay. So this one you can see here, 62.93% reduction in the pest control vis-a-vis, you can see 34 in case of drone mounted, what is that? 50% less, all these things, you can check it. And this is for the first spray. And I think second spray, the data, again 59.42 and 59.91 in case of the 50%, I think 50 recommended dose. And this is 25% less, 50% less, you can see here, right? So at least you can check between these two, like you can have your eye on these two, the second and third. And for leaf hoppers in the first, this one, and you can check it. So where is 24 versus where is 66, right? Then again the leaf hoppers, thrips in the next season, I suppose, 69.56 versus this one. And you can also check with the other treatments, our normal sprayers. Then the percent reduction, again the leaf hoppers in the next year, the first spray, same trend with a greater reduction in the 25% reduction in the load of the pesticides. And again, I think this is thrips, and the subsequent year, you can see the same trend. Leaf hopper in the subsequent year, the same trend, right? And it should have given phytotoxicity, na? Now it has not given. Why it has not given?
Chemical per square per unit area is actually less.
Even at the double dose also, the chemical has not given phytotoxicity, means it's already been proved, because the same chemical have been recommended. Such of the chemicals which have already been registered, they have been permitted to use through drone mounted sprayer, because already we have done these kind of experiments through normal sprayer as a bioefficacy trials for the registration. This is just a additional data which they wanted to have it for the same registered available product in the market. This data through drone application, what will happen? Artha aita? Alla adanu madidwe. We have the doubling the dose with the drone also, but nothing has happened. Yeah, see, now normal trial madlike, when we do normal trial without the drone, I am talking about the other spray, knapsack sprayers, we do 1x, 2x, 4x also. To double the dose, recommended dose on the double the molecules only, not for the any other. Suppose if any new chemical has come, if they wanted to apply through drone, have it tested? No, means they have to give it for at least one season trial. One season, taking the data of normal sprayer, the 2 seasons which might have been done it, registered, but still they want 1 season data of drone, not bioefficacy, it is phytotoxicity. That's the unfortunate thing. Ade navin tappu madiddu ಬಹುತೇಕ. What central government hurriedly they have taken a decision is that the new molecules which have been registered can be tested for phytotoxicity, not for the bioefficacy anta ಕೊಟ್ಬಿಟ್ರು. ಎಲ್ಲರೂ ಟ್ರೀಟ್ಮೆಂಟ್ಸ್ ಏನು ಕೊಡ್ತಾರೆ? 2x and 2x ಅಂತ ಕೊಡ್ತಾರೆ. Probably that is a good thing. Many forum ನಾನಂತ ಹೇಳಿದ್ದೀನಿ ನಾನು. Many forum also, even in my short course also I have recommended and sent it. I did this short course, I share short course on drone technology. Excellent. ತುಂಬಾ ಒಳ್ಳೆಯದು. Correct.
Sir, one very interesting doubt is in my mind. I think we use the other directive 50,000 ppm. So, and if we double the doses, at that time there should be a scorching effect on it.
See, azadirachtin 50,000 ppm, probably it might have been done with the normal sprayer also. What is the status of that? When it is not causing any problem there with the normal and the double dose, how can it cause us here? That's a simple logic, isn't it? So first of all, we have to try with the normal sprayer, or you have to combine at least these treatments like normal sprayer with the drone mounted sprayer. That's the reason why I'm giving a hint to our colleagues here is that suppose if you wish to take such kind of experiments, have number of treatments on your own. Don't follow the protocol which is supplied by the company like it. What they give is one X dose, which is recommended dose with the drone, double the dose with the drone, ಬಸ್ ಹೋಗಿ ಒಂದು ಅನ್ಟ್ರೀಟೆಡ್ ಅಂತ ಕೊಟ್ಬಿಡ್ತಾರೆ, ಆರ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಚೆಕ್ ಅಂತ ಕೊಡ್ತಾರೆ. ಸೊ ದೆನ್ ವಿತ್ ದಟ್ 3 treatments, what you do then? What you are going to get? Array, no phytotoxicity. It is already proved because earlier we have done it. Somebody has done it, alla. So ಅದಕ್ಕಾಗಿ you had some 2-3 treatments, maybe 25% less, 10% less, whatever it is. Hypothetically, I have taken 25%. It doesn't mean that exactly, I don't know, maybe even 10% would have been much better. 10% would have been given same equivalent control with reduction in this one, isn't it? So I don't know. See, these are all the trials which we have to meticulously design it and do it. This is what I thought of bringing. So no phytotoxicity in all the treatments, boss. In all the 2 years we have done it, no phytotoxicity like. Natural enemy, of course, on par. Same data we have got. Absolutely, there is no much difference. Statistically, natural enemies vis-a-vis all the treatments, it is almost same, right? Then spiders, gators, everything we have taken. Then droplet drift and other things you can see. Up to 3 meters also. You can see as the distance increases from the target area, the drift is also less, but still up to 3 meters we could able to see the drift effect like. I have placed the water sensitive papers and did this.
Combination may be high concentration of the chemical with less of water, maybe reducing the droplet size, increasing the speed.
That's what, that is a researchable issues now. I'll come to that. I have given it to my student now. Right? Say same thing. I think already Sunil ಹೇಳಿರ್ತಾರೆ. I don't want to go in detail. Let me come to the economics. See here. The economics, when it comes to the, this is 25% less, alla? You can see the 2.6 vis-a-vis. It is 2.8 versus what is our standard one? This one, na? Power sprayer, ಅಥವಾ ನಾವು ಇದನ್ನ ಹೇಳ್ಕೊಳ್ಳೋಣ. ಹಾಂ ನೋಡಿ 2.42. ಅಂದರೆ this is again hypothetically I have done it with taking 25% less. If we can just do meticulously as he said, probably the cost can be reduced and the benefit is also bit more. But what I am trying to say is that finally there is a scope to reduce the pesticide dosage with the drone mounted sprayer. There is a scope. I didn't say that it is recommended. There is a scope. That is again researchable issues. Please know from where the people have done it, or study the literature, or you yourself can do. This is what the still ಹೌದು ಇರ್ಬೋದು ಇಲ್ಲ ಅಂತ ಹೇಳಂಗಿಲ್ಲ ನಾನು. ಮಾಡ್ಬೋದು. ಹೌದು, ಇದು ಫೀಲ್ಡ್ ಇದೆ. Spraying cost, rest of the cost is same. Common cost of cultivation is same, na? ಅಷ್ಟೇ. I have taken only my pesticides. Cost of application, cost of cultivation, everything remains same there. Now ಮಾಡ್ಬಿಟ್ಟಿದ್ದೀನಿ ನಾನು. ಇಲಾಖೆ treatment cost is nothing but our pesticide cost, spray cost. ಹಾಂ ಇಲ್ಲ ಅದನ್ನು, that is what I am doing it now. I am taking it now.
So it's not required because when already it has been tested and when the bioefficacy has been given report, so that's all. There is again doing with the drone, it doesn't matter.
Exactly. I'll come back. ಇಲ್ಲ. The droplet size is so small that will be deposited on the leaf surface, wherein the penetration of the particles into the leaf system, the plant system is very faster and more. Compared to you take a high volume sprayer, for example, low volume sprayer itself like a power sprayer, where the thrust, it will go, and most of the time it will be drifted onto the soils also. The the soil pollution with the pesticide application with the power sprayer is more than drone applicator. That much I can guarantee you. But still we need the data, as you told, to say or to convince the people, we need the data. Yes.
Sir, 30 days, the land area covered by the cotton is less. At that time, the swath will on the top of the rows itself, or generally you take the that will take.
No, you can adjust with the row spacing also. We can adjust that, there is a provision there. Okay, if it is this one, you can just increase the what is that, swath width, what is that? Nozzle size, nozzle width you can adjust, so that exactly it will fall onto the top of the canopy. That we can adjust. That we can adjust. ಪಕ್ಕದಲ್ಲಿನೂ ಇದನ್ನು ಬಿಟ್ಟು ಇದೆಷ್ಟಿತ್ತು, ಆಲ್ಮೋಸ್ಟ್ ಒಂದು ಹಾಫ್ ಮೀಟ್ರ್ ಹಾಫ್ ಫೀಟ್ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ, ಬೇಡ 1 ಫೀಟ್ ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣಂತೆ. ಅದಾದ್ಮೇಲೂ ಸಹಿತ ಪಕ್ಕದಲ್ಲಿ ಇದಿತ್ತು, ಬೇರೆ ಕ್ರಾಪ್ ಇತ್ತಲ್ಲ, ಅಲ್ಲಿನೂ ಹಾಕಿದ್ದು ನಾವು, ಇದಕ್ಕೂ ಹಾಕಿದ್ದು 0.5 ಮೀಟರ್ಸ್ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. ನಂತರ 1 ಮೀಟರ್ 2-3 ಮೀಟರ್ಸ್ ಟು ಜಸ್ಟ್ ಪ್ಲೇಸ್ಡ್ ಇಟ್, ಬಿಕಾಸ್ ನಾವು 1.5 ಮೀಟರ್ಸ್ ಅಬೌವ್ ದ ಕ್ರಾಪ್ ಕ್ಯಾನಪಿ ಮಾಡ್ತಾ ಇರ್ತೀವಿ. ಸೊ ದರ್ ಈಸ್ ಎವ್ರಿ ಚಾನ್ಸ್ ಟು ಡ್ರಿಫ್ಟ್ ಇಟ್ ಔಟ್. ಓಕೆ, ನಾವು ಇದನ್ನು ಟ್ರೀಟ್ಮೆಂಟ್ ಬೈಫರ್ಕೇಷನ್ಗೆ ಹಾಕ್ಕೊಂಡಿದ್ದು, ಬಟ್ ರೈತ ಯಾರೋ ಹಾಕೋದಿಲ್ಲ, ನಮಗೆ ಹಾಕ್ಕೊಂಡಿದ್ದು. ಮೇಜ್ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ, ಯು ಕ್ಯಾನ್ ಗೋ ಡೌನ್ ಸ್ಟಿಲ್. ಐ ಆಮ್ ಶ್ಯೂರ್ even 1 meter, 0.8 meters above the canopy also you can do it, nothing will happen because crop will not break. It is so flexible. ಹೌದಿಲ್ಲ? Even suppose if the crop is say 1 month or 1.5 month crop ಇದೆ ಮೇಜ್ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ, you can go around 1 meter height, so that let the droplet fall into the whorls, leaf whorls, because fall armyworm normally feeds there, so that it will the particle will reach it. Okay, so that way ಫಾರ್ ಈ ಸೀರಿಯಲ್ಸ್ಗಂತೂ ಈಸಿಯಾಗಿ ಮಾಡ್ಬೋದು. ಹಾಕಿ ವಿತ್ ಇಟ್ ರಿಲೇಟೆಡ್ ದಿಸ್ ಈಸ್ ವಾಟ್ ಯು ಕ್ಯಾನ್ ಸಿ ಹಿಯರ್. ಈ ಥರ ಮಾಡಿದ್ದು. ಸೊ ಪೀಪಲ್ ವಿಸಿಟೆಡ್ ಆ್ಯಂಡ್ ಡಿಸ್ಕಸ್ಡ್ ಆಲ್ ದೋಸ್ ಥಿಂಗ್ಸ್ ಆ್ಯಂಡ್ ದಿಸ್ ಹ್ಯಾಸ್ ಬೀನ್ ಡನ್ ಬ್ಯೂಟಿಫುಲಿ. ಓಕೆ, ಎನಿ ಡೌಟ್ಸ್? ಸೇಮ್ ಥಿಂಗ್ ವಿ ಹ್ಯಾವ್ ಡನ್ ಇಟ್ ಇನ್ ದಿ ಪ್ಯಾಡಿ ಇಕೋಸಿಸ್ಟಮ್. $23.55 quintals per hectare vis-a-vis knapsack ತಗೊಂಡ್ರೆ ನಮ್ದು ಇದು ತಾನೆ recommended 21, which is almost 2 quintals more or less, 2 quintals more ಅಲ್ವಾ? I'm planning it now. Actually, what I'm planning it is, this is initially we were not having any idea how much to reduce. I thought there is a scope to reduce the pesticide load because the usage of water is less. The amount of water which goes through drone mounted sprayer is less. So that's why hypothetically I fixed it 25% and 50%. But you can start with the height, what he said, height, then the dose, the speed, all the things, then different treatments you can fix it up. So beautifully it will be wonderful research work, and across the crops, across the stage of the crops you can do it. For example, for cotton 1 month to say 4 months depending upon because pest spectra varies. Okay, for example I will spray at 3 meters height. Okay, what will happen? Let me spray at 1 meter height. What will happen? Discharge rate, everything can be designed meticulously, and we have to. So at this juncture, I'll just give you one maybe information to the you people is that unless you know about the information which is done elsewhere or through literature or your own experience, don't commit to the public. Don't tell to the farmers. Particularly what they have done it is, the department, they have given the drones now to the, what is that? Raita Samparka Kendra. People doesn't know how to operate also. Licensed pilot is required and expert is required, isn't it? So they doesn't know. Unless we develop SOPs, how can he, even if he know how to operate also, but SOPs na, at what height, what speed, ಅದಾದ್ರೂ ಬೇಕಲ್ವಾ? ಏನು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಹಾಕಬೇಕು, ಎಷ್ಟು ಹಾಕಬೇಕು, ಅದು ಇರೋದೇ 10 ಲೀಟರ್ ಇರ್ತದೆ, ಭಾಳ ಅಂದರೆ 20 ಲೀಟರ್ ಇರ್ತದೆ. ಎಷ್ಟು ಹಾಕಬೇಕು ಅಂದರೆ ಅಷ್ಟು ತಗೊಂಡೋಗಿ ಒಂದಕ್ಕೆ ಹಾಕಿದರೆ ಮುಗಿದು ಹೋಯ್ತು. ಸೊ ದಟ್ಸ್ ದ ರೀಸನ್. ಕೆಮಿಕಲ್ ಕಾಸ್ಟ್, ಹೌದು, ಸ್ಪ್ರೇ ಕಾಸ್ಟ್ ಆ್ಯಂಡ್ ಕೆಮಿಕಲ್ ಕಾಸ್ಟ್. ರೆಸ್ಟ್ ಏನೋ ಅಗ್ರಾನಮಿಕ್ ಪ್ರಾಕ್ಟೀಸಸ್ ಆರ್ ಸೇಮ್, 80,000 which I have taken. So quickly I'll just go through. This is again the same set of experiment with a different chemical. We just did it with the paddy. Same droplet size, everything the same trend as it was in the cotton also. But the chemical, of course, Hillodi. This is a fluopyrimine which we have used from Corteva. So they gave it the testing trials, and of course with the request I just added one more treatment. 75%, 100% they were interested, plus 200% phytotoxicity they were interested. With this we have done it the 2 years. The droplet size is less in case of all the drone mounted treatments. Same is the ತಗೊಂಡೋಗಿ we have taken it to the laboratory and counted. Software ಇದೆ. If you just place it under this one microscope and you have the software, ಇದೆ ಈಸಿ. ಅದು ಸಾಫ್ಟ್ವೇರ್, ಅದನ್ನೇನು ಇಂಡಿವಿಜುವಲಿ ನಾವು ಮ್ಯಾನ್ಯಲಿ ಕೌಂಟ್ ಮಾಡ್ಬೇಕನ್ನಂಗಿಲ್ಲ. ಈಗ ಜಸ್ಟ್ ಪುಟ್ ಇಟ್, ಮೆಜರಿಂಗ್ ಮಾಡುತ್ತೆ. ರ್ಯಾಂಡಮ್ಲಿ ಯು ಕ್ಯಾನ್ ಮೆಜರ್ ಇಟ್ ಅಂಡ್ ಆವರೇಜ್ ಫಿಗರ್ ಯು ಕ್ಯಾನ್ ಟೇಕ್ ಇಟ್ ಔಟ್. Everything it will be. And in fact what we are doing it is actually old method, I suppose. One the advanced ಯಾವ್ದಲ್ಲ ಸುನಿಲ್ ಅದು, the completely it gives ಯಾವ್ದು 50 lakhs ಏನು ಅಂದ್ರಲ್ಲ.
So by using the deposit scan software we can get it directly. So by scanning the image of that water paper, so uploading it, and we will directly get the droplet sizes in terms of VMD, NMD, then droplet density, area coverage. So a lot of parameters can be
done. Yeah. Yeah.
So actually the image is a broad software. Within that, deposit scan is a part of it, which can be used for our
Droplet is one.
droplet is a droplet which is can be used by mobile also. But somewhat the accuracy is little bit less.
So in the droplet size, in case of second spray also in the first season same, and again in the second spray in the first, I think second season summer is same. So this is a graphical representation of the same thing. And again droplet size in the second season, the first spray, second spray, and again the summer paddy in the second season also. Everything is same. Droplet density, everything is same. I don't want to repeat the things. I'll straight away come to insect plague. You know, the BPH per hill we have taken. You can see the mean number here, 75%, 3.85 versus 3.65. You can see here, absolutely it is on par. You can see here, percent this one. You can take, this I have taken mean actually. You can check each and every column, 1 day, 3 days, 7 days and 14 days, it's on par. And you can see the difference in respect of percent reduction over control. It is 81 versus 82.82. So which is also narrow, in the sense very less, the difference. So the second spray in the first season also we have done it. This is the result, same trend has been noticed. And again in the summer also we have done the first spray. This you can see the same trend. And the second spray of the summer, the second season crop, same trend, right? Phytotoxicity absolutely no, right? Same trend, you can see. Natural enemy population, of course, not much variation across the treatments, right? drift, again up to 3 meters it went, right? Yeah, you can see this one, you can see here. Now I have taken common cost is 75,000 rupees versus the treatment cost is here 73 versus 89. You can see 1.7 versus 1.68, which means there is a scope. There is a scope to reduce the 25% of the pesticide load. So that's what. Okay, so while designing, probably we need to think of these kind of treatments. I'm sure I can really say with confidence, there is a scope to reduce the pesticide load with the, when you are using less amount of water. So that way, it is a serving to savor to the farmers. Because that much, see, you can see here, net returns, how much it is? How much? Eshtagatri? 72 versus 67, 5,000 rupees. 5,000 for 1 hectare into say so many, isn't it? For in a zone like Shumaga, which is almost 5 lakh hectares paddy, into 5,000 rupees hakri, plus water saving, pollution. Who is going to ecosystem services something ಹೇಳ್ತೀವಲ್ಲ, who is going to calculate all those things, bothered only about money? These are the issues, like, okay. Yes, exactly right. ನಾನು ಬರೀ 25% ಅಂತ ತೆಗೆದೆ, ಮೇ ಬಿ ಏನು ಮಾಡ್ಬೋದು. ಈಗ ಏನು ಬರುತ್ತೆ ಅಂತಂದರೆ, ಸೊ ದಿಸ್ ಈಸ್ ದ ಬಯೋಎಫಿಕಸಿ ಡೇಟಾ, ಕಾಸ್ಟ್ ರಿಟರ್ನ್ಸ್ ಎಲ್ಲ ಆಯ್ತು. Now the people will ask, what is the pollution rate? Pollution with respect to the high volume sprayers, vis-a-vis drone sprayers, ಮೇಲಿಂದ ಬರ್ತದೆ, ಹಾಗಾರ ಹೋಗ್ತದೆ, ಹೀಗಾರ ಹೋಗ್ತದೆ ಅಂತೇಳಿ. ಸ್ವಾಮಿ, ಈಗ ಟ್ರ್ಯಾಕ್ಟರ್ ಮೌಂಟೆಂಡಿಂದನೂ ಸಹಿತ ಮೇಲಿಂದನೇ ಮಾಡ್ತೀವಿ ನಾವು, ಕೆಳಗಿಂದ ಅಂತ ಹೋಗೋದಿಲ್ಲ ಅದು. ಹೌದಿಲ್ಲ, ಕ್ರಾಪ್ ಹೈಟ್ ಆದಾಗ ಅದನ್ನು ಹೈಟ್ ಮಾಡೇ ಮಾಡ್ತಾನವ, ಹೌದಿಲ್ಲ. ಈವನ್ ಟ್ಯಾಂಕ್ ಮೇಲೆ ಕೂತ್ಕೊಂಡು ಹೊಡಿತಿರ್ತಾರೆ ನಮ್ಮ ಮಂದೆಲ್ಲ, ಅಲ್ಲಿ ನೋಡ್ತಿರ್ಬೇಕು, ಭಾಳ ಚೆನ್ನಾಗಿರ್ತಾವೆ. ಟ್ಯಾಂಕ್ ಮೇಲೆ ಕೂತ್ಕೊಂಡು ಹಿಂಗೆ ನಿಂತ್ಕೊಂಡು ಹೊಡಿತಿರ್ತಾನೆ ಅವ್ನು. ಏನಾರು ನೋಡ್ಬೇಕಂತಂದರೆ ಆ ಕಡೆ ನೋಡ್ತಿರ್ತಾನೆ, ಹಿಂಗೆ ಹೊಡಿತಿರ್ತಾನೆ ನಾವು. ಕಲಬುರಗಿಯಲ್ಲಿ ನೋಡ್ಬೇಕು, ನಮ್ಮನೆ ಭಾಳ ಸಿಗ್ತಾವೆ. ಓಕೆ, ಸೊ ಟ್ರ್ಯಾಕ್ಟರ್ ಮೌಂಟೆಡ್ ಅಂತೂ ಕಾಮನ್ನೇ ಅದು. ದಟ್ ಆಲ್ಸೋ ಪೊಲ್ಯೂಟ್ಸ್ ವಿತ್ ಸೋ ಮಚ್ ಆಫ್ ಸ್ಪೀಡ್ ಆ್ಯಂಡ್ ಅದರ್ ಥಿಂಗ್ಸ್. ಈಸ್ ಇಟ್ ನಾಟ್ ಗೋಯಿಂಗ್ ಟು ಪೊಲ್ಯೂಟ್ ಇಟ್? ಡೆಫಿನೆಟ್ಲಿ ಇಟ್ ಪೊಲ್ಯೂಟ್ಸ್. ಏನಂದರೆ ನಮ್ಮ ಹತ್ರ ಅಥೆಂಟಿಕೇಟೆಡ್ ರಿಸರ್ಚ್ ಡೇಟಾ ಬೇಕು, ಅದನ್ನು ಜನ್ರೇಟ್ ಮಾಡೋಕೆ. ಹೌ? So while spraying, you can collect the the spray along with the air, you can collect it. There is a techniques, like, I don't know what is the technique, is collect ಮಾಡೋದು. GCMSC ಕೊಟ್ಟರೆ ಸಹಿತ it will analyze, isn't it, the amount of pesticides which is there in the air. ಅದು ಹ್ಯೂಮನ್ ಇಂಟರ್ವೆನ್ಸ್ ಅಂತ ಜೀರೋ ಅಲ್ರಿ, ಜೀರೋ. ವಿತ್ ದಟ್ ಇಂಟೆನ್ಷನ್ ಓನ್ಲಿ ಡ್ರೋನ್ ಬಂದಿದ್ದು ಅಲ್ಲ. ಪೊಲ್ಯೂಷನ್ ಎಷ್ಟಾಗುತ್ತೆ ಸಾಯಿಲಲ್ಲಿ, ಏರಲ್ಲಿ, ವಾಟ್ರಲ್ಲಿ ಅನ್ನೋದಕ್ಕೆ ವಿ ನೀಡ್ ಟು ಕಲೆಕ್ಟ್ ದ ಡೇಟಾ ಆ್ಯಂಡ್ ಗಿವ್ ಇಟ್ ಟು ದ GCMS. The data across the treatments, you can collect this sample, give it to the analysis part, that they will give it. So ಎಲ್ಲದನ್ನು ಮಾಡ್ಬೋದು, there is no harm in it, like. So this is what I am planning it to my PhD student. Of course it may take 1 or 2 years to give the data, all those things, like. Yes, application, yes. We have, yes. Sunil, ನಾವು ರೈತರು ಕೊಟ್ಟಿದ್ದೀವಲ್ಲ, ವಾಟ್ ಈಸ್ ದೇರ್ ಒಪಿನಿಯನ್ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. No, one board member of our own university, he took it when there was raining. It was raining, of course, there was a gap of almost some 4 hours also. He took our drone itself. We have hired at that time, actually. He took the person, the private company person whom we have hired, actually. He took him. And I think ಅಲ್ಲ ಎಷ್ಟು 25 MNC ಅವ್ರು ತೊಗೊಂಡೋಗಿದ್ರು ಅಲ್ಲ, I think 25 acres 10 acres. 25 acres they did it. The time, even in the rainy season also, there was a gap, in the sense, the 4 hours gap was there, it was not raining. He could able to use the drone, and the 25 acres was completed within 4 hours. He was very happy. Now the drone,
after spraying, for crop to take that chemical ingredient from
We do not have data, but I am sure it is much faster than normal sprayer.
Not actually for drones, sir. So you are saying that we can spray in the gap of 3 to 4 hours in the rainy season.
Boss, within 2-3 minutes, the press particles will be get absorbed. There is no question of this one. And I'm sure with the high volume sprayers, what the droplet size is, and with the droplet size of drones, they will penetrate very faster. Even if the rain comes also, I'm sure it is not going to wash it out. Okay, that much guarantee I can tell. Absorption rate ಜಾಸ್ತಿ ಆಗೇ ಆಗುತ್ತಲ್ಲ ಜಾಸ್ತಿ. Nothing. Straight. ಬೇಕಾಗಿಲ್ಲಲ್ಲ, ಬಿಕಾಸ್ ಕಮರ್ಷಿಯಲಿ ಅವೈಲಬಲ್ ರೆಡಿ ಟು ಯೂಸ್ ಫಾರ್ಮುಲೇಷನ್ಸ್ಗೆ ನಮಗೆ ಲೈಸೆನ್ಸ್ ಕೊಟ್ಟಿದ್ದು. ನಾನು ಮತ್ತು ಅದಕ್ಕೆ ಅಡಿಷ್ನಲ್ ಅಡ್ಜಾಯಿಂಟ್ಸ್ ಹಾಕಿ ಎಕ್ಸ್ಟ್ರಾ ಕಾಸ್ಟ್ ಮಾಡಿ ವೈ ಐ ಶುಡ್ ಬರ್ಡನ್. ಬೇಕಾಗಿಲ್ಲ ಮೇಡಮ್, ಬೇಕಾಗಿಲ್ಲ. ಸೊ ವೆನ್ ದ ಕೆಮಿಕಲ್ ಹ್ಯಾಸ್ ಬಿನ್ ಫಾರ್ಮುಲೇಟೆಡ್, ಇಟ್ ಇಸ್ ಆಲ್ರೆಡಿ ದೇರ್ ನಾ, ವೈ ಐ ಶುಡ್ ಯೂಸ್ ಇಟ್. ಯಾ ಪ್ಲೀಸ್.
All these trials with 20 liters.
Drone mounted sprayers.
But now, sir, in market or in the government, 10-liter drones are.
You have to again refill it and send the fellow again.
The cost of operation is increasing. Sir, if you are taking 2 times, 3 twice for.
That is there. That all depends on the weight of your purse. Depends on the capacity of a farmer. It all depends. Anything, ಮೇಡಮ್ ನೀವು ಈಗ ಮಾರ್ಕೆಟಲ್ಲಿ ರಿಜಿಸ್ಟರ್ಡ್ ಫಾರ್ಮುಲೇಷನ್ಸ್ ಏನಿದಾವಲ್ಲ, ದೇ ಆರ್ ಆಲ್ ಅಲೌಡ್ ಫಾರ್ ಸೇಲ್. ಏನು ಆಗಲ್ಲ, ನಥಿಂಗ್. ಡಿಸಲ್ಯೂಷನ್ ಅದು ಇದು ಎವ್ರಿಥಿಂಗ್ ಸೇಮ್. Now, one question comes like percentage of concentration of the insecticide in that is more. Because we are mixing in a less amount of water. Right? So, since the droplet size itself is less, the penetration is very fast. So, that way the pest control will be excellent. Any questions? Yes, sir. Of course, still KSNUAHS data, my data I have published. The data which I showed you in the carton, I have published, and KSNUAHS is still yet to be. She has already into. And of course, one information I wanted to bring it is, with this drone technology, now I am using application of drones for pheromone applications, drones for the pheromones, for the pink bollworm. This I am taking in 25 acres this season. Anytime between September to November, if you pass Raichur, please come. I'll show you entire my demonstration, drone mounted, normal sprayers. Okay, I have different formulations for pink bollworm control. Of course, that's a wonderful study which I have doing it and did it. You are most welcome to Raichur. You are most welcome. So, institution is there. My field studies right in the farmer's field. I am taking not less than 25 acres, one treatment each, directly in the farmer's field.
Can we request CIBRC, if the farmers they want to spray by using their drones, can reduce 25%?
The data from all the institutions has to be submitted so that we can really say, and I am sure with authenticated data from multi-location trials and many crops, certainly it will accept. Certainly, because they too want serve to the farmers by reducing at least the cost of the plant protection. ಇಲ್ಲ ಏನಾಗುತ್ತಂದರೆ ಪೆಸ್ಟಿಸೈಡ್ ಕಾಸ್ಟು ರಿಡ್ಯೂಸ್ ಆಗುತ್ತೆ ಅಂತಂದರೆ ಅವ್ರಿಗೆ ಪೆಸ್ಟಿಸೈಡ್ ಮಾರ್ಕೆಟ್ ಕಡಿಮೆ ಆಗುತ್ತೆ ಅನ್ನೋದು ಒಂದು ನೋಷನ್ ಬರುತ್ತೆ. ಇಲ್ಲ, ಅವರು ನೌ ದ ಎವ್ರಿ ಕಂಪನಿ ಈಸ್ ಕಮಿಂಗ್ ಔಟ್ ವಿತ್ ದ ವಿನ್ ಪ್ರಾಜೆಕ್ಟ್, ಲೈಕ್ ಪ್ರಾಬಬ್ಲಿ ಕೇಳಿರ್ತೀರ ನೀವು. ವಿನ್ ಪ್ರಾಜೆಕ್ಟ್ ಅಂದರೆ ದೇ ವಾಂಟೆಡ್ ಟು ಹ್ಯಾವ್ ದೇರ್ ಓನ್ ಡ್ರೋನ್ ಟೆಕ್ನಾಲಜಿ. ದೇ ವಾಂಟೆಡ್ ಟು ಯೂಸ್ ಆರ್ ಗಿವ್ ದ ಡ್ರೋನ್ಸ್ ಫಾರ್ ದಿ ಸ್ಪ್ರೇ ಸರ್ವಿಸ್ ಟು ದಿ ಫಾರ್ಮರ್ಸ್ and recommend their own chemicals. Yeah, say for example, so the farmer will inform one company, I have 10 acres of cotton. Okay, so which is almost 1 month old. So the person will come, he will study, he will suggest his own company chemical with his own drone. So the charge which he makes as compared to the hiring the drones, na, it will be less. Plus his chemical will go.
Sir, shut up.
It's a kind of.
Can you give the recommendation to the farmers by reducing 25%? The recommendation should be approved by the committee which has been suggested with the DGC.
Unless, correct.
Sir, the committee is here. Land Protection Advisor, CAP and DC, Kariyappa.
Hmm.
And also these are all the committee members.
Correct.
If you have to submit the report, then they will.
That is one part at the national level. At least at the university level, apex body is NARP, ZARC and ZREFC, where you can have the 2 years data, multi-location data, and convince with all those things. Yes, once the ZREC body accepts, I can use in my jurisdiction, na? Who is going to affect me like? We are telling now, we have the technical brochure. Yes, we have done it. And we are giving it technical brochure and pamphlets to farmers. Ready-made information, 4 years data, and what do you want? Like such a authenticated data, beautiful done. Like.
ಹೈ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಸ್ಪ್ರೇಯನ್ನು ಪೆಸ್ಟಿಸೈಡ್ಸ್ ಬೀಳಸಿ ಗೊತ್ತಾದರೆ ಅವರು ಹೈ ವಾಲ್ಯೂಮ್ ಸ್ಪ್ರೇಗೂ ರೆಕಮೆಂಡ್ ಮಾಡಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತಾರೆ.
ಸರ್ ಇದೆ ಬಿಸ್ನೆಸ್ ಇದೆ, ಬಟ್ ಅದೇ ಹೇಳ್ತೀನಲ್ಲ, ನೀಡ್ ಆಫ್ ದಿ ಅವರ್ ನಮ್ಮ ಫಾರ್ಮರ್ಸ್ಗೆ ಅವೇರ್ನೆಸ್ ಎಲ್ಲ ಹೇಳಿಬಿಟ್ಟು, ಸೊ ಈ ಥರ ಅಡ್ವಾಂಟೇಜ್ ಸರ್ ಫಾರ್ಮರ್ಸ್ಗೆ ಡ್ರೋನ್ದೆಲ್ಲ ಚೆನ್ನಾಗಿ ಗೊತ್ತಾದರೆ ಇದರಿಂದ ಇಷ್ಟು ಟೈಮ್ ಸೇವ್ ಆಗುತ್ತೆ, ಕಾಸ್ಟ್ ಸೇವ್ ಆಗುತ್ತೆ ಅಂತಂದರೆ ಅವ್ರು ಬಿಡೋದಿಲ್ಲ ಅವರು. ಸೊ ಡೆಫಿನೆಟ್ಲಿ ದೇ ವಿಲ್ ಗೋ. Slowly it is taking up, like, so compared to 2-3 years before and now, it is slowly increasing, like. Mate, any other questions? Thank you very much then. Thank you all.
Sir, thank you so much for providing lot of information on plant protection equipments and sharing your practical experience with the usage of pesticides in 2 crops. One is paddy and cotton, and how to reduce the pesticide. That is very interesting one and very curious information you have given, sir. On behalf of all the participants and on behalf of the organizing secretary and from KSNUAHS, I profusely thank you, sir. Thank you. Thank you so much.
I'll take some more 5 minutes just to show, maybe I don't know who is interested in taking interested of research in cotton and other things. I'll just share my experiences and you can think of using this technology. Just to show, I'm not going to take much time. So exhaustive work which I have done it on pink bowler actually. Just 5 minutes I'll take it because we have time. Okay, please. So pink bollworm is really national pest now. It's a very problematic pest because it has developed resistance to BT cotton and insecticides also. BT cotton as well as insecticides. So whatever insecticides, one nimsha. So whatever insecticide you say, it is going to be futile in the sense it is not going to give satisfactory control because of 2 reasons. One, resistance development, plus another is nature of the insect is such that it is internal borer. The fellow once it goes, whatever you spray, it will not reachable like. Next. Yeah, beda, cotton production of the idu beda. Next straight away go to. So the loss which causes actually the pink bollworm on BT cotton is almost 60%. In terms of acreage quintals, helbekandre, it is not less than 3 to 5 quintals per acre, even after 4 to 5 sprays. I repeat, per acre it will cause a loss to the tune of 3 to 5 quintals even after 5 to 6 rounds of sprays. 5 to 6 rounds of sprays, which is almost 5,000 rupees cost. Okay. Next. Of course, I don't want to go in detail. Pink bollworm, what it does. Next. Go ahead. Go ahead. Go ahead. Yeah, why it is problematic? I just did a couple of studies, because when the BT cotton was released 2002, they used to give in a one packet, they used to give 2 packets. One is BT cotton 450 grams and non-BT cotton 120 grams. So people didn't use non-BT cotton. It was supposed to be, they recommended, because it has to be grown all around the field, 5 rows, 20% of the area, 120 gram, adanella kotru. So but still our farmers, Indian farmers mentality is that they took it in a reverse way, reverse way. When the scientist told you had to grow 5 rows of non-BT cotton because the pink bollworm will come, it will feed on that, they took other way, Arey, BT cotton is meant for not to have the pink bollworm, but these people are saying, the 5 rows, it will invite a pink bollworm, then why to use the non-BT cotton? They just threw it away. Okay, they just threw it away and started growing only BT cotton. Instead of 1 packet, they went for 2 packets. Again, cost has increased. So that way, and pink bollworm, it is almost monophagy. Other than cotton, it doesn't want to feed. If the cotton is there, 90%, 99%, it will feed on the cotton only. It will not touch other crops. That being the case, for a fellow, cotton is the bread and butter. If it is not going to any other crop, then imagine, if the cotton is having the toxin, how long it can survive and sustain? Artha aitana heliddu? How long it can? It survived till almost 2014. 2002 to 2014, it was submissive. It sustained, it support, in the sense it has, okay. 14 onwards, people started reporting, including Yavatmal. It was a big issue, even in Raichur also. A pink bollworm has developed resistance, it is not going to be controlled, any amount of pesticides, isn't it? And farmer suicide, that, this, everything came into the national issues and other things like. So which means, no control measures are there because of non-compliance of refugee. Yaru use madilla. Allinda ivattin vargu use ಮಾಡ್ತಾ ಇಲ್ಲ. Nobody is using it. So what I did it is, you can see what are the other reasons why pink bollworm has increased antandre. In the cotton ginning mills, they just, after ginning the waste, they just throw it. They just throw it. They don't bother for that. From that also, the pink bollworm will cause menace up to 2 kilometers radius. Next, okay, sir. Next. You can see these are the gin mills in and around Raichur. I have geotagged it and placed the pheromone traps. And also I took the observations from a ginning mill. If the cotton is say 50 meters, 100 meters, half a kilometer, 1 kilometer, 2 kilometers distance, is that a infestation of the pink bollworm is more or less, which I did it. Next, okay, sir. You can see here 50, 100, 2 kilometers also I went. Last figure you can just see. Even at the 2 kilometers also 9.96, which means almost 10% damage. 10% damage even after spray. Nobody, no farmer will, oh, professor has taken a study, I should not spray. Nobody will leave that, isn't it? Ellaru spray madore. Next hogi. So ಇನ್ನೊಂದು ಜಿನ್ನಿಂಗ್ ನಲ್ಲಿ ಅಲ್ಲಿ ನೋಡಿ 10.46. Last figure I am just reading. 2 kilometers like. Next. One more gin mill, 10.99. So which means infestation will be much more if you don't bother about, because pink bollworm normally it undergoes diapause in the seeds under larval stage. It will be there for next season till next. ಈ ಥರ ಈವನ್ ನೋಡಿ ಇನ್ನೊಂದು ಮಜಾ ಫೀಲ್ಡ್ ಮಾಡಿ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಿದ್ದು ನಾನು. ನೆಕ್ಸ್ಟ್ ಹೋಗಿ ಸರ್. ವಾಟ್ ಐ ಡಿಡ್ ಈಸ್, ನಾರ್ಮಲಿ ಅವರ್ ಫಾರ್ಮರ್ಸ್ ದೇ ಲೀವ್ ದ ಕ್ರಾಪ್ ಆ್ಯಸ್ ಇಟ್ ಈಸ್. They leave the crop as it is. They don't bother even after 6 months also, because cotton is a 6 months crop, na? Okay. So after that also they just leave as it is. But the pink bollworm will be there, na, where it has to go, isn't it? So what I did is, in our IRM project now, after the crop age is over, you have to shred it, remove and incorporate. There is a machine called a shredder. This treatment I have done it, you can see here. And also some people on the standing crop, they just leave as it is. What I did was I just placed the cages just to know how much pink bollworm will come from the standing crop. This is one more treatment. This is cotton stalks. Now some people they remove and they will keep it on the bunds. On the field itself they just keep it, which is ready to put fire like. So for that also I have placed cages, and one more deep plowing also ಮಾಡಿದೆ. Now because in IPM we say deep plowing na. So next ಹೋಗಿ sir. You can see from this standing crop, heaped, shredded, everything, you can see the data. So heaped it is more, right? Shredded it is less, which is very, very less. And you can see deep plowing is also very less. So standing crop is also more. What it reflects? Which means if you leave the crop residues as it is, it will serve as a source of inoculum for the future, because cotton being a monocropping in that ecosystem. Normally people take every year. Next. Moth catchers ಅನ್ನು ಸಹಿತ ಅದರಲ್ಲಿ ತುಂಬ ಬಂದಿದೆ. So that's what I said. Even in our IPM, ನಾವು ಹೇಳ್ತೀವಿ IPM project, we normally give inputs, everything we give. But still, even IRM follow ಮಾಡಿದ್ರು, IPM follow ಮಾಡಿ, even after advocating IPM to the pink bowler, it's not giving satisfactory control. Which I am doing it since 6 years. IRM project funded by DBT from CSR Nagpur. Next hogi sir. So you can see here, by following IRM, what we could able to reduce is, this is cost benefit ratio na, 17,000 we can reduce it per hectare. I agree. Instead of many sprays, we can able to bring down some sprays in case of IRM or IPM project. Next hogi sir. But what I mean to say is that totally we cannot control the pink bollworm even after adopting IPM technology. What technology which I have developed is this splat or cremit technology. This cremit is nothing but controlled release emission mating interruption technology against pink bollworm. This is very simple. Pheromone traps, isn't it? Pheromone traps, there is a lure which has got artificial pheromone which has been placed, for which normally the males will be attracted, because the pheromone is produced by females, right? So normally same pheromone we have formulated in the form of paste. Next, this is the paste. This paste is looking as if it is a Dantkanti, ಅಲ್ಲ ರಾಮದೇವ್ ಬಾಬಾ ದಂತಕಾಂತಿ ಅನ್ನಂಗೆ ಅನ್ಸುತ್ತೆ. Baba Dantkanti, it is here. If you just paste it like this on a cotton, okay, the males will come, thinking that it's a female. Imagine, it will come thinking that it is a female, there won't be any female there, it will be confused. The fellow will live only for 6 days, male. Again, so it applies to human beings and insects also. All the 6 days it will not be younger. ಅದಕ್ಕೂ what is called childhood, teenage, old age, isn't it? For that also it will be 2 days is childhood, child age, 3rd and 4th is young age, during which he has to get partner. ಸಿಗಲೇಬೇಕಲ್ರಿ, ಪಾರ್ಟ್ನರ್ ಸಿಗಬೇಕು, ಹೌದಲ್ಲ? Then probably 5th and 6th is going to die. Okay, then so the fellow will wander. It will not get, the male will not get female, it will be get confused. It is called as mating confusion or mating disruption technology. We disrupt the male to go out, let it go anywhere, why to bother, isn't it? Ellaru hogli namge yaake beku. Okay, then suppose I applied very fresh it is, okay, the male moth has come, it has touched anta itkolli. So the paste has been stuck to its legs or mouth parts. ಅರ್ಥ ಆಯ್ತೀರಾ? Is it clear? Imagine paste I have applied very afresh. Male moth has come thinking that it is a female and it has touched. The paste has stuck to its mouth parts or legs. Already it has confused, the fellow will fly. It will go back. When it is going back, When it is going back, other males will think that this fellow is female. That is a, ಏನೋ ಅಂತಾರಲ್ಲ ಮಹಾಭಾರತದಾಗ ಯಾರನ್ನೋ ಇಟ್ಕೊಂಡು ಯಾರನ್ನೋ ಹೊಡೆದ್ರಂತೆ, ಯಾರನ್ನೋ ಮುಂದೆ ಇಟ್ಕೊಂಡು ಬಾಣ ಹೊಡೆದ್ರಂತಲ್ಲ ನವೀನ, ಹಂಗಾತಿದು ಅಲ್ವಾ? ಸೊ ದ ಮೇಲ್ ಕನ್ಫ್ಯೂಸಿಂಗ್ ಮೇಲ್ಸ್, ಇಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಆಟೋ ಕನ್ಫ್ಯೂಷನ್, ರೈಟ್? ರೈಟ್? So in total it will reduce the family planning. That's why I call it as insect family planning. Oviposition will be less, na? We are making the fellows to go out. Male will go. Then what about females? ಯಾರು ಹೇಳ್ತೀರಾ? Female also can come, na? Female normally doesn't like a plot where the pheromones are more. Already chemicals ಇರೋದ್ರಿಂದ what females thinks that, oh, already pheromone has been deposited my sister. She will think that, and she will be also be confused, and she will go off. Both will be confused, like, ಹೌದಾ? ಸೊ ದ್ಯಾಟ್ ವೇ ಮೇಟಿಂಗ್ ಡಿಸೆಪ್ಷನ್ ಮಾಡ್ತಿದ್ವಿ. ನಾನು ಯಾಕೆ ಹೇಳಿದೆ ಈ ಕಥೆ ಅಂದರೆ ಪ್ರಾಬಬ್ಲಿ ಪೀಪಲ್ ಶುಡ್ ನೋ ಇಟ್. ಆ್ಯಂಡ್ ಆಲ್ಸೋ ಸೇಮ್ ನಾ ದ ಪೇಸ್ಟ್ ವಿಚ್ ವಿ ಹ್ಯಾವ್ ಡನ್ ಇಟ್, ವಿ ಆರ್ ಫಾರ್ಮುಲೇಟಿಂಗ್ ಇನ್ ದಿ ಫಾರ್ಮ್ ಆಫ್ ಎ ಸ್ಪ್ರೇ. ದಟ್ ವಿ ಕ್ಯಾನ್ ಟೇಕ್ ಇಟ್ ಅಪ್ ಥ್ರೂ ಡ್ರೋನ್ಸ್. ನೆಕ್ಸ್ಟ್ ಅಕ್ಟೋಬರ್ ನವಂಬರ್ಗೆ ಅದೇ ಟಾರ್ಗೆಟ್ ನಮಗೆ. ಒಂದು 25 acres ಬ್ಲಾಕ್ ಮಾಡಿದ್ದೀವಿ. ಸೊ ವಿತ್ ದ ಹೆಲ್ಪ್ ಆಫ್ ಸುನೀಲ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಟೇಕ್ ಅಪ್ ದ ಸ್ಪ್ರೇ. I have that pheromone now readily available. Spray formulation is with me. One season na madidini. Through drone I wanted to try. Through drone, through tractor spray also I wanted to try. So which one is best and cost effective? Atara, so I wanted to do it. Is it clear? Idanna, this is also one such technology. This is going like a hot cake anta ಹೇಳ್ತೀನಿ ನಾನು. ನಾನು ಮಾಡಿದ್ದೀನಿ ಅಂತಲ್ಲ. This is good, and this is a answer for the pink bowler, because farmers are facing lot of problem of the pink, right? Next, this has to be taken applied 4 times anta ಹೇಳ್ತೀವಿ. Minimum 3, maximum 4. Okay, next please. Next, yeah, this I have done it in a very very larger area, almost 1000 acres ಮಾಡಿದ್ದೀನಿ ನಾನು ಇಲ್ಲಿ. This is the 2 years data. Other than that I have done 3-4 years multi-location trials, large scale demonstrations. Averi also, yes, when we came and did the demonstration and Krushi Mela, all those things. Next, this is the data. Next, okay sir. You can see here, with this technology the yield which is obtained is 33 versus 22. This is in the farmer's practice, which is almost 11 quintals difference. 11 quintals is because of avoiding the pest in the applied field. This is the one. Next, okay sir. Next. You can see here previous. You can see 72,000 is the net returns. Previous per hectare is beda. Even if I say 72,000 is exaggerated figures, at least with this technology 3 quintals per acre, which the pink bollworm is going to cause loss, we can reduce it. That much guaranteely I can say. 3 quintals into 7,000 minimum. 7,000 minimum antu cotton sigutte. It is 21,000 rupees minimum saving we have to do it. This is a, I would say, not that Srinivas has done it, which is great enough. It is a saver to the farming community, being a scientist and an entomologist rather. This is what I urge to my youngsters. Any seva, any little seva in reducing the cost will directly go to the, not Shiva, it is to the farmers, which is equivalent to Lord Shiva, serving to the Lord Shiva. Adde naan kaltid ade. Next, same technology, instead of paste we have the PB Ropel. I think my colleagues know it. This also is good, but thing is this requires 60 acres at a stretch, 1 point to apply. That's the biggest problem. Getting 60 acres at a stretch is difficult. Even if you get 60 acres at a stretch, is convincing farmers itself is a big task. Idannu ಮಾಡ್ತಾ ಇದ್ದೀನಿ. This also I am taking 60 acres, 2.5 acres and 5 acres also. ಯಾಕಂದರೆ ಇದು 60 acres nobody is practicing now. I wanted to bring down it to 2.5 hectares and 5 hectares this year. So that will it work like. As per recommendation, as of now, it is 160 threads, 160 ropes per acre, 60 acres at one stretch. That is a recommendation, because it has to work means minimum acreage is 60, which I am trying it to have 2.5 hectares and 5 hectares. Whether it will work or not, this season I am trying. So you can come in the month of October, November, you can see all these things. Same. Percent of chemical, the gossiplurin ಅಂತ ಕರಿತೀವಲ್ಲ, ಇದ್ರಾಗೂ ಸೇಮ್, ಅದ್ರಾಗೂ 4% ಇರುತ್ತೆ, ಇದ್ರಾಗೂ 4% ಇರುತ್ತೆ. ಬಿಕಾಸ್ ಈಗ ಏನಾಗುತ್ತೆ ಅಂದರೆ, ದಿಸ್ ವಿ ವಿಲ್ ಅಪ್ಲೈ ಇನ್ ದಿ when the crop is almost 30 days. The crop grows always. So to have effective mating reception, so 60 acres ಬೇಕು. ಯಾಕಂದರೆ ಇಲ್ಲಿ ಇಲ್ಲಿ ನಾವು ಹಚ್ಚೋದು 160 ಗ್ರಾಮ್, 160 ropes. ನಾವೇನು ಹೇಳ್ತೇವೆ ಪೇಸ್ಟ್, which we normally say the paste is 400 plants, not 400 tubes. 400 plants, 1 tube per acre. 400 plants, so that it will cover beautifully the 1 acre plot. But here it is insufficient. If you want to increase this number, the cost will increase. Cost will increase because the cost also it has to be taken into consideration. So that way it is. So these are all the technology which are very much helpful for area-wide pest management. We also call them as community-based pest management. For community-based pest management, drone is the best technology. ಅದಕ್ಕೆ ಹೇಳ್ತಾನೆ, ಅವನು ಏನಾರು ಕಂಪ್ನಿಯವ್ನು ಕರೆದ್ರೆ, ಸರ್ ನನಗೆ ಮಿನಿಮಮ್ 20 ಎಕರೆ ಕೊಡ್ಬೇಕು, ನನಗೆ ಹಾಗಾದ್ರೆ ಬರ್ತೇನೆ ಅಂತ ಹೇಳ್ತಾನೆ ನಾವು. ನನಗಿಲ್ಲಾಂದ್ರೆ ವರ್ಕೌಟ್ ಆಗಲ್ಲ ಅಂತ ಹೇಳ್ತಾನೆ. ಹಾಗಿದ್ದಾಗ ಕಮ್ಯುನಿಟಿ ಅಪ್ರೋಚ್ ಟೆಕ್ನಾಲಜಿ ಲೈಕ್ ದಿಸ್, it is very much good, very good. Next. Yeah, ಮೇಳ ಗೀಳ ಮಾಡಿದ್ದು. Next ಹೋಗಿ ಸರ್. This is Doordarshan TV. Yeah, this is next. Yeah, award, Bairak award. This is one such. This is, I went to Punjab and Haryana. There also we have given training programs to the dealers and farmers. Next, we went to Central Agriculture Minister and also appraised about the technology to have the area-wide management through drones. This is what the attempt I have made. Next, please. KST award for the state award for this technology. Next, please. Same public-private partnership from the Cotton Research Development Association, Haryana. This I got it. This is the photo. This is wonderful. This is my dream actually, but it came true. Like Putrudre Endowment Award for the Best Plant Protection Specialist, National Award, given by the great Ashok Dalwai Saab. Next, please. And this is again Best Extension Workers from GKVK Bengaluru in the month of December. So I got it. The Giriyappa Gowda Best Research and Extension Award. Like this is the one. Not to impress you people, like just to inspire you. Impression and inspiration, lot of difference. That's what, as an elder, as a senior person, I'm just here to inspire you. Please do that. So anything to the farmers, it will give it, you will get it back with a dividend on that. Thank you very much.
Thank you once again, sir, for sharing your rich experience to manage the pink bollworm through insect family planning. Now I request Organizing Secretary Naveen sir to present a small memento and certificate sir served as a resource person. Please.
Right. Anything, my phone number is with Naveen. Anything from my side, please, most welcome. Just mail me, I am very fast. Not in WhatsApp.
Thank you, sir. Thank you once again. So now we'll break for the lunch. Now the time is 1:30, 1:28. So we'll be back by 2:30. 1 hour is enough, I think. 4 members ಇದ್ದಾರೆ. ಅಲ್ಲ ನೀವು ರೆಡಿ ಇದ್ದೀರಿ, ನಿಮ್ಮನ್ನು ವೇಟ್ ಮಾಡಿಸ್ತಾರೆ ಅವರಿಗೋಸ್ಕರ. ಸಚಿನ್ Very good afternoon. Hope everyone has had your lunch. Fine, good. Again, it's a task to the resource person to engage you till up to 4:30 or a max of 5 o'clock. Okay. So now, once again, I call upon Dr. Sunil Sherwal sir, who is Assistant Professor of for Machinery and the Power Engineering. Morning, he has delivered the talk on role of drones in agriculture for revolutionizing crop management. So morning, he has explained where exactly we are using the agriculture drones in a different platforms. So how those platforms can be qualified now, because morning it was quantification. I think now it is a qualitative data. That is because of that is the most important is vegetative indices. So that is going to deliver a talk on effective drone mapping and also development of vegetation indices for the crop management, which is very, very important for particularly the plant pathologist, entomologist, and as well as the agronomist. So it is a very, very important. So please, I request once again Sunil sir.
So, ಏನಕ್ಕಂದ್ರೆ ಡ್ರೋನ್ ಅಂತ ಸ್ವಲ್ಪ ಇಂಟ್ರೆಸ್ಟ್ ಬಂದೇ ಬರುತ್ತೆ. ಅದರಲ್ಲಿ ಲಕ್ಕಿಲಿ ಸೆಕೆಂಡ್ ಇಯರ್ ಅದರಿಂದ ಬಹಳಷ್ಟು ಟಾಪಿಕ್ಸ್ ಕವರ್ ಆಗಿಲ್ಲ, ಹಂಗಾಗಿ ಸ್ವಲ್ಪ ಇಂಟ್ರೆಸ್ಟ್ ಬರ್ಬೋದು. ಬಟ್ ಆಫ್ಟರ್ 3, 4, 5 ಆದ ತಕ್ಷಣ ಸ್ವಲ್ಪ ರಿಪಿಟೇಷನ್ ಜಾಸ್ತಿ ಆಗಿ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. ಅವಾಗ ಮತ್ತೆ ಬೋರ್ ಆಗ್ತದೆ. ರೈಟ್. ಸೊ ಇನ್ ದ ಮಾರ್ನಿಂಗ್ ಜಸ್ಟ್ ಐ ಹ್ಯಾವ್ ಡಿಸ್ಕಸ್ ಸೊ ಜನರಲ್ ಕಂಪ್ಲೀಟ್ ಓವರ್ವ್ಯೂ ಆಫ್ ದಿ ಅಪ್ಲಿಕೇಶನ್ ಆಫ್ ದ ಡ್ರೋನ್. ಓಕೆ.
ಕಾರ್ಡ್ಲೆಸ್ ಅಲ್ಲಿ ಮಾತಾಡಬೇಕು.
Okay. Right. Since you have discussed in the morning just an overview about the different applications of the drones, so how best we can use those drones, and as a part of that, when we talk about the application part, because we need to get the data in a very effective manner so that we can draw a very good conclusion out of it. So whenever we want to analyze the data, so how clean and better the data we are going to collect, so based upon that only our results will be depending. That's why just I have selected this topic, that is the effective drone mapping. And once the mapping the parameters has been considered, once you collect the data, then we will go for the development of the vegetation indices for the required for the crop management. So here I have made into 2 parts. One is the this presentation part. So just I will be introducing what are the different mapping methods or the effective flight planning, mission planning methods are there. Just I will go through that one. Then after that, again the vegetation indices. So many of you may be mastered in that vegetation indices. I am not at may not be as best as you, some of you people. But I have defined some of the few vegetation indices, and again these vegetation indices will depend upon the individual targets. So what actually we are going to target, and these things can be varied and changed as per the requirement. There is no hard and fast rule that we need to follow these formulas only. Again, it is a customized formula. It can be customized, it can be on the basis of the trial and error, it can be calculated. So where we get the better results, so those indices can be adopted, and we can give a new name for those indices also. So then later on the second part, so just it is a practical part. I will show once we collect the images from the camera drone, so how to analyze and first how to process that thing, then how to analyze that thing. So for that I have selected one software which is available on paid basis, but I am showing you in the trial version. So I brought it, I installed it yesterday only. So I will just show you how can we use those collected images and how to make into an orthomosaic images, and how can we can process the thing, then how can we best develop those vegetation indices, different vegetation indices. So those things can be discussed in the second part. So coming for the this first part, so already we have seen regarding the in detail about, we have seen about the agricultural drones, general drones and agricultural drones. So because as I said, the agricultural drones or the drones which are very versatile in nature, that's why they can be easily adopted for many operations for agricultural purposes. So not only for any fixed operation. So because usually what happens whenever we take the crop cultivation, so it is very difficult for the person to reach each and every point in the field, and also it is a very cumbersome also. So to minimize those things, we can take the help of the technology, in that the drone is going to have a very important role, so that we can easily cover all over the area and target and the each point can be reached, and we can analyze and reach our target. So those things can be done. So that's why we can select drones for very good for surveillance or for precision agriculture purposes. So research and rescue missions, and also it can also be used for delivering of the goods also. Then so in this drones, so drones are just like what we are seeing, just like it is a technology, just like our mobile phone, so which is costing around, starting from around 4,000, 5,000, it may go up to in lakhs. So we can differentiate between those mobiles also, because depending upon the technologies, depending upon the features, depending upon the different sensors which we are using in those mobile phones. Similarly, depending upon the capability of the drone, how precise it is going to work, what are the different types of sensors or sensing elements we are using in these drones, the cost also varies. So also apart from that, we can combine with new coming cutting edge technologies, so high computational powers outside so that has been retrieved. So the combination of these things may give a very good tool for us for better analyzing the things. And these some of the applications, it is we can use these drones for mapping purposes. So once the mapping has been done, again it can be analyzed, so monitoring can be done. We can schedule the irrigation systems and plant diagnosis, disaster mitigation. So these things already we have discussed in the morning session. And of course, so if you want to effectively use these applications in a successive manner, then so we can have the effective flight mission planning. So that is very important. Where the drone has to fly, how it has to fly, and what are the things that it has to capture. So how much area it has to cover. Those things needs to be planned by us. So these are some of the key components for the drone flight plans. So flight planning means we can call it as a flight mission planning. We call it as a mission planning. So mission planning means once the drone is taking off from particular point, where it has to go and what are the areas it needs to cover. So for covering that area, what should be its travel line or travel path. So that path needs to be optimized, because we are having some of the next constraints are there. So we need to overcome those constraints. It may be the battery backup, it may be the limitations of the sensors. So some of the constraints are there. By keeping in mind about those constraints, we need to plan the things. So first one is the flight path, as I said. So we need to establish waypoints for effective navigations of this drone. Then it can be where hovering can be done, and the flying or the movement of the drone can be done, and the image can be acquired. Then the speed and heading. So what should be the operational speed that needs to be decided, and what should be the direction of movement of the drone. Those also plays a important role. And apart from that, the gimbal action. So gimbal, I think you may know the gimbal. Gimbal ಗೊತ್ತಿದೆಯಲ್ಲ? I think you may have heard the gimbal. It is a platform where the camera is mounted. So depending upon our area of interest, so the gimbal will changes the focus angle, that's all. So we can take the help of that gimbal actions. So once we talk about the autonomous functionality, means when we are giving the decision making capacity for the drones themselves, then it should take some decisions along with the safety measures. Okay, so otherwise what happens? Okay, if you are giving this mark, you are giving some geofencing and you give the go command for it, it will start flying, it will go, and it is blind in nature. If anything comes in between that its path, it is going to hit it. But it needs to think something. It needs to analyze the things. So whether there is any obstruction is there or not, it continues to monitor it. If obstruction is coming, what decision it has to take, that needs to be decided by itself. We need to give some function, some program to it. Okay, so this detection, this object is coming means you need to move to left or right, you need to avoid it, or you need to change your direction, in what way, you need to go upward or downward. So those commands or those things needs to be pre-programmed, and it has to be pre-trained for drones. And that is the one decision making abilities. Another is the fault tolerance, means if it is flying, something happens, some of its component may get failed. The best example is, say the battery has been completely discharged or it is about to discharge. Then what it has to do? It will directly fall down. So instead of that, we can give some command. We can write some program that once your battery reaches to 80%, you should do this action. Either you can come back to the original position, or it is severe means you land there only, but at a slower rate. So these commands can be pre-programmed. So already these kinds of programs has been adopted in nowadays, whatever the drones we are using now. But earlier what we have handled the drones, so these features were not available. So they used to fly, we used to continuously monitor the battery status in our transmitter itself. So allenaದರೂ ನಾವು ಸ್ವಲ್ಪ ಏನಾದರೂ ಅದನ್ನು ಸರಿಯಾಗಿ ನೋಡಲಿಲ್ಲ ಅಂತಂದ್ರೆ, we are not taken care means it is going to fall there only. So similar kind of crashes has been observed earlier days. But now we have got a very sophisticated drone technology, so these things has been already included in the systems. And one more important feature is the return to home feature. So in return to home feature means you are flying it, you are doing something, but something has happened there, your drone is going out of your control. So one simple button is there. So if you press it, so from where it has been taken its flight, it will come back to its original position. So it's a very important safety feature, we can say. So nowadays for all the drones it is having, and it is a compulsory for as per the DGCA guidelines. Then why do we need a flight planning, as I said? So what is the importance of that one? So we need to make sure that our drones captures the images at the right time and in the right place. So there should not be any repeatability of the images, or there should not be any missing of the images. So those things needs to be taken care properly. Then we do not want to control our drones all the times. Transmitted continuously we can't monitor it. It is very difficult. So once it within the site it is very difficult. Once it goes beyond our site means usually we will be taking the images at a height of 100 meters or 120 meters. Maximum 120 meters is allow. 120 meters it will be just looking like a small dot. So it is very difficult to visualize those things. So that's why it needs to be completely atomized. Even though it has been autonomous in nature, at the same time it has to cover our area of interest. Then we want to make sure that the drone is flying safely. So that's why we need to plan a proper mission planning. So that is very first thing. I think if anybody has undergone the training also, they are going to say first we need to see the safety. And that too, they used to say that while in training, we need to keep our mind very peace. If you are having a disturbed mind, then they are saying you should drop for flying. ಯಾರಾದರೂ ಡ್ರೋನ್ ಟ್ರೈನಿಂಗ್ ಮಾಡಿದರೆ ಫಸ್ಟ್ ಅದನ್ನೇ ಹೇಳ್ತಾರೆ ಅವರು. ಇಫ್ ಆರ್ ಅನ್ಕಂಫರ್ಟೇಬಲ್, ಇಫ್ ಆರ್ ಫೀಲಿಂಗ್ ಸಮ್ ಅನ್ಈಸಿನೆಸ್, ಡ್ರಾಪ್ ದಟ್ ಪ್ಲಾನ್. ಫೋರ್ಸ್ಫುಲ್ ಆಗಿ ಅದನ್ನು ಡ್ರೈವ್ ಮಾಡೋದು ಬೇಡ ಅಂತಾನೆ ಫಸ್ಟ್ ಸಜೆಷನ್ ಕೊಡೋದೇ ಅದನ್ನು ಅವರು. So safety we need to give the more importance here compared to the data generation. So these are some of the images that we can capture. So first one is, we can see we call it as an orthomosaic image. So where we are having the geolocations, and also we are having the RGB images where we can easily identify what is there on the ground. So this is known as, this kinds of things is known as the orthomosaic images. Second one, it is a point cloud or a 3D models. So actually whatever the image has been taken, it has been taken for that particular structure So whenever we are going for analyzing some structures, so these kinds of things will be done. So where the elevation, along with the images, the elevation is also taken care, and this 3D points has been framed, and it looks like the same structure as the original structure is there. Actually, this is not an actual image. So these are the points where the photographs has been taken. So that's why it is known as a point cloud models or a 3D models. Instead of all next when we process it, so whatever the images that has been taken at those points, those will automatically fixes there, and we can have an actual 3D image. And last one, that is a DEM model, that is a digital elevation model, where the elevation is very important for us for our analysis purpose. So these kinds of things can be analyzed. So this is the similar photo. The same Arthamasiak photo has been converted into a DEM. So that can be converted, where the important for us is the elevation. We need to find out the elevation. We can see wherever the red is there, it is having at a higher elevated place, and the darker or the green or black, wherever is there, that may be in a lower elevation. So these are the three types of requirements will be. So I think you can see these 5 pictures. It is clear. What is the difference between these images? Can anyone say? One is clarity, then images has been taken from the same drone, same camera. Then also there is some difference is there. Area coverage is more in some pictures. So in area coverage at the last picture is more compared to first one. As 1, 2, 3, 4, 5, the area coverage is more and more. So exactly, sir. So these are the images which has been taken at different altitudes, at different heights. So this is what I want to say is, if you vary the height, so these are the features we are getting. So if you are interested in these features, then this is a very good. In detail, we can go for a very high. If you want to have a detailed view, then it has to be flown at a lower levels. So these are images were taken at a different heights. As the height goes on increasing, we can see the more area is there, but the information what is available at pixel level is reducing. See, so these are the photos that has been taken at different heights. So of course, as we go for higher, the more area coverage will be there, but we are compromising with the details of the images. In each pixel, the images has been less. So higher means less photo for the same area. So how to measure or how to analyze those things? In what way? So we usually use this term GSD, ground sampling distance. So we can generally we can say in an understanding manner. So this GSD is nothing but it is a how big each pixel is on the ground. So already I think you may know the image. So image is made up of a number of small boxes, or we can say it as a pixels or picture elements. So each picture element is having its own digital numbers. Okay, so those we are allocating the digital numbers for each pixels, and what each pixel is representing on the ground. So that is known as a GSDs. For example, I will see in this image. So the width of the image is 400 pixels, 4000 pixels, and the height is 3000 pixels. So 4000 pixels are there in the horizontal line, in single line. In the vertical lines, 3000 pictures are there, pixels are there, elements are there. So as the number of pixels are more, so we call it as this much of megapixel cameras. So this is the pixels, what you are counting. So this is what, how to measure this GSD. So GSD is a simple formula where we are using this formula. So what is your height multiplied by the sensor height divided by focal length of the sensor into image height. So this will be giving your GSD in the GSD of the height of the image in the vertical lines. And similarly in the width only we are taking the what is the sensor width. So that no madam, sensor height alla. Sensor means it is nothing but it is a on rectangular element will be there. One just box is the one cardboard. It is a sensor where it is recording the responses of the light. Other the dimensions. Height and just like either. For example, you assume this is a sensor. ಅದರಲ್ಲಿರುವಂಥ ವಿಡ್ತ್ ಮತ್ತು ಲೆಂತ್ ಏನು ಹೇಳ್ತೀವಲ್ಲ, ಲೆಂತ್ನ ಹೈಟ್ ಅಂತ ಹೇಳ್ತಾ ಇದೀವಿ ಇಲ್ಲಿ, ವಿಡ್ತ್ನ ವಿಡ್ತ್ ಅಂತ ಹೇಳ್ತಾ ಇದೀವಿ ಅಷ್ಟೇ. So this is, for example, one camera with DJI Phantom 4 which is flying at 80 meters height. So the GSD for that is 2.36 centimeter per pixel. It means each pixel on the image is representing 2.36 centimeter on the ground. So it is able to identify, or it is able to differentiate 2.36 centimeter on the ground when you take the image from that sensor or from the camera at a height of 80 meters. That is meaning of this GST. So again, as I said, so those are the parameters of the sensors and also the image which is going to be captured by that one. But apart from that, so whenever we want to have a good image, so only taking one or two images may not be sufficient. For example, if I want to take the image of this classroom, okay, so I can take the image by standing here. If my sensor is able to capture whole class within the single picture, then it's good. But I am unable to get it. Of course, detailed view can't be get. So what the class person is doing, I am unable to see in that picture. But I want to focus on each and everybody. I can split into number of units. Then I will take picture here, 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 here. But there should be an overlapping among those pictures. Otherwise, we may be missing some information, or we may be missing some one person. So how much overlapping should be there? That should be decided. So here also in a similar fashion, we need to go for a overlapping of the images so that we can't avoid or we can't miss any of the single information out of the ground. So this is the overlapping technique what we are using. So these are the positions. First, second, third, 4, 5, 6. 1, 2, 3, 4, 5, 6. So these are the positions or the points where the images are taken by the camera. So when our vehicle reaches to first position, it will take one picture. Second position, second picture. Third position, third picture. Like that. So it is going to take around 6 pictures there. You can see the overlapping here. It is almost more than 50%. And you can see there the same pictures which has been taken by that image. It can be, if you are making in that fashion means. So those are the images 1, 2, 3, 4, 5, 6 position. Then it is coming back 7, 8, 9, 10, 11, 12 pictures which has taken. The forward overlapping, it has taken around 60% between the photos, and the side overlapping, it has taken around 20 to 40%. Maybe it may be 20, sometimes for 20% is there. You can see there is a shift in the images also. So what happens while flying, even though we are using a very highly accurate sensing element for the, or highly accurate GPS for our onboard GPS for the drones. So because of some windy nature, some wind, there will be a slight movement in the drone. So during that period, it can't take exactly the same image when it goes for the second position. You can see the first image it has taken up to this is the boundary line. Next it is going and taking the boundary line has been shifted there. Then third, it is coming on. So it will be somewhat variation. So those variations needs to be countered by keeping appropriate overlap. So you can see if we are not providing an enough overlapping, of course you are taking the 4 images of that particular area, but you are missing the center part. Some part you are going to miss. So this is about 75 to 80% overlap, which is recommended for the agricultural purposes and for mapping purposes. So we can have a very good image where the data missing is almost nil. But again, the problem is if you go for more overlapping, of course you are getting the data, but it is of no use. Unnecessarily you are using more time, you are using more resources. So it is a waste of time. So by trial and error, we have got that around 70 to 80% overlapping is required to have a very good data without any missing information. So usually we will keep around 75% overlapping. So this overlapping 75%, again, it depends upon the mission planners. ಸೊ ಫ್ಲೈಟ್ನ ಫ್ಲೈ ಮಾಡ್ಬೇಕಂದ್ರೆ ಮಿಷನ್ ಸಾಫ್ಟ್ವೇರ್ಸ್ ಬರುತ್ತೆ. ಸೊ ಸಮ್ ಸಾಫ್ಟ್ವೇರ್ಸ್ ಆರ್ ಗಿವಿಂಗ್ ಆಪ್ಷನ್ಸ್ ಫಾರ್ ಚೇಂಜಿಂಗ್ ದಿ ಓನ್ಲಿ ಒನ್ ಓವರ್ಲ್ಯಾಪಿಂಗ್, ದಟ್ ಈಸ್ ಫಾರ್ವರ್ಡ್ ಓವರ್ಲ್ಯಾಪಿಂಗ್. So same will be taken for the side overlapping also. But in some softwares they are providing both, we can adjust side overlapping and forward overlapping. See, even though why 50%, we may think that 50%, 60% is high overlapping, 70% is high. So this is the practical issues what we can see in the when we're taking the images. So if you are going for a 60% overlap here, when it is flying at a 300 feet height, so you can see we can have a best image. But when it is going on elevated place, so the same 60% now over that stockpile, it has been made into only 50% effective overlapping. Then as the height increases of the ground surface, then 30%, only one image. See, for this purpose, for this image, this information, we are having only one image. At least we need to have one image. Okay. But when we go for still higher terrain, there see, even though we are going for 60%, so some of the information, this gap, those information has been lost. So to counter these things, so 70 to 75% is 70 to 80% is a good option. If the terrain is very uneven, highly uneven, then higher overlaps needs to be taken. Or else we need to split it for almost ಒಂದು ಯೂನಿಫಾರ್ಮ್ ಏನು ಟೆರೇನ್ ಇರುತ್ತೆ ಅಲ್ಲಿ ತಗೊಂಡು ನೆಕ್ಸ್ಟ್ ಯೂನಿಫಾರ್ಮ್ಗೆ ಅಲ್ಲಿ ಹೋಗಿ ಮತ್ತೆ ನಾವು ಓವರ್ಲ್ಯಾಪಿಂಗ್ನ ಚೇಂಜ್ ಮಾಡ್ಕೋಬೇಕಾಗುತ್ತೆ. ಮೇಡಮ್ ಸಿ area covered is same. You can see, madam, here approximately we are having these 1, 2, 3, 4 and 4 images has been taken for this central part. So the information is almost same, it is no differences. But yenagate, as I said, if you are keeping 50% here only, then it will be not effective whenever there is a changes in the terrain. Yes, madam. These problems can be avoided. Even though we are taking these means, then also some missing will be there. Yenagatte, the practical issues ಏನಂತಂದ್ರೆ, while taking the images, something happens and the drone camera may not take the image. ಒಳಗಡೆ ಏನೋ something processing ಆಗಿ ಕೆಲವು ಟೈಮ್ ಮಿಸ್ ಆಗುತ್ತೆ ಮೇಡಮ್. But while coming back, it can be overlapped. ಅಲ್ಲಿಂದ ಅದನ್ನ ರಿಕವರ್ ಮಾಡ್ಕೋಬಹುದು ನೆಕ್ಸ್ಟ್. So this is the another thing. So once you take the images, then it has to be correctly rectified. So because whenever we are talk about the what you can say, analyzing what is the exact coordinates. So if you want to improve those measured coordinates, of course nowadays all the drones, especially the drones which are used for imaging purposes, so those will be having the onboard GPS system, sophisticated onboard GPS system. So these things can be avoided. But if you want to more accurate, up to 1 centimeter level of accuracy in the from where you want to connect from ground to that drone image, then what you can say, we are having an options to go for GCPs. So that is known as the ground control points. It is a very simple. On the ground we are marking those points like this. These points should be visible for drone camera, and we need to keep our own GPS meter there. We need to mark that what is the GPS location of that particular point. So once you are using in a software, there we are having an option for adding those GCPs. Ali now the GCPs madre, it is just like a verification purpose. See, like that we can take. See, once this is the image taken from the drone, you can see this is the point is a GCP point. So while analyzing in the laboratory, so we can mark those points as this is the GCP, or this is the coordinates mark madre. So it can be automatically ortho rectified. So as I said, nowadays whatever the drones we are getting, so already they are having a highly accurate onboard GPS system. So these are some of the components which are present in the drones, which can be used for image capturing purposes. So this is what, once you plan the things, once you make the area, so this is known as a, actually whatever the green color is there, that is the area of interest. And to have more accuracy, we can have these plus marks in Kanta. Plus marks is there, those are the GCPs which has been marked and which has been installed in the field. Then these lines, it is the path of the drone. So in these paths, the drone is going to fly, and whatever the points or whatever the dots you are seeing, so those dots are the where we are actually the images are captured by the drones.
So if you want to specify the path, will you take a shortest route and cover the distance?
Yes, sir. That's next part is, that was the algorithm's work. That is the algorithm's work. It has to be done. But right now, we still now ಮಾಡದ್ ಬೇಕಾಗಿಲ್ಲ, algorithms, everything is inbuilt. So just we can mark the boundaries. It will suggest some paths. Among those paths, we can select one. So you can see these are the overlaps of the images. So two images has been taken here. So one is overlapped with other. Similarly, the side overlaps also is there. So that's what. So in flight planning, so these things should be taken into account. So what ultimately the thing is, what is our goal and how much accurate data we require. So unnecessarily going for a high accurate data, if it is not required, then it is a waste of time, waste of resources, waste of money, everything. So simple information is required means we can go for higher points. So we need to take into account about the areas to be covered. So what is your desired accuracy, that is the GS is what I said. Then what should be the flight height, flight path, those should be decided. If you want to have a GCPs or not, that needs to be, we can decide that one. And what should be the overlaps, that is front overlaps, side overlaps. And for those things, what kinds of drones you are using. So these kinds of drones, it is very difficult to use these kinds of drones. These are meant for up to particular height. They are claiming it may go more than that height also, but the battery. So it may not give that much battery backup when we compared with other kinds of drones which are very suitable for those image capturing only. And of course, whatever things you are doing, it should be within our guidelines only. Whatever the guidelines is given by the DGs, it has to be followed. So these are some of the softwares which are used for drone mapping purposes only. So drone mapping for images for spraying, these are the some of the things which some of the softwares which are available. That is cost basis only. Free again the thing which is coming free, which is having its own disadvantages also. But one thing which we are using with not this one. So for this AgriBot, they have developed their own software. It is having its own. But even the freely available on the agri management and then so agri management software which is freely available, which can be connected with any flight control, can be used. So drone deploy, drone harmony. So these are the things, and drone deploy and precision hawk. So these are the leading ones which are widely used in European and USA, European countries and USA. So these are some of the things that is when once you map it. So some of the options it is going to show. So just I am showing this is the options which are available in the, I think it is of a drone deploy app. So you can directly by just by the map only by fingers we can mark the points, boundary lines of your field. So after marking it, automatically it will do the lines. There those lines will be depending upon these areas. So it is showing what is the duration is required for covering that area. So 7 minutes. It again depends upon the speed and height. So it is going to change. And what is the area you have selected? What is the resolution? That is the GSD. 2.1 inches per pixel, it is saying. Then what is your altitude? 400 feet is the altitude. So everything can be controlled. And again, what is your front overlap, side overlap, flight direction with respect to horizontal, what you can say, with flight controller, ಅದೊಂದು ನಮ್ಮ ಹತ್ರ ಒಂದು ಮ್ಯಾಪಲ್ಲೂ ಕಾಣಿಸುತ್ತೆ ಒಂದು ವಿತ್ ನಾರ್ತ್ಗೆ ಎಷ್ಟು ಬಿಟ್ಕೊಂಡು ಹೋಗಬೇಕು, ಡೈರೆಕ್ಷನ್ ಹೋಗಬೇಕು. ದೋಸ್ ಥಿಂಗ್ಸ್ ಕ್ಯಾನ್ ಬಿ ಚೇಂಜ್, ಬಟ್ ದೀಸ್ ಕೈಂಡ್ಸ್ ಆಫ್ ಆಪರೇಷನ್ಸ್ ಮೇ ನಾಟ್ ಬಿ ಅವೈಲೇಬಲ್ ಇನ್ ಫ್ರೀಲಿ ಅವೈಲೇಬಲ್ ಸಾಫ್ಟ್ವೇರ್ಸ್. What is the flight speed? So everything can be adjusted here. So what we have seen, so those are the maps which are automatically generated by the software itself. But behind that, so on the background, some things is happening. So everything what we are using as a digital technology, so we may feel very easy to operate it. Even for your mobile also, just it's a screen, when its light is coming there, then it operates in different manner. If you open a different application, it operates in a different manner. So whatever we are touching the finger on the screen, it is something is happening in the background. So what is happening in the background? So for to understand that, just I have taken some few slides are there. I will not go deep into it. So these are some of the paths that are there which are used before the coming of those softwares. ಇದಕ್ಕಿಂತ ಮುಂಚೆ ಏನು ಮಾಡ್ತಾ ಇದ್ರು, ಮ್ಯಾನ್ಯುವಲಿ ವಿ ನೀಡ್ ಟು ಸೆಲೆಕ್ಟ್ ದೀಸ್ ಥಿಂಗ್ಸ್, ವಿ ನೀಡ್ ಟು ಫೈಂಡ್ ಔಟ್ ದ ಥಿಂಗ್ಸ್ ಆ್ಯಂಡ್ ಆಪ್ಟಿಮೈಸ್ ಎಲ್ಲನೂ ಮಾಡಿ ಅದನ್ನು ಫೀಡ್ ಮಾಡ್ತಾ ಇದ್ರು ಡ್ರೋನಲ್ಲಿ. But nowadays it is not required. But then also, so some of the paths I want to just discuss. So this is known as a grid flight path. So completely it is a grid. So complete grid ಅಲ್ಲಿ drone flight ಮಾಡುತ್ತೆ. So it will be maybe it will be starting from this point. So in zigzag manner, it is going to cover this field. After coming to this end, then it will be starting from this end. So complete agi, whatever the information, more information is required under those situations, we are using this one. But here what happens, since we are going for multiple flights, we can minimize the overlaps. Overlapping percentage 80% ಬೇಕಾಗಲ್ಲ, we can go up to less than 50% overlapping can be taken. But ಇಲ್ಲೇನಾಗುತ್ತೆ, the number of what you can say, the waypoints will be more, the passes will be more. That's why more images will be covered. So these things can be used wherever we are having a very what you can say, undulated terrain, and the region of interest is very much important for us. We have very detailed study we are going to take. Under those situations, this grid flight path can be used. So another flight path, that is the spiral flight path. So this is the movement of the drone as the figure image is showing. So the movement is just like in the spiral manner, in circular manner. So these things are used wherever you want to capture the image of any 3D building or structures or building structures. So if you want to what you can say, build a map for any old temple or structure like that things, some things surveying has to be done. So under those conditions, these kinds of spiral paths are used for just like a wind turbines. So adneಲ್ಲ mapping ಮಾಡಕ್ಕೆ, ಅದನ್ನ ಸ್ಟಡಿ ಮಾಡಬೇಕಾಗಿತ್ತಂದ್ರೆ we can go for these kinds of paths. So these paths we are not using in our agriculture sectors. And another one is the lawn mower flight path, we are saying it. So it's a very simple, most commonly used one. So maximum information we can get it. But here the number of passes will be less, but we need to keep 70 to 80% of overlapping is compulsory here. So this is the path what we are following for the aerial photography. So simple, the flight will be making a flying in a parallel line in zigzag way. So another point or another method is waypoint navigation. So waypoint navigation means, of course, we are having this area. So in that area, so if you are saying the drone should follow this path or follow these, it has to reach these points, we need to give that command. Then how it has to be followed, so it will be again decided by itself. So we need to say, so these points needs to be it has to cover, or in sometimes what happens, it is ulta, it's just a reverse. Something is, obstacles are there at these points, we can say these are the obstacles you need to avoid. We can give two commands, one is to follow it, to not follow it, or to cover it or not to cover it. Those things can be done. If obstacles are there, we can mark those obstacles that path will be automatically, and in no way the drone is going to take this path. Ee path alladu togolala. It can be done like that.
Irrespective of the distance between 2 points.
Yes, ma'am.
Like if the distance is more, then also it goes differently.
Yes, ma'am. Like, no issues. Then of course the circular flight path, it is also wherever usually we are using in the film industries these things. So by taking the videograph in all the directions, flying ಮಾಡ್ಕೊಂಡು ಏನೇನೋ ತಗೊಂತಾ ಇರ್ತಾರಲ್ಲ. So under those situations also, if it is run by autonomous mode, so these commands will be used there, or for inspection of the structures or reservoirs, dams, something. So for some moreover, that's for surveying purposes and for inspection purposes, we are using this path. Another one is the parallel transect path. So it is just like the lawnmower path only. Only difference is we are not covering these things. We are not joining these things. So usually for spraying purposes, we are using this. Spraying in ಮಾಡ್ತಾ ಇದೀವಿ. Once we start, the path has been started from point 1 to 2. Then 2 to 3, there is no spraying will be done. ಅಲ್ಲಿ sprayer off ಆಗುತ್ತೆ. Then 3 to 4, again spraying will be continued. 4 to 5, spray will stop. 5 to 6, spray ಆಗುತ್ತೆ. 6 to 7, spraying will be stopped. So it is not required there spraying. So those kinds of paths will be decided by followed the parallel transect path. ಈ ಡಿಸೈನ್ ಅಲ್ಲಿ ಫಾಲೋ ಮಾಡ್ತೀವಿ. And another important thing is the terrain following flight path. So depending upon the different terrains for a particular height, once you fix the particular height and it is having some terrain sensing sensor, ground sensing sensor, then it will follow the same path. So usually it can be used in our field crops by giving the crop height as a terrain. If you consider the crop canopy as a terrain, depending upon the crop canopy, the height can be adjusted. The height of spraying or height of something application can be varied. And another thing is the point of interest flight path. So here we need to provide it whatever the points of interest are there, and whatever the area it is coming within that region, it is going to cover all these things. There is a difference between whatever we have seen in the earlier one. Waypoint navigation. Here the path is connected those way paths or waypoints. But here you need to give only these points. ಈ ಪಾಯಿಂಟ್ಸ್ ನಾವೆಲ್ಲ ಈ ತರ ನಮ್ದು ರೀಜನ್ ಆಫ್ ಇಂಟ್ರೆಸ್ಟ್ ನ ಆ ತರ ಹಾಕಿದ್ರೆ, then the path actually created is here. Orange line ಕಾಣ್ತಿದೆಯಲ್ಲ, that is the path that has been created. So that when the drone is passing through that path, it is covering all those points. ಎಲ್ಲ ಪಾಯಿಂಟ್ಸ್ ಅದರಲ್ಲಿ ಕವರ್ ಆಗಿರುತ್ತೆ. Okay, so those are the different paths that are usually we are using for mission planning purposes. Among them, the most commonly used is the parallel path. Okay, these are some of the form analysis. As I said, the sensor, when we talk about the sensor integration, here the two things are very important. So one is the integration, whatever the drone we are selecting and whatever the softwares we are selecting, that needs to be easily integrated with the existing drones. So ನಮ್ಮ ಹತ್ರ high capacity drones ಇದೆ, high capacity sensors ಇದೆ, but it is unable to fit to the existing drone, means it is a waste of time, waste of money. Okay, so whatever the things we are purchasing or whatever taking, those things should be interoperability. And at the same time, so whatever the tools you are selecting, so that is also important. So these kinds of RGB cameras, LiDAR, and then multispectral cameras, different sensors. So these are the sensors which are fixed for the each flight passes, and we can take the images. So for regarding the data processing and the analysis, so we should have some processing, pre-processing and post-processing softwares, which should be very sophisticated in nature, which has to be rigorously used and because when we produce a very good input for the machine learning algorithms, then only we are able to get a very good output. And for machine learning algorithms, it can be used for interpreting data, generating the detailed maps or models. So again, the machine learning algorithms will be depending upon our end output. So the one thing which is suitable for me may not be suitable for your purpose. Again, it depends upon a type of target what we are aiming to. So regarding the mission planning algorithms, which will be running in the background, as I said. So background now in points kotirthi now. So depending upon the points, the path will be decided by the system itself. So for to run those systems, the system should be fitted with the predetermined or pre-evaluated different mission planning algorithms. So already they will be fitted in them, so that we can have an efficient flight plannings. So there are some of the algorithms are there. So these algorithms, see whenever algorithms are we talking, so these are something restrictions or something that needs to be taken care. That is what is the airspace restriction, what is the flight altitude limits, and some specific requirements are there. So any constraints ide, any requirements ide, everything should be considered, and the decision should be taken by the algorithms. So there are some of the algorithms are there which are there. One is the traveling salesman problem algorithm. So these are the different types of algorithms which are running in the background of the system and for developing those flight paths. One is the CPP algorithms are there. Then grid-based approaches, A-star algorithms, then genetic algorithms. So these are some of the algorithms which are used for specific conditions. So another is a particle swarm optimization algorithm, reinforcement learning. So this PS algorithm usually we will be seeing. So whenever there is some drone shows are there, on the hundreds of drones they are taking and making some different designs and different lightings, even though they are not crashing with each other. ಆಮೇಲೆ ಅವರು ಒಂದೇ ಡ್ರೋನ್ನ ಕಂಟ್ರೋಲ್ ಮಾಡ್ತಾ ಇರ್ತಾರೆ. ಸೊ ರಿಮೈನಿಂಗ್ ಡ್ರೋನ್ಸ್ ಆರ್ ಕಂಟ್ರೋಲ್ಡ್ ಬೈ ದ ಮಾಸ್ಟರ್ ಡ್ರೋನ್, ಆ್ಯಂಡ್ ದೋಸ್ ಥಿಂಗ್ಸ್ ವಿಲ್ ಬಿ ಡಿಸೈಡೆಡ್ ಬೈ ದಿಸ್ ಅಲ್ಗಾರಿಥಮ್, ದಟ್ ಇಸ್ ದ ಪಾರ್ಟಿಕಲ್ ಸ್ವಾಮ್ ಆಪ್ಟಿಮೈಸೇಷನ್ ಅಲ್ಗಾರಿಥಮ್. ಸೊ ಈ ಅಲ್ಗಾರಿಥಮ್ ಅದನ್ನ ಎಲ್ಲ ನಾವು ಮ್ಯಾನೇಜ್ ಮಾಡ್ತಿರ್ತಾರೆ. ಇನ್ reinforcement learning means already we know that ನೀವು ಕ್ಲಾಸಿಫಿಕೇಶನ್ ಮಾಡ್ತೀವಿ reinforcement based upon the experience, based upon the comments previously whatever we have given, ಹಿಸ್ಟ್ರಿ ಮೇಲೆ ಅದು ಫರ್ದರ್ ಇಂಪ್ರೂವ್ಮೆಂಟ್ ಅದರಲ್ಲಿ ಚಾನ್ಸಸ್ ಇರುತ್ತೆ. So these are some of the advanced technologies in the mission planning, that is the integration of artificial intelligence and machine learning. So these things are going on, and still further improvements are required, and those are already including in the system. Then as I said, some of the challenges are there which needs to be considered for mission planning. So the main issue is the battery constraint, as I said. So battery is the major issue. Based upon that battery requirement only, as I said, one of the things that I shown 7 minutes ಅಂತ ತೋರಿಸ್ತಾ ಇದೆ ಅದು. So 7 minutes backup ನಿಮ್ದು ಬ್ಯಾಟ್ರಿ ಬರುತ್ತೆ ಇಲ್ಲ ಅಂತ ಅನ್ನೋದು we need to think of that one. Okay, but again it will be based upon the reinforced learning. ಏನಾದರೂ ಅದರಲ್ಲಿ ಇತ್ತಂತಂದ್ರೆ it's the software itself, it will be taking that parameter. For example, when flying in the last time, so with single set of battery, your flight maybe went for only 5 minutes. Even though it requires 7 minutes, it will not show 7, it will say 5 minutes, and this is the maximum area. ಅದಕ್ಕಿಂತ ನೀವು ಜಾಸ್ತಿ ಏನಾದರೂ ಏರಿಯಾ ಕೊಟ್ಟರೆ it will show in a red mark. Okay, red mark ಬಂತಂದ್ರೆ ಆ ಏರಿಯಾ ಕವರ್ ಆಗಲ್ಲ ಅಂತ ಅರ್ಥ. ನೀವು ಮಾರ್ಕ್ ಮಾಡಿರ್ತೀರಾ, but it is not covered by your images because of some constrictions. And of course, there is an issue with interoperability and standardization, because since we are having the different diverse technologies, various applications are there. So with one drone, we may not integrate all the sensors which are available in the market. So it is very difficult because some kind of sensors provided by some vendor, that sensor may not be suitable for the existing drone. Again, he is having his own drone. He is saying our drone, we have the same problem. So we are already having that multispectral camera with along with the drone, which is costing around 24.5 lakhs. That's already ತಗೊಂಡಿದ್ದೀವಿ. But when we talk about that thermal sensor, he is saying that sir, thermal sensor is there, but it is not suitable for your drone. You need to purchase it separately, which is costing around 15 lakhs. Unnecessary, because the sensor is costing around only 3 lakhs. So 3 lakhs ನನಗೆ integration ಆಗ್ತಾ ಇತ್ತು ಅಂತಂದ್ರೆ within 3 lakhs I can do that job. Otherwise I need to extra pay 12 lakhs for that drone only. So that is the issue. So this is still constant is there. And of course, as I said, even within the manufacturers only, so if the parts are broken, parts are failed, means again we need to approach the same manufacturer. Other parts are not suitable for those drones. So ಈ ಥರ issues ಇದೆ. These are the current going issues, and many of them, compared to what we have seen in the last 5 years, now almost many of the problems has been solved. So many diversification done, and standard components are also using by our companies. So ಇದು ಯಾಕಾಯ್ತಂದ್ರೆ ಇಷ್ಟು ಫಸ್ಟು ಮುಂಚೆ ಏನಾಗ್ತಾ ಇತ್ತು, ಎವ್ರಿಥಿಂಗ್ ವಿ ಆರ್ ಡಿಪೆಂಡಿಂಗ್ ಆನ್ ಚೈನಾ. Complete drone unit we used to import from the China, and once the company which is selling that drone from China to the vendors of the Indian companies, ಒಂದು ವರ್ಷ ಬಿಟ್ಟು ಅವ್ರ ಹತ್ರ ಹೋದರೆ ದೇ ಹ್ಯಾವ್ ಚೇಂಜ್ ದೇರ್ ಮಾಡಲ್. ಚೈನಾದವ್ರ ಮಾಡಲ್ ಚೇಂಜ್ ಆಗ್ತಾ ಇರುತ್ತೆ ಅವ್ರ ಹತ್ರ ಕಂಟಿನ್ಯೂಸ್ ಆಗಿ. ದೇ ಆರ್ ನಾಟ್ ಹ್ಯಾವಿಂಗ್ ದ ಸ್ಪೇರ್ಸ್. ಸೊ ವೆನ್ ದೇ ಆರ್ ನಾಟ್ ಸಪ್ಲೈಯಿಂಗ್ ದ ಸ್ಪೇರ್ಸ್ ಫಾರ್ ದೆಮ್, ಹೌ ಕ್ಯಾನ್ ದೇ ಸಪ್ಲೈ ಟು ಅಸ್? ಸೊ ಈ ಇಶ್ಯೂ ಬರ್ತಾ ಇತ್ತು. ಬಟ್ ಈಗೇನಾಗಿದೆ, ಸಿನ್ಸ್ ದ ಗೌರ್ಮೆಂಟ್ ಹ್ಯಾಸ್ ಬ್ಯಾನ್ಡ್ ದ ಕಂಪ್ಲೀಟ್ ಇಂಪೋರ್ಟಿಂಗ್ ಆಫ್ ದ drone, so they only the components import is allowed. So when you there is a demand for the components, so you will give the components in terms of thousands of orders. So ಯಾವುದೋ ಒಂದು ಮೋಟರ್ ಬೇಕಂತಂದರೆ 1 motor 2 motors ನಾವು ಇಂಪೋರ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಲ್ಲ. ವಿ ವಿಲ್ ಸೇ 100 200 500 ಕಂಪ್ನಿ ಕೆಪಾಸಿಟಿ ಮೇಲೆ 1000 ಮೋಟರ್ಸ್ ನಮ್ಗೆ ಬೇಕಾಗಿದೆ ತೊಗೊಳ್ತೀರಾ. ESC ಇಷ್ಟು ಬೇಕಾಗಿದೆ, ಫ್ಲೈಟ್ ಕಂಟ್ರೋಲ್ ಎಷ್ಟು ಬೇಕಾಗಿದೆ, ಎಲ್ಲನೂ ತೊಗೊಂಡು ಬಂದು ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಫ್ಯಾಬ್ರಿಕೇಟ್ ಹಿಯರ್ ಇಟ್ ಸೆಲ್ಫ್. ಸೊ ಈ ಥರ ಆದಾಗ ಏನಾಗುತ್ತೆ, ವಿ ಕ್ಯಾನ್ ಮ್ಯಾನೇಜ್ ದೋಸ್ lacunas that we are facing because of that shortage of those components. So ಅದಕ್ಕೆ ಈಗ ನಾವು ಅಷ್ಟು ಶಾರ್ಟೇಜ್ ನಾವು ಕಾಣಿಸ್ತಾ ಇಲ್ಲ. ಬಟ್ ಅಗೇನ್ ಆಫ್ ಕೋರ್ಸ್ there is a issue with the service providing. ಇವ್ರ ಹತ್ರ ಕಾಂಪೊನೆಂಟ್ ಇದ್ರೂ ಕೂಡ we need to go to them, get repaired. ಅವ್ರು ನಮ್ಮ ಹತ್ರ ಬಂದು ರಿಪೇರ್ ಮಾಡಲ್ಲ. This is the issue. Okay. Of course in ಶಾರ್ಟ್ ಪೀರಿಯಡ್ ಅದನ್ನು ಕೂಡ ಇದಾಗುತ್ತೆ. So cost, because we need to think of the what is the initial cost, as it will be high because it is having the sophisticated sensors we are using, and for a particular sensors, as I said, it is having its own drone system also. So initial cost and the operational cost will be more. Then we need to assess what is the return on investment, how much return on investment is there. That things needs to be calculated. Of course it is going to come on a higher side only, sorry, a lower side only, ROI. So after that, so just I am switching for the mapping system. So just here I am going to discuss what is the mapping and how best we can do that one, and what are the different indices are there. So high resolution mapping. So because I am saying it is high resolution, since we are taking it from drone system. So whatever the resolutions we are getting, it is comparatively higher than the satellite images. So a high resolution mapping means which is a creation of a detailed and accurate map. Those provide a close-up view of a specific area with a high details. You can see the clarity where you can easily identify where is the tree is there, where is the crop is there, and again something in between within the crop, different types of crops can be identified in those images. So at least it should give those values or those images. If satellite alli enagutte, it will give complete. You may miss this information. This strip nimge kanalla completely onde barutte, because that entire area may covered in only 1 pixel there. 1 pixel ಅಲ್ಲಿ ಬಂತಂದ್ರೆ ಎಲ್ಲಾನು ಸೇರಿಸೋದಕ್ಕೆ ಒಂದೇ ಅಂತ ಅರ್ಥ ಅದು.
Sir, is there any specific standard for high resolution? So
Standards means, sir?
when we say the high resolution image, what is the criteria?
That's what it is. No, it is not having any definite values for that. Only just we should decide. For me, this image, one image may be a high definition for me. It may not be HD for you. And ನಿಮಗೆ ಇರೋದು HD, ನನಗೆ ಇನ್ನೂ ಇನ್ಫಾರ್ಮೇಷನ್ ಬೇಕಂತಂದರೆ ನೀವು ಫುಲ್ ಹೈ ಅನ್ಬೋದು, ನನಗೆ ಹೈ ಇರಲಿಕ್ಕಿಲ್ಲ ಅದು. It again depends upon the application where we are going to use. That's what. Okay. So this is the why we need to go for a drone mapping. So in the morning session, somebody has asked the question, what is the difference between those two? So these are the differences. In satellite, whatever you're getting, so that will be having a low spatial resolution we will be having, and but in a UAV we will be getting in a very high spatial resolutions, and also the cost is also lesser compared to the satellite data. And in satellites, as I said, it is a predefined one. So date is defined, time is bound. At that period only we are going to get. We can't change that one. Due to some adverse effect or due to some reasons, if it is the data has been lost, means it is lost. We can't have that data. So those things can be done, and those data, whatever the data we are going to miss through satellites, can be taken through UAVs. And high cost of operation, because it again depends upon the companies or the organizations who are providing this data, how accuracy and how much Suppose if you are interested to get a data for say around 1 to 10, 1 hectare area, ಅಷ್ಟೇ ನಮ್ಗೆ ಬೇಕಾಗಿದೆ. We can't take 1 hectare area. We need to purchase whatever the data is available with them. No, they will say I am having a 50 hectare data, you need to purchase that one. ಸೊ ಅಷ್ಟು 50 ಹೆಕ್ಟೇರ್ ಕಾಸ್ಟ್ ಕೊಟ್ಟು ನೀವು 1 ಹೆಕ್ಟೇರ್ ಕೆಲಸ ಮಾಡ್ಕೋಬೇಕಾಗತ್ತೆ ಅಲ್ಲಿ. ಸೊ ದಟ್ಸ್ ವೈ ಇಟ್ ಈಸ್ ಸಮ್ ವಾಟ್ ಕಾಸ್ಟ್ಲಿಯರ್ ಕಂಪೇರ್ಡ್ ಟು ಕಾಸ್ಟ್ ಆಫ್ ಆಪರೇಷನ್ ಇಸ್ ಹೈಯರ್ ಇನ್ ಕೇಸ್ ಆಫ್ ದಿ satellites. And there the sensor is fixed, we can't change it. For a particular satellite, that will be the bandwidth will be fixed, the sensors will be fixed, we need to adjust with those sensors only. But here we are having an option, we can go for a multispectral. If you are having option, we can go for a hyperspectral sensors for the same drone, or we can go for a thermal sensors. So whatever sensors we require, or we LiDAR, we can go for those sensors can be changed here. So of course, when we talk about the remote sensing options or image analysis, so these are the 4 things we are usually come across. That is the spatial resolution, spectral resolution, radiometric resolution, and temporal resolution. So as I said earlier only, very much mastered in these parameters. So just for the information purpose, I have brought it. Many of you people sitting here may be having more knowledge than me. So just to brush up the knowledge, just I brought these things. So spatial resolution means, so it is in each pixel how much it is going to represent the actual ground surface in simple manner. So one pixel alli ಎಷ್ಟು area cover ಆಗ್ತಾ ಇದೆ. Okay. So for example, if I want to take the 2 meter by 2 meter as a ground surface, in my 2 meter, this table is coming, this red carpet is coming, some part of the table is also coming. Aden ಮಾಡುತ್ತೆ complete, it will, for that it is 1 unit. It will assign only one value. It will not differentiate. Is within that pixel, this is the table, this is red, this is table, ಅದು represent ಮಾಡಲ್ಲ. ಅದೇನು ಹೇಳುತ್ತೆ? It will give some number. Suppose if you want to have an accurate means, then that 2 meter by 2 meter has to be divided into smaller size, say 50 centimeter, 50 centimeter. So ಅವಾಗ ಏನಾಗುತ್ತೆ, ಈ 50 centimeter ಏನೋ ಒಂದೇನೋ ಬೇರೆ ನಂಬರ್ ಕೊಡುತ್ತೆ. We can say something is different is there. So like that, we can have the spatial resolution. And in spectral resolution means the spectral bands. So in which bands it is interested, and this is the amount of information that an image which is determined by the number of wavelengths. So how many the image is captured in how many bands? What are the reflectance values in the different bands? So multispectral RGB is the 3 bands, multispectral 4 to 10 bands. Then we go for hyperspectral up to 100 or 200, 300 bands. Then we go for ultraspectral, which is in terms of 700, 800, thousands of bands. So depending upon the how much spatial, spectral resolution is there, it depends upon the how many bands how many bands you are getting the informations. Of course, the radiometric resolution means, so these are the reflectance values within the same band. How much variations in the reflections I can measure. So suppose if I am getting the reflection from the system, say it is giving a reflection, say value is around 0.5 one part, another part it is giving 0.51, next part is giving 0.55. I may not recognize, I may not differentiate 0.5 and 0.51. I may recognize 0.5 and 0.55. So my resolution for the radiometric is 0.05. Okay, like that the spatial radiometric resolution will be there within the same bands. So this decided by these bits. 8 images will be classified into 8-bit, 1-bit, 2-bit, 8-bit data. So in 8-bit data means, so it is a grayscale image which is having 256 number of variations, like that. Of course, the temporal resolution means it is the based upon the time to time, temporal, what are the changes are there. If you are able to measure that one, then those kinds of resolutions are known as temporal resolutions. So these temporal resolutions will be important for the satellite data. For the drone data, it is not much important, because we are having an option whenever you want, we can take it.
It will be more useful than forecast.
Which one, sir?
Temporal resolution.
No, sir. Temporal resolution will be for the image capturing devices. ಈಗ ಏನಾಗುತ್ತೆ ನಮಗೆ ಯಾಕೆ ಸ್ಯಾಟಲೈಟ್ ಹೇಳೋದಂದ್ರೆ there may be 5 satellites for example. So one satellite may be repeating for every 5 days. Another one is repeating for 10 days. 15 days ಬರ್ಬೋದು. So for the spatial temporal resolution for one satellite is, we can say 5 days resolution. ಆ ಥರ. ಬಟ್ ನಮಗೆ ಡ್ರೋನಲ್ಲಿ ಇದು ಬರಲ್ಲ. ನಮ್ಗೆ ಬೇಕಂದರೆ 5 days ತೊಗೋಬೋದು, 1 day ತೊಗೋಬೋದು, 10 days ತೊಗೋಬೋದು. It depends on us. So these are the image collection processing using the drone. So first, as I said, we have discussed, that is the mission planning is very important. So depending upon the area of interest, the mission planning can be done. Later, the selection of a drone and which type of sensor you are going to integrate for your drone, that needs to be decided. After that, the pre-flight checks has to be done. So pre-flight checks means what is the altitude, what is the overlapping, what is the speed, how much battery is there, everything can be checked. Then it has to be fed in the flight planning software, where the planning will be done, and navigation takeoff will be done through that command. So once then later on, after going up, it will be taking the images, it will be going to capture, then what are the overlaps, ground control points has to be initiated. So these are the parameters that needs to be taken care for while collecting the high resolution images. So similarly, after that, once the data has been taken, so whatever the images we are taking, so these are the operations has been that can be done. Some of the operations can be integrated with each other, those can be clubbed and it can be formed into one operation. So usually, basically, that is done the data import and organization. So whatever data we are getting from the flight, that needs to be imported to our formats, that needs to be done. Then geo-referencing has to be done. Already, if the images are geo-referenced, then no issue. Otherwise, based upon that GCPs what we are getting, it needs to be geo-referenced. And ortho rectification based upon our what you can say, the curvature of the globe. ಅದರ ಪ್ರಕಾರ ನಾವು rectification ಮಾಡಬೇಕಾಗುತ್ತೆ. Rectification will be done. And image stitching. So because as I said, at different points we are taking the number of images. Those images needs to be stitched as per their overlap, so that we can get a complete image. So ಆ ಥರ, that is known as a image stitching or mosaicing. Then after that, if you, depending upon the requirement, we can go for some enhancement of the images by applying some different filters. Then classifications can be done, feature extraction, so your region of interest. So if you are interested to identify the ponds or water logging is there, adnenadru bekayindre we can mark it, we can label it there, and feature extraction can be done. Then what are the change detections? So these are the different steps. It again depends upon our output requirement. Quantitative analysis can be done, machine learning and object recognition programs can be run on it to identify those things. Okay, so these are the things that can be done.
Geo-referencing of irregular images, for that, is there any like minimum number of points should be given at an image?
Irutte madam, yes, it will be there, but it will be difficult. Yes, correct. Usually ಏನಾಗುತ್ತೆ, this is for a general image processing system. Drone ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, since it is having onboard GPS system, so ನಮಗೆ ಜಿಯೋ ರೆಫರೆನ್ಸ್ ಇಶ್ಯೂ ಬರಲ್ಲ, ಅದರಲ್ಲಿ ಬೇಕಾಗಲ್ಲ. Only we can correct it by GCP ಅಂತಂದ್ರೆ we can increase the accuracy of it, that's all. So these are some of the data analysis softwares which can be used in normal Adobe Photoshop can be used for image analysis, or AGS soft photoscan, it is one software which can be used for image analysis purposes. It's a very strong software where we can create the different point clouds for 3D modeling of the images. Okay, so those things can be done using AGSoft software. Then it can also be used for calculating the vegetation index. So wide applications are there for AGSoft software. Okay, then already people know about the QGIS. I need not tell about that one. So usually we are using the satellite images for analyzing the things using QGIS. Then MATLAB. So MATLAB is also it's a very big software. Depending upon our applications, we can select a particular toolbox. So based upon the toolboxes, we can analyze the things. Pix4D. So Pix4D, it is particularly meant for analyzing the drone images. So again, depending upon it is having the different products depending upon our requirement. For surveying, it is having a separate software. For mapping of the 3D maps, having separate software. For mapping of the mining areas, for mapping of the roads. So almost I think it is having around 9 to 12 products are there depending upon the applications. In that, one is there for agricultural purposes, which is known as the Pix4D fields. Pix4D fields antide, that is particularly meant for agriculture purpose. Anyhow, I am going to show you how to use that Pix4D fields for developing the vegetation indices. So it is particularly meant for agriculture applications only. Now images tagondo completely. It can be stitched, orthomosaic image can be generated, then we can develop the required indices. We can make the different zonations, and we can also recommend for the variable rate technologies. Means ಯಾವ ಏರಿಯಾದಲ್ಲಿ ಎಷ್ಟು ಅಪ್ಲೈ ಮಾಡಬೇಕಂತ ಅನ್ನೋದು ಅದರಲ್ಲಿ ನಾವು ಫೀಡ್ ಮಾಡಿ, ಇಫ್ ಯು ಫೀಡ್ ದಟ್ ಟು ದ ಆಲ್ರೆಡಿ ಅವೈಲೇಬಲ್ ಮೆಕ್ಯಾನಿಸಮ್, ದೆನ್ that can be achieved for target applications. So ಅಲ್ಲಿವರೆಗೂ ಅದರಲ್ಲಿ ಮಾಡಿದ್ದಾರೆ Pix4D ಅಲ್ಲಿ. So there is particular Pix4D fields is particularly meant for agriculture applications. And regarding the applications of those mapping systems, already ಇದನ್ನು ಬೆಳಿಗ್ಗೆ ನಾನು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೀನಿ. For soil health assessment, for checking the variability mapping, I am not going to further discuss these things. So these are the variations that can be seen. And vegetation health monitoring, even for the yield prediction also it can be done. See, just by seeing there, we can see there's some issues are there at the bottom level. It may be a pest infestation, maybe it may be spreading. So if you identify earlier itself, it can be stopped there only, which may be difficult to search it manually. What kind of variables, sir? No, sir, those things it is not going to give anything. ಅವರೇನು ಕೊಡಲ್ಲ. Only thing is they will be helping us for, or that software will be helping for generating an orthomosaic image which is having the reflectance values in different bands. Yes, we need to create the required indices. Yes, we need to create it. They are having some defined indices within them. Predefined indices ಇದೆ sir. ಕೆಲವು ಇದಾವೆ. If you are getting something variations in that, if you are satisfied, you can adopt that one. Otherwise, you can generate your own indices also. Yes. They have made it very simple, sir. Just within 5 minutes only, everyone can generate the indices now. I will show that one. ಮುಂಚೆ ಭಾಳ ಕಷ್ಟ ಆಯ್ತು ಸರ್. ಇನ್ 2019 ಅದನ್ನು ಫಸ್ಟ್ ಯೂಸ್ ಮಾಡಿದಲ್ಲಿ ನಂಬರ್ ಆಫ್ ಪ್ಯಾರಾಮೀಟರ್ಸ್ ಇಟ್ ಇಸ್ ವೆರಿ ಡಿಫಿಕಲ್ಟ್ ಟು ಆಪರೇಟ್. ಬಟ್ ಈಗ ಅಡ್ವಾನ್ಸ್ ಆಗಿದೆ, ಹೆಂಗಾಗಿದೆ ಅಂತಂದರೆ ಕೆಲವು ಪ್ಯಾರಾಮೀಟರ್ಸ್ನು ಬೇಕಾಗಿಲ್ಲ, ಸ್ಕಿಪ್ ಮಾಡ್ತಿದ್ದಾರೆ, ನಮಗೆ ಕನ್ಫ್ಯೂಸ್ ಆಗ್ತದೆ ಯಾವ್ದು ಯೂಸ್ ಮಾಡಬೇಕು ಯಾವುದಿಲ್ಲ ಅಂತ ಅನ್ನೋದು. ಬಿಕಾಸ್ ಗೆಟಿಂಗ್ ವಿ ನೀಡ್ ಟು ಅಪ್ಡೇಟ್ ಇಟ್. ಅದನ್ನು ಟ್ರೈನಿಂಗ್ ಕೊಡೋರು ಬೇಕು, ಆ ಟ್ರೈನಿಂಗ್ ನಮ್ಗೆ ಸಿಗ್ತಾ ಇಲ್ಲ. ವಿ ಆರ್ ಲ್ಯಾಕಿಂಗ್ ಇನ್ ದಟ್ ಫೀಲ್ಡ್, ದಟ್ಸ್ ಆಲ್. ಐ ಡೋಂಟ್ ನೋ, ಐ ಹ್ಯಾವ್ ಯೂಸ್ ಇಟ್ 6 months ಬ್ಯಾಕ್. ನನ್ನ ಹತ್ರದ ಸಿಸ್ಟಮಲ್ಲಿ ಕರಪ್ಟ್ ಆಗಿದೆ. ನಿನ್ನೆ ನನ್ನ ಪರ್ಸನಲ್ ಲ್ಯಾಪ್ಟಾಪ್ ಇನ್ಸ್ಟಾಲ್ ಮಾಡ್ಕೊಂಡು ಬಂದಿದ್ದೀನಿ. ಇವತ್ತು ಎಷ್ಟು ವರ್ಕ್ ಆಗುತ್ತೋ, ಏನು ಅಪ್ಡೇಟ್ ಆಗಿದೆ ನನಗೆ ಗೊತ್ತಿಲ್ಲ. ಇವತ್ತು ನೋಡಬೇಕಷ್ಟೇ. ಬೆಳಗ್ಗೆ ಕುಂತು ಟ್ರೈ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಇನ್ನೂ ಅದು ಪ್ರೊಸೆಸ್ ಆಗಲಿಲ್ಲ. ಐ ವಿಲ್ ಸಿ. ಬಟ್ ಬೇಸಿಕ್ ಥಿಂಗ್ಸ್ ವಿಲ್ ಬಿ ರಿಮೈನ್ ಸೇಮ್, ಅಂತೂ ಸೇಮ್ ಇರುತ್ತೆ. ಸೊ ದಿಸ್ ಈಸ್ ದನ್ ಜಸ್ಟ್ RGB ಇಮೇಜ್ ವಿಚ್ ಇಸ್ ಕನ್ವರ್ಟೆಡ್ NDVI ಇಮೇಜ್. ಸೊ ಯೂಶ್ವಲಿ ಡೋಂಟ್ ಗೋ ವಿತ್ ದಿಸ್ ಕಲರ್ಸ್. ಕಲರ್ಸ್ ಅಂತ ಅದರಲ್ಲಿ ಹೋಗೋದು ಬೇಕಾಗಿಲ್ಲ. ವಿ ಕ್ಯಾನ್ ಚೇಂಜ್ ದ ಕಲರ್ಸ್ ಲೈಕ್ ಎನಿಥಿಂಗ್. It is not representing, it is a completely a false color system only. It is representing only the variations. So depending upon the levels, how many levels of variations you want, you can identify. Only 1 or 2, black and white ಮಾಡ್ಬೋದು. Some things in intensity of the colors also it can be used. Then of course in precision irrigation ಬಗ್ಗೆ already ಹೇಳಿದ್ದೀನಿ. How to monitor the, how to identify soil, dry soil, that can be variation done. What are the issues are ಒಂದು ಫೀಲ್ಡಲ್ಲಿ ಜಾಸ್ತಿ ವೆಟ್ ಇತ್ತು ಅಂತಂದರೆ ದೇರ್ ಮೇ ಬಿ ಲೀಕೇಜ್ ಆಫ್ ದ ಪೈಪ್ ಲೈನ್ಸ್ ದಟ್ ಕ್ಯಾನ್ ಬಿ ಐಡೆಂಟಿಫೈಡ್. So in the weed and pest also it can be used. See, this is the identification of the weeds in the field. The weeds has been in the first picture, you can see the weeds has been identified in the field. In the second figure you can see those weeds has been classified based upon the intensity, low density, high density. Wherever there is a medium density weeds are there, those things can be marked and appropriate action can be taken. And field mapping, the field boundaries, and land use mapping, that can also be done for land use classifications. And sir, usually just for general purpose means we can go, what we are doing is we are varying from 80 meters, 80 meters ತಗೋತೀವಿ ಸರ್. 80 meters, 100 meters, 120 it is the maximum. 120 ಗಿಂತ ಅಲೋವೇ ಇಲ್ಲ. ಎಸ್, ಫ್ರಮ್ ದ ಗ್ರೌಂಡ್ ಸರ್, ಫ್ರಮ್ ದಿ ಗ್ರೌಂಡ್. ನೋ ಸರ್, ರೆಸಲ್ಯೂಷನ್ ವಿಲ್ ಚೇಂಜಸ್. ಅದಕ್ಕೆ ಒಂದು ಫಿಗರಲ್ಲಿ ತೋರಿಸೋದಲ್ಲ ಸರ್ ನಾನು. ಆಸ್ ದ ಹೈಟ್ ಇನ್ಕ್ರೀಸಸ್ ದ ರೆಸಲ್ಯೂಷನ್ ಡಿಕ್ರೀಸಸ್. ನಮ್ಗೆ ಅದೇ ನಮ್ಮ ವಾಟ್ ಈಸ್ ಅವರ್ ರಿಕ್ವೈರ್ಮೆಂಟ್, ದಟ್ ಡಿಪೆಂಡ್ಸ್. ವಿ ಕ್ಯಾನ್ ಗೆಟ್ ಇಟ್ ಸರ್, ಬಟ್ ಇಟ್ ರಿಕ್ವೈರ್ಸ್ ಮೋರ್ ನಂಬರ್ ಆಫ್ ಪಾಸಸ್. ಏರಿಯಾ ಕವರೇಜ್ ಕಡಿಮೆ ಆಗ್ಬೋದು. 60 meters. Yes. We have done from 60 meters, 70 meters, 80, 90, 120 ವರೆಗೂ ವೇರಿಯೇಷನ್ಸ್ ನಾವು ಸ್ಟಡಿ ಮಾಡಿದ್ದೀವಿ ಸರ್. ಸೊ ಬಿಲೋ 60 if you are going means lot of data will be missing. Overlapping ಕಡಿಮೆ ಆಗ್ತಾ ಇದೆ, ಮಿಸ್ ಆಗ್ತಾ ಇದೆ, because what software we are using, what mission planning we are using, it is unable to match up to below 60 meters. ಮೇಡಮ್, ಇಟ್ ಡಿಪೆಂಡ್ಸ್ ಅಪಾನ್ ದ ಟೈಪ್ ಆಫ್ ಕ್ಯಾಮ್ರಾ. ಅದು ನಾನು ಆಲ್ರೆಡಿ ಹೇಳಿದ್ದೀನಲ್ಲ, ಈಗ ಕ್ಯಾಮ್ರಾ ಸೆನ್ಸ್ ಸ್ಪೆಸಿಫಿಕೇಶನ್ಸ್ ಬರುತ್ತೆ, ಜಸ್ಟ್ ಪುಟ್ ಇಟ್ ದಟ್ GSD ಫಾರ್ಮುಲಾ, ಹೈಟ್ ಎಷ್ಟಿರುತ್ತೆ ಅದ್ರ ಮೇಲೆ ನಮ್ಮದು ಎಸ್. ಸೊ ಈವನ್ ಒನ್ ಸ್ಟೆಪ್ ಇನ್, ಆಸ್ ಅ ಸೈಡ್ ಇನ್ Pix4D, they went one step ahead, that is after giving some prescriptions, map can be developed, and those prescription maps can be integrated with the variable rate application machineries. Then the machines will be taking the actions as per the requirement. Means ಈ ಒಂದೇ ವೇರಿಯೇಷನ್ಸ್ ಇತ್ತಂದರೆ ಎಲ್ಲೆಲ್ಲಿ ನಮಗೆ ಫರ್ಟಿಲೈಸರ್ ರಿಕ್ವೈರ್ಮೆಂಟ್ ಜಾಸ್ತಿ ಇದ್ರೆ ಅಲ್ಲಿ ಫರ್ಟಿಲೈಸರ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ, ಎಲ್ಲಿ ರಿಕ್ವೈರ್ಮೆಂಟ್ ಇಲ್ಲ ಅಲ್ಲಿ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಸಪೋಸ್ ಬೇಸ್ಡ್ ಅಪಾನ್ ದಿ NDVI ವ್ಯಾಲ್ಯೂಸ್, ಆ ಥರ ನಾವು ವೇರಿಯೇಷನ್ಸ್ನ ಮಾಡ್ಕೋಬೋದು. ಬಟ್ ಅಗೇನ್ ಇಟ್ ರಿಕ್ವೈರ್ಸ್ ಅ ಸಪರೇಟ್ VRT equipments. ಸದ್ಯಕ್ಕಿನ್ನೂ ಇಂಡಿಯಾದಲ್ಲಿ VRT equipments ಇಲ್ಲ, ಬಟ್ ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಕಮಿಂಗ್ ವಿದಿನ್ 1 year 2 year ಬರುತ್ತೆ. ಆಲ್ರೆಡಿ ದೇ ಆರ್ ಯೂಸಿಂಗ್ ಇನ್ ಚೈನಾ ಆ್ಯಂಡ್ ರಷ್ಯಾ, US ದಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಬೈ ಜಾನ್ ಡೀರ್ ಕಂಪ್ನಿ. ಓಕೆ, again coming for some vegetation indices. So already people know what is vegetation indices, how it is going to be calculated. So just based upon the whatever the wavelengths or whatever the reflectance values we are getting from the different wavelengths, different types of wavelengths. So just by mathematical calculations of these wavelengths, we are going to calculate these vegetation indices. So for vegetation indexes, so the reflectance value is very much important, and the ground truth data which is having, which we need to have, because if you want to target some particular object, then we should study the reflectance property of that particular object or that particular matter. Then only we are able to identify, or we are able to efficiently distinguish that material with respect to the other things. That's why the ground truth data is also important. So usually it will be done using some spectroradiometers. So these are different electromagnetic spectrum where depending upon this wavelengths. So ಏನಾಗುತ್ತೆ, visible in the radio waves ವರೆಗೂ we are using in our agriculture purposes. So it is safe also. So whenever we talk about the reflection, so reflection is depend upon these parameter, that is the materials or the feature dependent and also the wavelength dependent. So since we are able to distinguish between two materials, means those two materials are able to reflect the different wavelengths at different intensity. Then only we are able to identify that there are two types of materials. Otherwise it will be same for us. Similarly, wavelength. So the same material may be reflecting the same at same intensity, but it may be reflecting the other wavelength, what you can say, the spectrum. So again, depending upon this, because some of the materials are there which are absorbing particular wavelengths, some are transmitting, or it is what you can say, reflecting the particular wavelength. So we need to differentiate those variations, then it will be easy for identification. So this is the spectral signatures which has been taken for bare soil, a green vegetation and a water body. So you can differentiate there. So at the bottom you can see this is the water body which is having the reflectance values from in the visible range itself within 0.8 micrometer. Then for the vegetation, so we can say the maximum reflection was there within this near infrared region. NIR region alli reflection ಜಾಸ್ತಿ ಇರುತ್ತೆ vegetation ಗೆ. So that's why in multispectral camera we are using the NIR band, red edge and NIR. So you can see red edge means at the end of the red. So this is also having the more reflectance value and NIR. Then when we talk about this bare soil, so of course it is having some different reflections compared to vegetation at this point. Illondu ಸ್ವಲ್ಪ different ಆಗಿದೆ. Again here it may be there or may not be, and again it is having variations more than in the MIR, mid infrared region. So within the same, for same vegetation, depending upon its stress involved in it, so the healthy green vegetation, it is having the some special, or we can say high amount of reflection in this zone, 0.7 in the n ide illivargu, around 1.5. So it is having a higher reflection value compared to second one is the stressed vegetation, and the yellow color which is representing it is a very severely stressed one. So there is a, for the same wavelength, the level of reflection is different. So we need to identify this, how much difference is there, then we are able to easily analyze the things. So that pattern, again we can see the pattern, there is some variation is there. But at these bands, when we talk about in these bands, we are unable, if you take these data, we are unable to differentiate those things. So ನಮಗೆ maximum differentiate ಆಗುತ್ತೆ, those bands needs to be selected. So these are some of the very basic vegetation indices which are used. That is one is simple vegetation ratio, that is reflection of the NIR divided by reflection of the red band. Then NDVI, which is the most commonly used, which has been developed in the year 1974. So first time they have used it, and usually it is used for identifying the biomass. So we used to go for the NDVI maximum, that is given by reflection from NIR minus red divided by NIR plus red. So again that NDVI has been modified and it has been used, and one is the renormalized vegetation index. So where it is going to, it will not consider the effects of the soil and the sun angles for its calculation. So some extra errors or something, the shaded areas, those things can be removed by using the modified formula, that is the renormalized difference vegetation indices. Again, what I am saying is, these are just a formulas. It may be suitable for you, it may not be suitable for you, and you can write your own formulas also. Then this is the renormalized, then transformed normalized vegetation indices, which is developed by or proposed by Tunker in the 1979. So where this is the index has been used for differentiating the biomass and the vegetation cover estimation purposes. They have used. So another one is the GRVI, the green red vegetation indices, so which is able to show the small changes in the vegetation condition during the crop growth. So this can be used for that purpose. And another one that has been developed, that is the normalized difference moisture index or water index. This is usually used for to closely observe the whatever the changes are there in the plant biomass and the water stresses in comparison with the NDVI values. So water, because we, in other words, we can say that of course there will be a stress in the crop. So if you want to know this stress has been caused because of the moisture effect only, then the index can be used. So in NDVI ಏನಾಗುತ್ತೆ, in NDVI only we will be able to identify whether the crop is stressed or not. The reason behind that, we need to have some supplement data. And similarly in soil adjusted vegetation indices, so n number of indices has been developed and they have particularly used. So these are some of the indices which are most commonly used. So this is indices is used for removing the soil background and what if there is an atmospheric effect is there. Usually this is used in satellite data. So ಏನಾದರೂ corrections ಮಾಡೋದಂತಂದರೆ we can remove those errors which is caused by atmosphere. So ಆ ಥರದ್ದು ಏನಾದರೂ adjustments ಇದ್ದರೆ ಅದನ್ನು ಯೂಸ್ ಮಾಡ್ಕೋಬೋದು ನಾವು. Then enhanced vegetation index, where this equation has been used for improved sensitivity to high biomass regions and has improved the vegetation monitoring. So everything, whatever the things are there, those are the modified things of the existing indices only. Similarly, one is to estimate the amount of chlorophyll in the vegetation. So this transformed chlorophyll absorption and reflectance index has been developed. One is red edge position indices. So this is the used for measure for studying the feature of the. It is not future. It is the feature of the vegetation spectral curve. And damage specific vegetation index. So this is they have given name because to estimate the damage levels caused because of the leaf folder, it may be yellow stem borer and brown plant hopper in the rice. So these kinds of diseases can be they have used for identifying say at a particular wave bands. So those were some of the vegetation indices which I have just I want to show you people. Then what are the main things that we should keep in mind for the data analysis or for capturing the data? First one, we need to use a specified sensors. That is, we need to know for a particular application which kind of sensor is required. That needs to be decided first. Then only we can go for either for a RGB or you want to go for a multispectral or you want to go for a hyperspectral or a thermal spectral images. So that needs to be correctly identified and used. Then use of suitable vegetation indices can be done for analyzing purposes depending upon the requirement of the analyst. So who is the person who is interested to analyze the things? What is his region of interest? What he want to try to identify the things? The indices will be different. If already existing indices are giving a better result for us, then we can adopt directly those things. Otherwise, there is a more scope for modifying those existing indices. Then use of multispectral or hyperspectral spectral radiometer at the field level. So this is because before going for the drone study, we need to have a minimum knowledge with what is the what you can say the radioactive the spectral activity of those particular thing. What you want to concentrate. So for that we are using this spectral radiometer at the field level itself, and we need to study the what is the spectral signature that object is going to create. Our knowledge itandre, it will be very easy for the deciding those sensors. Okay. So this is all about this presentation, and just want to conclude that one. So if you want to have, if you're having a very effective mission planning, and then we can extract the maximum information from the existing system itself, and at the same time we need to understand the better components for its integration so that a proper crop management can be done and the productivity can also be increased in a sustainable manner. Thank you.
Any questions? Okay, it's good. The mission planning, how, for what purposes you are using the different plans and how we need to analyze those mission plannings using the different vegetation indices. It was a really wonderful class. So thank you once again, sir, for theoretical part. Now, after the tea break, we'll have how exactly it will be analyzed through practical mode. Okay, he will be showing through the help of the software what he said, Pix4D field. So I think that is a good exposure. Okay. So then, because now it is full theoretical part, now after the tea break we'll have the practical sessions. Okay. Fine. We'll break for 10 to 15 minutes. Okay. Now it is almost 3:55. We can come back by 4:05 or 4:10. So after the practical class we'll break because one more class was there. But already it's 4:15. So we'll continue in the tomorrow. Okay. Fine. Thank you. And one more announcement is there. I think, have you seen your WhatsApp? No. Yeah. So now we'll be giving the one pre-receipt brochure. Okay. So where you need to fill your account details and also those who have traveled outside the institution. Okay. So for the local participants, it is not applicable. Those who have traveled out from outside the university and outside the main center. Even if you are traveling from Madikere or Hiriyur or from Mudigere, they can able to claim the traveling only after producing their original tickets. Okay, that's the mandate is there. As for the university mandate, I cannot do anything. So it will be giving to you. Please fill it. Okay, don't fill the amount and anything. You bring your original. We need onward journey. Okay, tickets. So once you will be going back, you are supposed to send the our original copy of the upload. If you are having both the tickets, it will be good. You can attach it. Okay, and the one passbook Xerox copy. Okay, and PAN card. Fine, Xerox, both all the Xerox. Okay, fine. Huh?
Since you are having net banking, can you produce the checkbook?
That is not any okay anything. Only account details we required. Account details is enough. If not passbook, you can produce check Xerox. That's also okay. If you are producing the original tickets, if it is no, you are also in the university system. Have you know how the billing claiming will be done? Okay. Eh? If your university is providing for that means we will provide. You know the system. That's what I said. You have to produce the tickets. That's all. If you are producing the ticket means your claiming will be done. Okay?
Can we give a self receipt?
No, sir. It is a university rule is there. You can articles related to the planning and as well as how the NDVI images will be analyzed using the software. Okay, Pix 4D field, with the help of Pix 4D field. Here itself, planning here only. Because in this drone we don't have a camera or RGB to take the images. If that was the case, you could have been shown. So already image has been taken. So now the how that image can be superimposed into. No. This can be fixed. Now I have to remove that one. Then again I have to fix the camera. It can be possible in this drone.
Okay. So just I have discussed about the different types of softwares which can be used for processing and analyzing the different processing and analyzing the things. Among them, so which the software which I thought or which I feel that it will little bit easier for understanding and for the operation, and also it is a very robust one, that is the Pix4D. So they are professionally they have been having the different types of products for photogrammetry and analyzing the things depending upon the different industries. So this is the Pix4D website. So just if you type of Pix4D and the first link, if you open it, so we will be getting this Pix4D website, this one. So here we can see the different types of products are available with them. So for the product related to mapping and 3D modeling, so we are having Pix4D, Matic, Mapper, Fields, React, Engine. So these are having the different applications in the different fields. Okay, it may be in terms of a surveying, for roads, for mining purposes, and for building the 3D models. So everything they have been done, and it goes on increasing day by day. And also here what I'm talking about is the thing which is suitable for the Pix4D fields, so which has been used for agricultural purposes only. They has been specifically meant for that kind. And here the Pix4D, as it is showing, is a hybrid drone and satellite mapping software for aerial crop analysis and precision agriculture. So earlier this software was only helpful for generating the indices, that's all. But now they have been giving some another support, more support in regard of generating the prescription maps, which can be integrated with the existing VRT technology machineries, and the VRTs can also be taken account while operating in the field conditions. So that has also been developed by them. So here actually this is not a free product, but it can be used for demo purpose. They are giving for around 15 days for time for analyzing the things. But the problem is, whatever the things you want to do, you can do in there only. We can't import the data, analyze data. We can't import that one. They are not providing one. But 2 years back, they used to give 1 month free subsidy with 100% abilities. So whatever the things that is happening, that can be exported, imported, it can be used for another softwares also. That thing can be done 2 years back. But after back 2 years, we can do the things in the system itself, but we can't unable to export the analyzed data. So this kind of restrictions they have made. So for that we need to purchase. Again, for the purchasing, again the different types of plans they have been providing. You can visit this website, and as per the requirement we can select the plans. So just to, for the operation of this one, if you want to use this one, first we need to click on this try for free, where is going to take a link for this account opening. It will suggest for opening an account. So just by entering your email ID, some what you can say, something it will be asking regarding about your personal data. Personal data is name and application purposes. The minimum data it is going to ask. You can fill it down, and you can download this one for the Windows, and it can be installed here. So once it has been installed, they also given the versions also. So continuously they are going to be updated. So I think they have updated 5.6. Okay, then it is a new version. I don't know. Some of the features may be increased and it has been modified. I also try in front of you only. No, Donna. And also they have been providing the different types of videos in the YouTube channel, but the problem is they are age old. Means 2 years back videos are available in the YouTube channel, because there's continuously they are upgrading, but they are not updating those videos, how to process the new things. So of course maybe they may be planning in future. We can take the guidance of those videos also, and we can use this. It's very simple to use. Okay. So after downloading, after installing, so once you install, so you will be getting this icon here. You can see Pix4D fields. So we can just open it. So when you are using for the first time, so we can it will be asking for the login details, so we can provide the login details. Once it has been logged, so you will be getting this dashboard. Okay, so these are some of the things which I have tried in the morning session. So version so I have not completed any of the projects. So in this only he has given 2 examples here. At the bottom you can see it is already inbuilt in the system. You can download those projects. They are going to provide you the images also for practicing purposes, and in some of the websites are there where we can get the data also. Now search kuda some data banks are there where we can get the random data. So for analysis purpose, for practicing purpose, those things can be used. And you can also use this multispectral example. If you download, if you press download, the number of photos which can be that can be downloaded, we can use those things. For RGB also it can be downloaded and it can be used. And this is the dashboard. First we are going to see. Then here there is a, you can see there is settings icon is there. So if you press this settings icon, you can see whatever the things we can change in the app setting. That is units. So I am keeping units as a metric, and it is also having an imperial units, that is in terms of meter, foot, acre, miles. In that manner it is going to measure. So generally we are very much familiar with this metric system. We need to select that metric system only. Then again we are having an option for selecting the language, that is which language you want. English is for us, it's good. Then base map, it is a standard base map we can select. So customize the PDF report is required, that can be done. So different types of options are there. You people can explore these things, and again manage license. So after the free trial has been expired, again it is going to ask to update the new license. Then after paying some fees, they are going to provide the license number. It can be updated there. So these are some of the things in the settings we can see. And here there are, you can see on the top it is the projects are there which will be empty. Whenever we want to do some projects, just you can click on this new project icon, or you can click the plus icon which is present at the bottom. So if I press this one, the new project will be gets opened. So just a random, when we are opening for the first time, a random map will be gets opened here. It may be related to you or it may not be related to you. Other ಬಗ್ಗೆ ನಾವು ಅಷ್ಟು ತಲೆ ಕೆಡಿಸ್ಕೊಳ್ಳೋದಿಲ್ಲ. Simple random map will gets opened, and in this data again at the top you can see the unnamed project one has been by default the name has been provided. So if you want, you can edit this pencil mark is there. You can edit the name of the project. If I want to give something name, anything can be done. If you want to do some drone training or training, so training 1, just I am giving the name. And if you are having any specific description about that project, means you may be, people may be interested in doing many number of projects with the same data. So there you can simply write small description. That is, for example, I want to identify the pest infestation. I want to identify the soil fertility variability. So those things can be given as an extra information so that we can recall it later on. Those things that provision has also been provided here. So just for this I'm giving, or you can leave it as an empty also, no issue. So just I will make a save. Then again, what kind of data you are working with, whether you are working with the satellite data or working with the data captured by the drone. So earlier it was only supporting for the drone data, but now they have extended, and now we can also use the data that can be taken from the satellites. So again, just I am concentrating on the data captured by the drones, because I have not worked with these that option till now. Just I want to fix with this captured by the drone. Again, when we talk about the captured by the drone, so here it is asking, so whether you want to import directly the images which is available in our system, or we can directly select a particular folder. In that folder, if the already images has been taken. So these options can be there. So usually it is recommended that we can have a different folders and subfolders, and that folders named the name can be provided with operational parameters. Means at what height you are flying the drones, what was the speed of operations. So those things should be noted while capturing the data, and it can be kept in some subfolders. Those information we should know, because for comparison purposes we may require those data later on. And also we can take from already existing maps are there. If I'm having some orthomosaic maps which has been processed by some other softwares, so directly we can import those processed maps also. Just for that option, it is having the other maps option at the bottom. So the file format should be in the GeoTIFF format. Then through that format we can directly import that existing map also. So before proceeding with that, just I want to show some of the data which I have captured. Because since I am unable to bring that drone here for making the practical thing to capture the data, so just I have took some of the data sets here. We can see. So once you take the images from that our existing camera, see, this is the folder 0016 set and then bardidella. So this is the automatically created by the camera, and during that flight period whatever the images are taken, that will be stored in that. So after, since when we go for the next flight, again the folder's name will be gets changed. It may be 17 set. Then again the data will be stored separately. So for individual operations, so individual set of data will be stored there. And again another thing is there. Once the number of images will be more than 2000, then again it automatically it creates another folder. So because if it is folder is having more than 2000 photos, then it will be taking more time for processing purposes. So that's why it is going to divide by itself. So just I want to open this one. Again inside there will be some DAT files will be there, which is having our flight details and flight data which may not be using for us. And then you can see these are the different images which has been captured in different bands. Say it is having around 570 images. You can see here 570 items antiದೆ ನೋಡಿ ಕೆಳಗಡೆ. So around 570 images has captured here. And before capturing the image, the sensor which we are using, that needs to be calibrated. Okay, so when we talk about the calibration, two calibrations we need to do. One is the drone calibration, another is the sensor calibration. So for the sensor calibration, because we are flying at different time, on that day the reflectance of the sunshine will be different, whether it may be cloudy, it may be a clear sky. Even though the time will be different, the sun orientation will be different. So depending upon that, the reflectance values what we are observing from the target area, that will be different. So whatever the errors that has caused because of these unavoidable things, those errors can be removed by calibration, by calibrating the sensor. So for that calibrating of the sensor, so they have given this calibration block. So it will be coming along with that camera. So what we should do is we need to keep this one, and by using that software, if you press calibrate camera, then it is going to take some images of that block. So those images will be taken in different bands. So the camera which we are using, it is having the 5 bands, RGB plus red edge, then NIR band. So the details of those cameras just I will discuss further when we start processing the things. And when we take this one, again there is one QR code is there here. So this QR code is saying what is the standard reflection values of this block. So once you analyze the things during analysis, so the software which now we are using, it will take those reflectance data as a calibrated data, and it will normalize the values of the reflection values that has been already stored. So automatically, earlier we used to calibrate it separately. We need to calculate it manually. Manually calculate ಮಾಡ್ಕೊಂಡು ಅದನ್ನ correction factor ಅಂತಂದು include ಮಾಡಬೇಕಾಗಿತ್ತು. ಈ correction factor we do not have separate correction factor. Automatically it will take the correction factors. Only thing is we need to give these values for that, or sorry, these images for our system. If you are not providing these images, then it will ask for those values, correction values. Another software I have said it, that is the AG soft ಅಂತ ಹೇಳಿದ್ನಲ್ಲ, AGI soft. So in that AGI soft, this feature is not there. For that we need to separately provide these values. Yes sir, this calibration block will be provided by the camera person where we are purchasing that one. They will be providing. And this is a standard method. It may be different for different sensors. So this is the actually this has been done in our university. We had one 10 days a short course. There we had this practical. So there we have captured this data. We can see here some many persons are standing here. The trainees are there. So it has taken our image, and we can have see 1, 2, 3, 4, 5. Then the image is changed. So it is taking one image in 5 bands. That's why we can have the 5 bands here. You can see first band, second band, third band, fourth and fifth band. So for a camera, for a sensor, so whatever the image is there, that is a simple grayscale image. It will not identify any color. Only it will be stored in the form of a numbers. So actually this is the black and white grayscale images we can see, but there is a difference in the reflectance values in those bands. That's why we are able to differentiate the values here. Okay. Sir, right now it is still flying, sir. It is taking off. Take off ಆಗ್ತಾ ಇದೆ ಅಷ್ಟೇ ಈಗ. So altitude we have kept around 80 meters. 80 meters ಇಟ್ಟಿದ್ದೀವಿ sir. See, this is the data. So you can see the persons here in this band. See, within this we are unable to, in some bands we are able to identify the persons are standing there, but in different bands we are unable to identify. Means we are not visible in that spectral band. Al ಕಾಣಿಸ್ತಾ ಇಲ್ಲ ಅಂತ ಅರ್ಥ. So these variations we need to identify in our analysis. Same image ಇದೆ, but ಕೆಲವರಲ್ಲಿ ನಾವು ಕಾಣಿಸ್ತಾ ಇದ್ದಾವೆ, ಕೆಲವರಲ್ಲಿ ಕಾಣಿಸ್ತಾ ಇಲ್ಲ. Yes madam, image means it will be a grayscale only. Actually those are the digital numbers. ಇನ್ನೂ ಸ್ಪೆಸಿಫಿಕ್ ಆಗಿ ಕಂಪ್ಯೂಟರ್ಗೆ ಅದೇನು ಗೊತ್ತಿಲ್ಲ, ಅದಕ್ಕೆ ಏನು ಗೊತ್ತಿಲ್ಲ ಅದಕ್ಕೆ. It will store in the form of number 10 to 255 number if it is an 8-bit image. If it is a 2-bit 1-bit ಅಂತಂದ್ರೆ 0 or 1 0 or 1 0 or 1 ಅಷ್ಟೇ ಇರುತ್ತೆ, ಬ್ಲ್ಯಾಕ್ ಆ್ಯಂಡ್ ವೈಟ್ ಅಂತ ಅಷ್ಟೇ ಇರುತ್ತೆ. ಸೊ ಡಿಪೆಂಡಿಂಗ್ ಅಪಾನ್ ದ ನಂಬರ್ ಆಫ್ ಬಿಟ್ಸ್ ಇಟ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ವೇರಿ. Yes, it will be simple for the computer to differentiate that one, sir. For us it is difficult, for computer, for the software it is easy, sir. Anything, sir, even ಇದನ್ನೇನಿದ್ರು ಕೂಡ ನಾವು we need to convert that into a grayscale image. Grayscale image ಕನ್ವರ್ಟ್ ಮಾಡಿನೇ ಅದು ಅನಾಲಿಸಿಸ್ ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ. ನಮಗೆ ತೋರಿಸೋದು ಅದನ್ನು ಬೇರೆದಲ್ಲಿ ತೋರಿಸುತ್ತೆ, ಬಟ್ ಫಾರ್ ಇಟ್ಸ್ ಅನಾಲಿಸಿಸ್ it will be in background, it will going to convert in that format only. So these are the different images which has been taken. ಬೇರೆ positions, when the camera is moving at different positions, so different images has been taken. Okay, so in this manner, so already there are yes, very small area we have taken. So 570 items are there, means 570 images has been captured by that camera. One position only 5 bands, 5, sir. If you divide it by 5 means you will get how many images, actual images are there. ಅದು ಮಾಡ್ಬೋದು ಸರ್ ಅಷ್ಟೇ. ಎಸ್ ಮ್ಯಾಮ್. ಹಾಂ ಮೇಡಮ್, ಡ್ರೋನಿಂದ ತೋಡಿರೋದು. ಮೇಡಮ್ ಅದು ಐಡೆಂಟಿಫೈ ನೀವು ಮಾಡೋಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ. ವಿ ಕಾಂಟ್ ಐಡೆಂಟಿಫೈ ಆ್ಯಸ್ ಎ ಹ್ಯೂಮನ್ ಐ. ನಮಗೆ ಕಾಣ್ತಿರೋದು ಮೂರು ರೇಂಜಲ್ಲಿ ಅಷ್ಟೇ. ನಮ್ಮ ಸ್ಪೆಕ್ಟ್ರಲ್ ಬ್ಯಾಂಡ್ ಇಷ್ಟೇ ಇರುತ್ತೆ, ಭಾಳ ಕಡಿಮೆ ಇದೆ ಮೇಡಮ್. ಅದರಲ್ಲಿ ನಾವು ಐಡೆಂಟಿಫೈ ಮಾಡ್ಬೋದು. ಯು ಕ್ಯಾನ್ ಸೇ ವೆದರ್ ಇಟ್ ಇಸ್ ರೆಡ್ ಆರ್ ವೈಟ್ ಅಂತ ಹೇಳ್ಬೋದು. ಬಟ್ ಫಾರ್ ದ ಕಂಪ್ಯೂಟರ್ ಇಫ್ ಇಟ್ ಇಸ್ ಎ ರೆಡ್, ವಿಚ್ ಟೈಪ್ ಆಫ್ ರೆಡ್ ಇಟ್ ಈಸ್ ಏಬಲ್ ಟು ಐಡೆಂಟಿಫೈ. ರೆಡ್ಡಲ್ಲೇ ಮತ್ತೆ ಅದನ್ನು ವೇರಿಯೇಷನ್ಸ್ ಹೇಳ್ಬೋದು, ಹಂಡ್ರೆಡ್ಸ್ ಆಫ್ ಥೌಸಂಡ್ಸ್ ಆಫ್ ವೇರಿಯೇಷನ್ಸ್ ಹೇಳ್ಬೋದು ಆ ಥರ. ಹಾಂ, ಸೊ ಈಗ ನಾವು ನೋಡ್ತಾ ಇದ್ದೀವಿ, ನಮಗೇನು ಗೊತ್ತಾಗ್ತಾ ಇಲ್ಲ, ಬಟ್ ಒನ್ಸ್ ದ ಸಿಸ್ಟಮ್ ಇಸ್ ದೇರ್ ಇಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಐಡೆಂಟಿಫೈ. ಓಕೆ, so similarly we have another set which has been taken in the paddy field. So actually we went for Gangavati, there we have taken this one. Again we have done the calibration, the similar. First camera calibration is important, so calibration we have done. So these are the images of the calibration. Then again, so reflectance values. ರಿಫ್ಲೆಕ್ಟೆನ್ಸ್ ವ್ಯಾಲ್ಯೂಸ್ ಅಂದರೆ ಕರೆಕ್ಷನ್ ಫ್ಯಾಕ್ಟರ್ ಅಂತ ನಾವು ಯೂಸ್ ಮಾಡ್ತೀವಲ್ಲ ಸರ್. ಈವನ್ ಸ್ಟ್ಯಾಟಿಸ್ಟಿಕ್ಸಲ್ಲಿ ಒಂದು ಕರೆಕ್ಷನ್ ಫ್ಯಾಕ್ಟರ್ ಅಂತ ತೊಗೊಂಡು ಎರರ್ನ ಹಾಕ್ತೀವಲ್ಲ ತೆಗಿತೀವಲ್ಲ, ಆ ಎರರ್ ತೆಗಿಬೇಕಾದ್ರೆ ಎರರ್ ಫೈಂಡ್ ಮಾಡೋಕ್ಕೆ ಇದು ಬೇಕಾಗುತ್ತೆ ಅಷ್ಟೇ. ಹಾಂ, ಸೊ ದಿಸ್ ಈಸ್ ದ ಪ್ಯಾಡಿ ಫೀಲ್ಡ್ ಸರ್. ಇದು ನೋಡಿದ್ರೆ ಗೊತ್ತಾಗಲ್ಲ ಪ್ಯಾಡಿ ಅಂತ ಅನ್ನೋದು, ಬಟ್ ಇಟ್ ಇಸ್ ಅ ಪ್ಯಾಡಿ ಫೀಲ್ಡ್. ಲೇಟರ್ ಆನ್ ಯು ಕ್ಯಾನ್ ಸಿ ದಟ್ ಒನ್. ಸೊ ಹಿಯರ್ ಜಸ್ಟ್ ಫಾರ್ ಮೈ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಪರ್ಪಸ್ ಇಲ್ಲಿ ನಾನು ಫೋಲ್ಡರ್ ನೇಮ್ ಕೊಟ್ಟಿದ್ದೀನಿ ನೋಡಿ, ಜಸ್ಟ್ H80 S8 ಅಂತಿದೆ. ಸೊ ಇಟ್ ಇಸ್ ದ ninth flight time. 80 is the height of the flight, then S8 is the 8 meter per second was my speed of operation. For my understanding purpose, we can name the folder like that, or we can have one Word file where we can make a table and we can write the information there. See, this is having around 2000 items. So after 2000, it is going to be shift for the another folder. So one folder ಅಷ್ಟೇ ನಾನು ತಗೊಂಡು ಬಂದಿದ್ದೀನಿ. So with this, see the data which has been generated, we can see this is having around 5 GB. Only images is 5 GB, that too multispectral. When we go for hyperspectral, it will be in terms of 50-100 GBs. So that's why data generation will be huge. Again, how best we are going to handle it, that is also difficult. Okay, sir. So next is the folder. So here just I want to include that one. So I'm selecting a folder just for the purpose. This is ಜಾಸ್ತಿ processing time ತಗೊಳುತ್ತೆ. I will take the first one for drone training. Set. You can select that folder. Select folder. Now it is taking scanning files. Okay. So the images has been scanned and it is giving some processing options. So here we can go for a fast processing and accurate processing. So almost all it has been explained here, self-explanatory is there. So if you opt for a fast processing, so rapid results, good arithmetic, but the coarser model will be there. Means the resolution is very less. Processing ಅಲ್ಲಿ ಅಷ್ಟೊಂದು ನಮ್ಗೆ ಡೇಟಾ ಸಿಗಲ್ಲ. ಸೊ ಏನೋ ನಮಗೆ ಸ್ಪೆಸಿಫಿಕ್ ಆಗಿ ಏನಾದರೂ ಬೇಕಾಗಿತ್ತು ಅಂತಂದರೆ ಫಾಸ್ಟಾಗಿ ಕೆಲಸ ಆಗಬೇಕಂದ್ರೆ ವಿ ಕ್ಯಾನ್ ಗೋ ಫಾರ್ ಫಾಸ್ಟ್ ಪ್ರೊಸೆಸಿಂಗ್, ಆರ್ ಯು ಕ್ಯಾನ್ ಗೋ ಫಾರ್ ಅನ್ accurate processing, but you will be taking some more time. So this is ideal for measurements, trial plots, spot applications, elevation analysis. ಅಲ್ಲೆಲ್ಲ ನಮಗೆ accurate processing ಯೂಸ್ ಮಾಡ್ಕೋಬೋದು. And again he is providing one option. So what was the weather condition during capture? Whether it was a overcast or it is a clear sky. So usually in our case it was a clear sky. I am selecting a clear sky. ಏನಿರುತ್ತೆ ಅದನ್ನು ಬರಿಬೋದು. Then again GSD here. So here while processing we can have the low resolution, that is 98 centimeter per pixels, and high resolution up to 0.5 centimeter per pixel, and unlimited means depending upon the images what we have taken, it will be self calculating and it will be doing. Sir, it is better even there is a cloud. If completely cloud cover agidre, it is best. Cover is best. ಸ್ವಲ್ಪ ಪಾರ್ಷಿಯಲ್ ಆಗಿ ಒಂದು ಸ್ವಲ್ಪ ಲೈಟ್ ಬರ್ತಾ ಇತ್ತು, ಸ್ವಲ್ಪ ಬರ್ತಾ ಇಲ್ಲ ಅಂತಂದ್ರೆ ಅಗೇನ್ ಇಟ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ ಸಮ್ ಎಫೆಕ್ಟ್ ಆನ್ ದಿ ಇಮೇಜಸ್. ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಟೇಕನ್ ಎನಿ ಟೈಮ್ ಸರ್. ಅರ್ಲಿ ಮಾರ್ನಿಂಗ್ ಇಸ್ ಓಕೆ, ಬಟ್ ಸನ್ಶೈನ್ ಇರಬೇಕಾಗುತ್ತೆ, ಸನ್ನೂ ಬೇಕಲ್ಲ ರಿಫ್ಲೆಕ್ಟೆನ್ಸ್ ವ್ಯಾಲ್ಯೂ ಕಲೆಕ್ಟ್ ಮಾಡೋಕ್ಕೆ. ದೆನ್ ಕ್ಲಿಯರ್ ಸ್ಕೈ ಇಸ್ ಬೆಸ್ಟ್. ಬಟ್ ಏನಾಗುತ್ತೆ ಸರ್, ಇಟ್ ಇಸ್ ವೆರಿ ಡಿಫಿಕಲ್ಟ್ ಟು ಗೆಟ್ ದ ಕ್ಲಿಯರ್ ಸ್ಕೈ ಆಲ್ಸೋ. ಅದಕ್ಕೆ ಏನು ಮಾಡಿದ್ದಾರೆ, ವೈಲ್ ಕಲೆಕ್ಟಿಂಗ್ ದ ಡೇಟಾ, ಒನ್ ಅನದರ್ ಸೆನ್ಸರ್ ಇಸ್ ದೇರ್ ಆನ್ ದ ಡ್ರೋನ್, IR ಸೆನ್ಸರ್ ಅಂತಿದೆ, ದಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಕ್ಯಾಲಿಬ್ರೇಟ್ ದೀಸ್ ವೇರಿಯೇಷನ್ಸ್. ಇಫ್ ಏನಾದರೂ ವೇರಿಯೇಷನ್ಸ್ ಆಗ್ತಾ ಇದ್ದರೆ ಅದನ್ನು ಕ್ಯಾಲಿಬ್ರೇಟ್ ಮಾಡಿ ಆ ವ್ಯಾಲ್ಯೂಸ್ನ ಫೀಡ್ ಮಾಡುತ್ತೆ ಇಲ್ಲಿ. ದಟ್ ಕರೆಕ್ಷನ್ ಪ್ಯಾರಾಮೀಟರ್ಸ್ ಆಲ್ಸೋ ದೇರ್. ದೆನ್ ಅಫ್ಕೋರ್ಸ್ ಅಗೇನ್ ವಿ ಕ್ಯಾನ್ ಗೋ ಫಾರ್ ಅಡ್ವಾನ್ಸ್ ಸೆಟ್ಟಿಂಗ್ಸ್ ಆಲ್ಸೋ. ಇಲ್ಲಿ ರೇಡಿಯೋಮೆಟ್ರಿಕ್ ಕರೆಕ್ಷನ್ಸ್ ಏನಾದರೂ ಇತ್ತಂದರೆ, ಈ ರೇಡಿಯೋಮೆಟ್ರಿಕ್ ಕರೆಕ್ಷನ್ಸ್ ನಾನು ಓಕೆ ಕೊಟ್ಟರೆ, ಸೊ ದ ಡೇಟಾ ವಿಚ್ ಇಸ್ ಕ್ಯಾಪ್ಚರ್ಡ್ ಬೈ ದಟ್ ಸೆನ್ಸರ್ ದಟ್ ವಿಲ್ ಬಿ ಟೇಕನ್ ಆ್ಯಂಡ್ ದ ರೇಡಿಯೋಮೆಟ್ರಿಕ್ ಕರೆಕ್ಷನ್ಸ್ ವಿಲ್ ಬಿ ಡನ್ ಹಿಯರ್. ಓಕೆ, ಸೊ ಜಸ್ಟ್ keeping those things default, just I am going to apply the things. ಇಲ್ಲಿ ಕಾಣ್ತಿದೆಲ್ಲ ಪಾಯಿಂಟ್ಸ್. ಸೊ ದೀಸ್ ಆರ್ ದ ವೇ ಪಾಯಿಂಟ್ಸ್ ಐ ಆಮ್ ಟಾಕಿಂಗ್ ಅಬೌಟ್. ನಾವೇನು ಫ್ಲೈಟ್ ಪ್ಲಾನಿಂಗ್ ಏನು ಮಾಡಿದ್ವಲ್ಲ, ಸೊ ದೀಸ್ ಆರ್ ದ ಪಾಯಿಂಟ್ಸ್ ವೇರ್ ದ ಪಿಕ್ಚರ್ಸ್ ಆಸ್ ಆ್ಯಕ್ಚುಲಿ ಟೇಕನ್. ಇಲ್ಲಿ ಕ್ರಾಸ್ ಆಗಿ ಕಾಣ್ತಿದ್ದಾವೆ ಕೆಲವು ಇಮೇಜಸ್ಸು. ಸೊ ಇಟ್ ಈಸ್ ವೇರ್ ದ ಆ್ಯಕ್ಚುಲಿ ವಿ ಆರ್ ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಹಿಯರ್ ಎಟ್ ದಿಸ್ ಪೊಸಿಷನ್. ಕಾಣಿಸ್ತಿದೆಯಲ್ಲ, ವಿ ಆರ್ ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಹಿಯರ್ ಎಟ್ ದಿಸ್ ಪೊಸಿಷನ್. the drone has been positioned here at this point. ಇಲ್ಲೊಂದು 3-4 ಇದಾವೆ ನೋಡಿ ಪಾಯಿಂಟ್ಸು. ಅಲ್ಲಿ ನಿಂತಿತ್ತು, ಅಲ್ಲಿಂದ ಟೇಕಪ್ ಆಗಿದೆ ಅದು. ಸೊ ದ ಸ್ಟಾರ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ ವಾಸ್ ಇಟ್ ದಿಸ್ ಎಂಡ್, ಡಯಾಗ್ನಲಿ ಈ ಎಂಡಲ್ಲಿ ಇತ್ತು. ಸೊ ವೈಲ್ ಗೋಯಿಂಗ್ ಇಟ್ ಇಸ್ ಟೇಕಿಂಗ್ ದ ಪಿಕ್ಚರ್ಸ್. ಸೊ ಇಟ್ ಹ್ಯಾಸ್ ಸ್ಟಾರ್ಟೆಡ್ ಇಟ್ಸ್ ಪಾತ್ ಫ್ರಮ್ ದಿಸ್ ಸೈಡ್, ದೆನ್ ಈ ಥರ ಬಂದು ಮತ್ತೆ ಹಿಂಗೆ ಟರ್ನ್ ಆಗಿ ಹೋಗಿ ಜಿಗ್ಜ್ಯಾಗ್ ಆಗಿ ಇಲ್ಲಿ ಬಂದು ಎಂಡ್ ಆದ ತಕ್ಷಣ ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ಮುಗೀತು ಈ ಕಾರ್ನರ್ಗೆ. ದೆನ್ ಇಟ್ ಈಸ್ ಕಮಿಂಗ್ ಬ್ಯಾಕ್ ಟು ದಿಟ್ಸ್ ಒರಿಜಿನಲ್ ಪೊಸಿಷನ್ ಆ್ಯಂಡ್ ಇಟ್ ಈಸ್ ಲ್ಯಾಂಡೆಡ್ ಹಿಯರ್. ದಟ್ಸ್ ವೈ ದೀಸ್ ಕೈಂಡ್ಸ್ ಆಫ್ ಪಾತ್ ಹ್ಯಾಸ್ ಬಿನ್. So start just after doing those settings, we can say start processing. So it will be taking the time depending upon the number of images and what are the settings we have selected there and your computer capability. ಅದ್ರ ಮೇಲೆ ಕೂಡ ಇದೆ. ಹೌದು ಮೇಡಮ್, ಇಟ್ ಶುಡ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ಸಮ್ ಗ್ರಾಫಿಕ್ಸ್. ಸರ್ ಇಂಟರ್ನೆಟ್ ಇಟ್ ಡಿಪೆಂಡ್ ಸರ್. ಒಂದ್ಸಲ ಇನ್ಸ್ಟಾಲ್ ಆಯ್ತು ಅಂತಂದರೆ ಏನು ಇಶ್ಯೂ ಇಲ್ಲ, ನಾಟ್ ರಿಕ್ವೈರ್ಡ್. ನಾನು ಜಸ್ಟ್ ಅದನ್ನು ನಿಮ್ಗೆ ವೆಬ್ಸೈಟ್ ತೋರ್ಸೋಕ್ಕೋಸ್ಕರ ಕನೆಕ್ಟ್ ಮಾಡಿದೆ ಅಷ್ಟೇ. ಸೊ ಇಟ್ ಇಸ್ ಸೇಯಿಂಗ್ ಅರೌಂಡ್ ಇಟ್ ವಿಲ್ ಟೇಕಿಂಗ್ 7 minutes. So till it will get processed. ಹೋಗಿದ್ರೇನು ಸರ್ ಡೆಲ್ಲಿಗೆ? ಒಂದು ಇದನ್ನು ಪ್ರೆಸ್ ಓಕೆ ಒಂದು ಇದನ್ನು ವಿಸಿಟ್ ಕರೆದಿದ್ರು ನನಗೆ, ಇದಕ್ಕೆ ಒಂದೇನು ಲೆಕ್ಚರ್ ಇದೆ ಅಂತಂದು ಕರೆದಿದ್ರು. ಆವಾಗ ಅದು ಟ್ರೈನ್ ನಾನು ಹೋಗಾಗಲಿಲ್ಲ ಅಲ್ಲಿ. ಜಸ್ಟ್ ಮತ್ತೆ ಇದು ಮಾಡಿದ್ರಾ? ಹಾಂ. So this is the sensor. It is a multispectral camera sensor which we are having. That is the Red Edge MX sensor name. We can see these are the 5 bands or the 5 sensors separately, which is going to take the images in separate bands. Just I want to show the, yes. So this is the specifications of the sensors, which what is the resolution is there. So it's only 1.2 megapixel cameras with 5 images, 5 sensors are there, and these are the focal length, everything, and output will be in 12-bit images. Then the ground GST values. So if you are flying at 120 meter, then the 8 centimeter per pixel will be there, the resolution. Then if you are flying at 60 meters, as I said 60 meter limitations ಅಂತ ಹೇಳಿದ್ನಲ್ಲ, 60 meter, that is having a 4 centimeter per pixel band. So this is the limitations of that. And regarding this camera bands which we are having, so 5 bands, that is blue, green, red edge and near infrared. So there are 2 models, RX02 antide, RX01 antide. There is no much difference, some ಸ್ವಲ್ಪ variations ಇದೆ only in terms of bandwidth ಅಲ್ಲಿ. We can see the blue is 475 is the center value, plus or minus 32 nanometers. ಆ ಕಡೆ ಈ ಕಡೆ ಒಂದಿಷ್ಟು bandwidth ಅಲ್ಲಿ ಕವರ್ ಆಗುತ್ತೆ. Then 560 nanometer plus or minus 27. Then red band is the 668 nanometers, 16 nanometers is the bandwidth plus or minus. Red edge is 717 plus or minus 12, 842 and 57 nanometers is there. So these are the different 5 bands, blue, green, red and NIR and red edge. ಈಗ ನಮ್ಮಲ್ಲಿ ಏನದು ಇಮೇಜ್ ಅನ್ನು ಇತ್ತಲ್ಲ, ಫಸ್ಟ್ ಇಮೇಜ್ ಅಲ್ಲಿ ನಂಬರ್ ಬರೆದಿರ್ತಾರೆ 1 2 3 4 5 ಅಂತಂದು. ಸೊ ಇಮೇಜ್ ವಿಚ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ ಸೀರಿಯಲ್ ನಂಬರ್ 1 ಇದ್ರೆ ಇಟ್ ಈಸ್ ಅ ಬ್ಲೂ ಬ್ಯಾಂಡ್, ನೆಕ್ಸ್ಟ್ ಗ್ರೀನ್ ಬ್ಯಾಂಡ್, ರೆಡ್ ಬ್ಯಾಂಡ್, ದೆನ್ NIR band and red edge band. So this is what I am talking. This is an additional sensor which is mounted on the drone, DLS ಅಂತ ಏನು ಕರೆದಿದ್ದಾರಲ್ಲ. So this is used for calibrating the existing sunshine with the images. So ಅಲ್ಲಿ ಏನಾದರೂ ಕ್ಲೌಡಿ ಇದ್ರೂ ಕೂಡ it can be, the values can be corrected, the correction factor will be included. That's why it is integrated with this camera. Okay sir, DLS camera ಅಂದ್ರೆ ಸೊ ಆ DLS, ಇದು DLS ಬೇರೆ, ಇದು DLS ಬೇರೆ. ಇದು DLS ಕ್ಯಾಮ್ರಾ ಅಲ್ಲ, that component is known as a DLS ಇದರಲ್ಲಿ. So DLS ಅಂದ್ರೆ ಇಲ್ಲ, ಇದರಲ್ಲಿ DLS means it is a digital light sensor. So this DLS means it's a digital light sensor ಇದು ಬೇರೆ ಅದು ಬೇರೆ ಸರ್. Yes. Okay, so this is the orthomosaic map. So this is the orthomosaic map which has been generated. So side ಗೆಲ್ಲ ಇರದೆ existing field ಅಲ್ಲೇ ಮಾಡಿರೋದು. But ಇದೇನಿದೆ actually whatever the images we have taken, even though we have made a rectangular map, so because of the extra overlapping and missing of the overlapping, we can see the image is not exactly rectangle. Irregular shape ಅಲ್ಲಿ ಇದೆ because of the movement of the sensors. So this is the orthomosaic map. Then here itself we can have the surface map also. So surface map, surface elevations and minor elevations ಏನಿದೆ ಕೂಡ we can identify by using this map. So again once we can get this one, then the next thing is if you want to have some region of interest. So just I am having a region of interest of this map means then I can draw a boundary here. So just go for here, boundary option is there. We can draw the boundary. So you can select here. So here the boundaries can be selected. Select ಮಾಡ್ಕೊಂಡು point na. Just I was interested. So ಇಲ್ಲಿಂದ ತಗೊಳ್ಳೋಣ just to have a green vegetation. So I can mark the boundary of region of interest. Just I'll make it as rectangular as much as possible. Okay. So once it has been drawn, we can say OK button here. Okay. So this boundary has been created, or we can say this is the region of our interest. Then once it has been done, then again at the bottom it is showing the boundary. We can give the name, maybe your interested field or field 1 ಅಂತ ಏನಾದರೂ ನೀವು ಕೊಟ್ಟಿದ್ರೆ 1 1 2 1 3 1 3 ಏನಾದರೂ ಕೊಟ್ಟಿದ್ರೆ ಅದನ್ನ ಲೇಬಲಿಂಗ್ ಮಾಡಿಕೊಂಡು you can also slightly see here the area has been given 2.55 hectare area is there. That much area has been covered. Then you can say the save button here. Then at the right side you can see that map has been, that boundary has been created it here separately. So again if you want to have another boundary within that region, or you want to have a separate field, then again another boundary can also be drawn similarly. So number of boundaries can be drawn. At the same time ಆಲ್ರೆಡಿ ಏನಾಗುತ್ತೆ ಕೆಲವು ಟೈಮ್ ಒಂದ್ಸರಿ ನಾವು ಇವತ್ತು ಬೌಂಡ್ರಿ ಹಾಕಿರ್ತೀನಿ, ನೆಕ್ಸ್ಟ್ ಟೈಮ್ ಬಂದಾಗ ನಂಗೆ ಬೌಂಡ್ರಿ ಹಾಕೋದು ಬೇಕಾಗಿಲ್ಲ. ದಟ್ ಫೈಲ್ ಕ್ಯಾನ್ ಬಿ ಎಕ್ಸ್ಪೋರ್ಟೆಡ್, ಲೇಟರ್ ಆನ್ ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಇಂಪೋರ್ಟೆಡ್ ಹಿಯರ್. ಇಲ್ಲೊಂದು ಇಂಪೋರ್ಟ್ ಶೇಪ್ ಅಂತಿದೆ ನೋಡಿ. ಸೊ ಇಂಪೋರ್ಟ್ ಆಸ್ ಎ ಬೌಂಡ್ರಿ ಅಂತಂದರೆ ಡೈರೆಕ್ಟ್ಲಿ ದ ಶೇಪ್ ಕ್ಯಾನ್ ಬಿ ಇಂಪೋರ್ಟೆಡ್ ಸೊ ದಟ್ ವಿ ಕ್ಯಾನ್ ಮಿನಿಮೈಸ್ ದ ಎರರ್ಸ್ ಫಾರ್ ಅನಲೈಸಿಂಗ್. ಸೊ ಒನ್ಸ್ ಇಟ್ ಹ್ಯಾಸ್ ಬೀನ್ ಡನ್, ಅಗೇನ್ ದ ಬೌಂಡ್ರಿ. ಸೊ ಇಲ್ಲೊಂದು ಟ್ರಿಮ್ ಆಪ್ಷನ್ ಅಂತಿದೆ. ಇಫ್ ಯು ಟ್ರಿಮ್ ಇಟ್, then only that is really creating as a separate unit. It is trimming that portion, and remaining portion it will be not considering. So it has been made as an orthomosaic 1 ಅಂತ ಒಂದು ಆಗಿದೆ ನೋಡಿ ಇಲ್ಲಿ ಮೇಲ್ಗಡೆ. That can be renamed. It can be renamed. One normal this is a normal orthomosaic. If I remove that boundary, it is a normal orthomosaic map. This is with a origin of interest map. That can be done. Then later on, suppose if you see here, if you want to add some labels or if you want to add some annotations, then that thing can also be done. Suppose illon field istu regionally some issue ide. Why, what is the issue anta namage ಇಲ್ಲಿ ಗೊತ್ತಾಗ್ತಾ ಇಲ್ಲ. I want to inspect in the field level. Okay, I will go to the field, I will inspect it. Something issue identify ಮಾಡಿದೀವಿ ನಾವು. You can take the image of that one. After coming back, just you can take the annotation here. Annotation can be done in point wise, line wise, or in a polygon annotations. So for example, point ತಗೊಂಡಿದ್ದೆ ಅನ್ಕೊಳ್ಳಿ. So something is there, I don't know about it. Just I will click it. You can add that image. ಒಂದು ಫೋಟೋ ಅಲ್ಲಿ ಹಾಕ್ಬೋದು ನಾವು. some tubewell ಇತ್ತು ಅನ್ಕೊಳ್ಳಿ. tubewell ಇತ್ತಂತಂದ್ರೆ, so tubewell is there, identification. tubewell ಫೋಟೋ ತಗೊಂಡು ಅಲ್ಲಿ ಹಾಕೊಂಡ್ರೆ later it can be used as a further information. This thing, I mean, ಏನಾದ್ರು ಒಂದು polygon ಹಾಕೊಂಡು we can give the information. We can type some matter, something. So whatever the information it is required, that can be done, and those annotations can also be entered there. Just I am removing this annotation. Okay. So this is the info antide. If you press this info, So this is going to provide the information about our region of interest. So it is saying the area, layer area is around 2.557 hectares, and the dimensions of that image is this much of pixels. Then the GSD of this image is 6 centimeter per pixel. So the 6 centimeter on the ground level is representing 1 pixel in our image. Then the file size is around 146 MB. So data type, everything. So band, what are the bands are available? So 5 bands are available here. So it is saying, so at what time you are doing, at what time you have taken the picture. You can see here, the data has been acquired in February 2nd, February 2024 at 3 o'clock in the afternoon class. We have captured this data. So everything, whatever the information is there, that is taken here. So what was the duration of the flight? So you can see the duration of the flight was 4 minutes to 28 seconds. Okay. So whether we have applied this radiometric correction or not, see here the camera correction, sun irradiations and sun angle using illumination model has been corrected. So reflectance target, whether we have used that reflectance target, means that for a calibration madidivilla antanadu, everything will be done here. You can get the information. So we can't fool others here. So information is sikkudutte. If I am providing you this information, means you can check whether I am providing a correct information or not. Those things can be done here. So once the information has been done, if the annotations are required, labels are required, thumbnails, so everything can be added depending upon requirement. You can later on you can see those things. Then which one, sir? Yes, zoom ಮಾಡಬಹುದು, sir. Sorry. Actually, I have not brought the mouse. Scroll ಮಾಡಿಬಿಟ್ರೆ ಸಾಕು, ಅದು ಬಂದ್ಬಿಡುತ್ತೆ. So zoom ಮಾಡಬಹುದು ನಾವು. You can zoom it. So this is the maximum zoom. We can also slide it. Just. It's a simple normal things which can be done in another image processing tools. Okay. Then, so coming for the next part, that is the generation of the indexes. So for the generation of the indices, so here we can have the options, index, magic, operation. This magic has been recently added. It can be edited, it can be done. So just it is to reduce the work, repetition ಮಾಡಕ್ಕೆ ಅದನ್ನ copy paste ಮಾಡಕ್ಕೆ ಅದನ್ನ use ಮಾಡ್ತಾರೆ. Later on you can explore that one. And regarding the operations, actually, okay, so this has been changed, I think. So earlier the zonation ಅಂತ ಏನಿದೆಯಲ್ಲ, so zonation and this index, only 2 options was there. We used to do that one. So something ಸ್ವಲ್ಪ variations ಆಗಿದೆ ಈಗ. Okay, we will see. So before that, so we need to develop some vegetation indices. So for that index, then illide ನೋಡಿ, these are the first thing we need to select which layer you are going to apply this one. So 2 options are giving. One is the orthomosaic complete area. Another name we have selected, region of interest, it is the orthomosaic 1. I am selecting this layer, orthomosaic 1, and these are already default indices or predefined indices are there. You can select 1, 2, 3, any number of indices, whatever you want. Just I want to select NDVI, NDRE, then what you call VRI. Any indices can green normalized difference index. So I am just selecting those things. After that, we can directly go for generate. ಕೆಳಗಡೆ generate ಅಂತಿದೆ. It can, if you say generate, the rest of the things will be done, calculations will be done by itself. We can generate this data. So this is the indices which has been developed. So this is the VRI index. Then this is the NDVI. So this is the NDVI index. We can zoom it, zoom out. We can see whatever the things are there. It can be seen. And here, as I said, this is here on the right hand side, you can see the different options are available. For visualizing purpose, different color modes are there. You can go for a simple grayscale. So this is a simple grayscale image. or else we can go for different colors, red, green, turbo color, glow color. Depending upon our requirement, we can select whichever is comfortable with us for identification. That can be selected and it can be done. Yes, ma'am. Yes, madam. Actually, this NDVI measures the greenness level. We need to see that. That's what, madam. We need to compare this. See, by selecting NDVI, I am getting this map. So whatever the regions it is showing red, it is saying that as per here on the other side, you can see the NDVI values has been varied from 0.122 to 0.906. This is the variation minimum and maximum. So if with the ground truth data, we can verify it. If you are satisfied this one, we can use this one. There are some chances are there, some of the regions it may be showing less NDVI, which may not be not important for you. Then we can shift for another indices. It can be done. See, here there is a range. You can select, you can slide this one. So I am selecting 0.349 or 352, 0.7, or you can directly type here also. 0.3 to 0.8. So here whatever the things, your region of interest is there, that it is showing. If I make it as a solid here, you can see the map. So completely red, whatever red is there, that is less than 0.3 only. Directly, or if you go for transparent, so whichever is the region of interest, only thing. So these are the maps which is showing only 0.3 to 0.8. You can place. Sometimes what happens, by using this one, you can further develop another indices, where the correction factor, by multiplying this 0. By removing, if you want to remove the 0.3, a formula is minus 0.3 now ಹಾಕಿದ್ರೆ 0.3 ಗಿಂತ ಕಡಿಮೆ ಇದೆಲ್ಲ ಹೋಗಿ only above 0.3 ಇದೆ ಅಷ್ಟು ನಮಗೆ ಕಾಣಿಸುತ್ತೆ. ಆ ರೇಂಜ್ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೋಬಹುದು. ಫರ್ದರ್ ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಮಾಡಿಫೈಡ್. For exporting, again, there are different options are available. Here the export option is there at the top. So when I say the export, you can export the layers, you can export the statistics data, and it is itself generates some PDF report. Okay, that is option is also there. Right now, since I am using a demo version, these are not available. ಮುಂಚೆ ನಾನು PDF reports generate ಮಾಡ್ತಾ ಇದ್ದೆ ಅವರು. ಈಗ ಬರ್ತಾ ಇಲ್ಲ ಅದು. There we can having those options. ನಿಮಗೆ image ಬರುತ್ತಲ್ಲ, it will be providing, it is better to generate one PDF report, and you can take the image in TIFF format, GeoTIFF format. GeoTIFF format ಬಂತಂದ್ರೆ it can be used for another software. ಅದೇನು ಕಲರ್ ಎಸ್ಟಿಮೇಷನ್ ಕೊಡ್ತಾ ಇದೆ ಆಲ್ರೆಡಿ ಬೇರೆ having the table also, report tables. And only ನಮಗೆ ಇದೇನು values ಬೇಕಾಗಿಲ್ಲ ನನಗೆ, only I need the statistics values. What is the values in terms of indices? So ಈ statistics ಅಂತ ಇದೆಲ್ಲ ಇದನ್ನ ಎಕ್ಸ್ಪೋರ್ಟ್ ಮಾಡಿಬಿಟ್ರೆ we will get in terms of numbers. That's all. So it can be used for machine learning purpose. ಅದಕ್ಕೆ ಯೂಸ್ ಆಗುತ್ತೆ. That is further thing. ಇದರಲ್ಲಿ ಮಾಡಕ್ ಬರಲ್ಲ. ಇದರಲ್ಲಿ ನೀವು ಇಷ್ಟು ತಗೊಳ್ತಿರಲ್ಲ, ಇದರಿಂದ ನಾವು ಮಷಿನ್ ಲರ್ನಿಂಗ್ ಅಪ್ಲೈ ಮಾಡಬೇಕು. ಹೇಳಿದ್ರು ಸ್ಟಾಟಿಸ್ಟಿಕ್ಸ್ ಏನಂದಲ್ಲ. So those statistics values we need to extract from here. It has to be trained. We need to train one algorithm. We need to say that 0.3 indices ಅಂತಂದ್ರೆ this much yield has been obtained. 0.4 ಬಂದ್ರೆ ಇಷ್ಟು yield obtain ಆಗಿದೆ ಅಂತ ಟ್ರೈನ್ ಅಪ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. Later on, once you map it, ನಿಮ್ದು ಏನಾದ್ರು 0.6 ಬಂದಿದೆ ಅನ್ಕೊಳ್ಳಿ indices, then it will say that this is your yield. Again, it is a further. It again depends on many things. ಎಲ್ಲನೂ ನಮಗೆ different variables, different factors are there. Whichever important factors are there, that we should. It is just like a modeling. Modeling, we can have hundreds of variables. We can have only 2 variables. Just like a model. So another option is there in this. ಸೊ ಇಲ್ಲಿ ಇನ್ನೊಂದು ಏನಿದೆ ಅಂತಂದ್ರೆ ಜಸ್ಟ್ ವಿ ಕ್ಯಾನ್ ಹ್ಯಾವ್ ದ ಕಂಪೇರ್ ಮಾಡೆಲ್. ಇಲ್ಲೊಂದು ಡಬಲ್ ಅಂತಿದೆ. ಸೊ ಇಫ್ ಯು ವಾಂಟ್ ಟು ಕಂಪೇರ್ ದ ಟೂ ಥಿಂಗ್ಸ್, ಜಸ್ಟ್ ಐ ವಾಂಟ್ ಟು ಕಂಪೇರ್ ಮೈ sorry. So suppose if you want to compare this orthomosaic map with the NDVI, I can select these two. This is the NDVI map, this is the orthomosaic map. So side by side we can compare, we can differentiate, we can analyze the things. Similarly, if you want to compare the NDVI map with NDRE map, this is the NDRE on the left side and the right side is the NDVI. So the same idena variations idena, what significant the NDRE is showing, those things can be analyzed. Again, it depends upon the person to person. So this option is there. Another option is there is on split antide. So if I go for split, for example, the same thing for orthomosaic and NDVI. So just by sliding this cursor, we can overlap the layer on it. Itara comparison. I ille nodta idini. So how it is looking like, what conclusion we can draw out of it. So that thing can also be done. Or I want to compare with VARI. So VARI ತಗೊಂಡು ಈ ಕಡೆ VARI ಇರುತ್ತೆ, ಈ ಕಡೆ ಇದು NDVI ಇರುತ್ತೆ. So we can compare between these two maps or these two indices. So these things can also be done here. So ultimately, after generating these indices, as I said, it is left to us, the operator. And after once it has been generated, once it has been done, again, it depends upon the analyst how he is going to interpret the data. That's all. Same thing. That is having more options compared to this one. But it is more complex. Normal person can't use that one. ಹೌದು ಮೇಡಮ್, ಅದರಲ್ಲಿ ಸ್ವಲ್ಪ ಎಕ್ಸ್ಪರ್ಟೈಸ್ ಬೇಕಾಗುತ್ತೆ. ಇದು ಒಂದು ಲೇಮ್ಯಾನ್, ಈಗ ನಾನು ಹೇಳಿದಲ್ಲ 5 minutes ಕೆಲಸ ಇಲ್ಲ, ಎಲ್ಲರೂ ಮಾಡ್ಬೋದು ಈಗ ನೀವು ಕೂತ್ಕೊಂಡು. ಕಂಪ್ಲೀಟ್ ಇಟ್ ರಿಕ್ವೈರ್ ಸಮ್ ಡೆಫಿನೆಟ್ ಸ್ಕಿಲ್ಸ್ ಎಲ್ಲ ಬೇಕು, ಅದಕ್ಕೆ ಟೈಮ್ ತಗೊಳುತ್ತೆ. ಬಟ್ ಅಷ್ಟೇ ಇನ್ಫಾರ್ಮೇಷನ್ ಸಿಗುತ್ತೆ ಅದರಲ್ಲಿ ನಮಗೆ. ಸೊ ಏನದರ್ ಇಂಡೈಸಸ್ ಅಲ್ಲೊಂದು ಕಸ್ಟಮ್ ಇಂಡೆಕ್ಸ್ ಅಂತ ಇದೆ ಲಾಸ್ಟಲ್ಲಿ. ಸೊ ಇಫ್ ಯು ಹ್ಯಾವಿಂಗ್ ಎನಿ ಇಂಡೈಸಸ್ ವಿತ್ ಫಾರ್ಮುಲಾಸ್, so just by putting those formulas we can generate our own indices also. That is option is also available here. Okay sir, so this is all about this Pix40 fields. So ಇನ್ನೊಂದು ಇತ್ತು, ಮೋಸ್ಟ್ಲಿ ಅದೇನೋ ಕಾಣಿಸ್ತಾ ಇಲ್ಲ. Just I want to show another one. Zonation ನೋಡೋಣ, just I will try it. Zonation means for if you want to give the prescription map for the variable rate technology. ಅದಕ್ಕೆ ಒಂದು I will try because that option has been ನಮಗೆ ಹೊಸ ಆಪ್ಷನ್ ಬಂದಿದೆ, ಅದು ಇರ್ತಿರಲಿಲ್ಲ, ಕಾಣ್ತಾ ಇಲ್ಲ. ಜಸ್ಟ್ ಐ ವಿಲ್ ಸಿ. ಇವನ್ ಬೆಳಗ್ಗೆ ನಾನು ಟ್ರೈ ಮಾಡ್ತಾ ಇದ್ದೆ, ಕಾಣಿಸ್ಲಿಲ್ಲ. ಪ್ಲಸ್ ನಾನು ವಿಡಿಯೋ ಚೆಕ್ ಮಾಡಿದೆ, ಅದು ಇದ್ರದ್ದು ವಿಡಿಯೋನೂ ಬಿಟ್ಟಿಲ್ಲ ಅವರು. ಐ ಆಮ್ ಅನೇಬಲ್ ಟು ಸೇ, ಹಳೆ ವಿಡಿಯೋ ಇದೆ ಅದರಲ್ಲಿ. ಓಕೆ, ಸೊ ಹಿಯರ್ ಇನ್ ದಿಸ್ ಥಿಂಗ್ zonation, we can classify this map into different zones. Number of zones ಅಲ್ಲಿ ಕ್ಲಾಸಿಫೈ ಮಾಡ್ಬೋದು. For that we can select this map. So just I am selecting this NDVI map only, or we can go for any NDRE ತಗೊಳ್ಳೋಣ. So this is the NDRE map and this is the boundary layer which we have selected. After selecting, if you just put here, if there is any obstacles are there, obstacles ಏನಾದರೂ ಇನ್ಕ್ಲೂಡ್ ಮಾಡಿದ್ರೆ ಅದನ್ನು ಇನ್ಕ್ಲೂಡ್ ಮಾಡ್ಕೋಬೋದು, ಇಲ್ಲಾಂತಂದರೆ ಬಿಡ್ಬೋದು. And prescription unit ಅಂತ ಕೇಳಿದೆ ನೋಡಿ ಇಲ್ಲಿ. So in prescription unit we can say liters per hectare. So liters per hectare, it may be liquid application, either it may be pesticide, weedicide, like that, or kg per hectare, fertilizer application may be there. So seeds per hectare, variable rate technology for the seeds, so that thing can be done. So just I am taking the fertilizer application ಅಂತ ಏನು ತಗೊಂಡ್ರೆ kg per hectare ತಗೊಂಡ್ರೆ for this NDR, based upon this NDRE value, just I will say continue. So this grid will be generated. Again this grid is the path for movement of your vehicle. So whatever the decision is taken by that vehicle, it will be based upon that grid. So grid size ಕೂಡ ನಾವು ಇಲ್ಲಿ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೋಬಹುದು. ಜಸ್ಟ್ ಇಲ್ಲಿ ನೋಡಿದ್ರೆ the cell size 3 meters. So one grid is 3 by 3 meter. So whatever the recommendations we are saying, it will be applied throughout that grid. You say 5 kg per hectare application rate ಅಪ್ಲೈ ಆಗಬೇಕಂತಂದ್ರೆ 3 meter 3 by 3 meter ಗೆ ಎಷ್ಟು ಅಪ್ಲೈ ಆಗಬೇಕು ಅಷ್ಟು ರೇಟ್ ಅಲ್ಲಿ ಅಪ್ಲೈ ಆಗುತ್ತೆ based upon that. So that can also be changed. Minimum I think it is go 0.10 centimeter ಇಂದ ಹಿಡ್ಕೊಂಡು up to 100 meters ವರೆಗೂ ಗ್ರಿಡ್ ಸೈಜ್ನ ನಾವು ವೇರಿ ಮಾಡ್ಕೋಬಹುದು. Then again orientations can be adjusted by using this Options are there, offsets, give sets, adjustment ನೀವು ನೋಡ್ಕೋಬಹುದು. It can be done. Then number of zones, how many zones you want to make it. So say I want to make 5 zones for application. ಅಂದರೆ ಈಗ ಸಪೋಸ್ ರೆಕಮೆಂಡೆಡ್ ಡೋಸೇಜ್ಗಿಂತ ನಾನು ಎಷ್ಟುವರೆಗೂ ನಾನು ಸ್ಪ್ಲಿಟ್ ಮಾಡ್ಬೋದು ಅದನ್ನು. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಐ ವಾಂಟ್ ಟು ಮೇಕ್ ಎ 5 zones, just I'm taking here, with equal intervals, I want to make it. So these things can be played later on. Then what is the index value? Whether you want to go for a minimum index or a maximum index or a mean value of the index. Just I want to keep that a mean index. Just if a preview one select ಮಾಡಿದ್ರೆ it will made into 5 zones based upon the indices. That is the index value is varied from 0.15 ಇಂದ 0.44 ವರೆಗೂ ಇದೆ. ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಇದ್ದು ಯಾವುದೇ ಝೋನಲ್ಲಿ ಇಲ್ಲ. ಗ್ರೀನ್ ಝೋನ್ ಅಂತಂದರೆ ನೋ ರಿಕ್ವೈರ್ಮೆಂಟ್ ಇಸ್ ದೇರ್ ಫಾರ್ ಅಪ್ಲಿಕೇಶನ್. ಸೊ 5 zones ಬಂದಿದೆ. ಓಕೆ, ಇಫ್ ಇಟ್ ಈಸ್ ಓಕೆ ವಿ ಕ್ಯಾನ್ ಕೀಪ್ ಇಟ್, ಅದರ್ವೈಸ್ ಯು ಕ್ಯಾನ್ ಚೇಂಜ್ ದ ನಂಬರ್ ಆಫ್ ಝೋನ್ಸ್. ಯಾವ್ದು ಸರ್? ಎಸ್ ಸರ್, ದಟ್ಸ್ ವಾಟ್ ಸರ್, ವ್ಯಾಲ್ಯೂಸ್ ನಾವು ಡಿಕ್ಲರೇಷನ್ ಮಾಡ್ಬೋದು ಸರ್. ಈಗ ಅದನ್ನೇ ಮಾಡ್ತೀವಿ ಸರ್ ನೆಕ್ಸ್ಟ್. ಸೊ ಪ್ರಿವ್ಯೂ ಇಸ್ ಓಕೆ ಇತ್ತಂದರೆ ಐ ಹ್ಯಾವ್ ಮೇಡ್ ಇಂಟು 5 zones. Create operation layer. Now the layer has been created. So here the options are provided. So the red zone and then ಕಾಣ್ತಾ ಇದೆಯಲ್ಲ, in that zone 0.74 hectare area is covered. So ಆರೆಂಜ್ ಸ್ವಲ್ಪ ಲೈಟಲ್ಲಿ ಇದ್ದರೆ 1 hectare ಇದೆ, ಅದರಲ್ಲಿ 0.76 ಇದೆ. ಸೊ ಇಷ್ಟಿಷ್ಟು ಹೆಕ್ಟೇರ್ ಇದೆ ಅಂತ ಅರ್ಥ. So what is your recommendations are there? We can provide there because red means more fertilizer you want to apply, green means less fertilizer as per indices. Just I am saying blindly. ನಾನೀಗ ಬ್ಲೈಂಡ್ಲಿ ಹೇಳ್ತಾ ಇದ್ದೀನಿ, ನಾವು ಅದನ್ನು ಡಿಸೈಡ್ ಮಾಡಬೇಕು. ಸೊ ಜಸ್ಟ್ ಫಾರ್ ಮೈ ಕೇಸ್ ಐ ವಿಲ್ ಸೇಯಿಂಗ್ 0.74 ಇಸ್ ದಿ ಏರಿಯಾ, ರೆಡ್ ಝೋನ್ ಇದೆ, ಅದಕ್ಕೆ ಜಾಸ್ತಿ ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಅಂತಂದರೆ ಸೊ ಎಷ್ಟು ಬೇಕು? ಸೇ ಐ ಆಮ್ ಅಪ್ಲೈಯಿಂಗ್ ಅರೌಂಡ್ 150 kg ಮ್ಯಾಕ್ಸಿಮಮ್. ನೆಕ್ಸ್ಟ್ ಈಸ್ ದಟ್ ಈಸ್ ದ ಮೋರ್ ದೆನ್ ರೆಕಮೆಂಡೇಷನ್, ಅದು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾಗುತ್ತೆ ನಾವು. ದೆನ್ ಈ ಕಲರ್ ಬಂತಂದರೆ ಐ ಆಮ್ ಸೇಯಿಂಗ್ ಐ ಆಮ್ ರೆಡ್ಯೂಸಿಂಗ್ ಇಟ್ ಅಪ್ ಟು 125, ಐ ಡೋಂಟ್ ನೋ, ಜಸ್ಟ್ 100, 50. It can be varied like anything, or 25, something, or nil, 0, ಬೇಕಾಗಿಲ್ಲ 0 ಇಟ್ಕೊಂಡ್ರೆ then you can see here the total amount required it is going to give. ಈ ಥರದ್ದು ಎಷ್ಟು ಬೇಕಾಗುತ್ತೆ? 110 kg for this zone, 129 kg for this zone. So everything will be given by this data will be provided. Then later on what was the cell size? Already total amount required is 332 kgs of fertilizer is required. We need to feed it. So applied rate, average applied rate is around for the 2.86 hectares area we are going to apply the fertilizer. So minimum rate of application is 116.4 kg per hectare is the application rate, average application rate. So everything will be provided here. So once you have done it, then this map can be directly exported. We'll export ಹೋಗಿ share ಅಂತಂದು different formats also ಸಿಗುತ್ತೆ. It may be in the form of a shape file, it may be in the TIFF files, depending upon our requirement of the VRT technology. ಆ ಫೈಲ್ ಫಾರ್ಮ್ಯಾಟಿಗೆ ನಾವು ಎಕ್ಸ್ಪೋರ್ಟ್ ಮಾಡಿಕೊಂಡು ವೆನ್ಸ್ ವಿ ಫೀಡ್ ದಟ್ ಒನ್ ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಡನ್, ದ ಆಕ್ಷನ್ ವಿಲ್ ಬಿ ಟೇಕನ್ ಬೈ ದಟ್ ಒನ್. ಸೊ ಅಪ್ ಟು ಇಲ್ಲಿವರೆಗೂ ಈ ಆಪ್ಷನ್ಸ್ ಇದರಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಷ್ಟೇ. ಓಕೆ, ಐ ಥಿಂಕ್ ಐ ಹ್ಯಾವ್ ಕಂಪ್ಲೀಟೆಡ್ ಎವ್ರಿಥಿಂಗ್. Okay, thank you. So if anything else, if you want to ask, you can ask. So just for maturity purpose ಗೆ ಒಂದು ನಾನು ಇಮೇಜಸ್ ತಗೊಂಡಿದ್ದೆ ನಾನು. Just I want to show that one. ಗಂಗಾವತಿಯಲ್ಲಿ ಏನು ಮಾಡಿದ್ವಿ ಫೀಲ್ಡ್ ಅಲ್ಲಿ. Here this thing. So here you can see these are the farmers field which has been taken. They have transplanted the paddy at different times depending upon their requirement. ಅವಾಗ ಅನುಕೂಲತೆ ಮಾಡ್ಕೊಂಡಿದ್ದಾರೆ. Some of the farmers they have achieved early maturity. Already ಇಲ್ಲಿ ನೋಡಿ ಕ್ರಾಪ್ ಹಾರ್ವೆಸ್ಟಿಂಗ್ ಸ್ಟೇಜಸ್ ಬಂದಿದೆ, ಇನ್ನೂ ಕೆಲವು ಬಂದಿಲ್ಲ, ಈ ಗ್ರೀನ್ ಕಾಣ್ತಾ ಇದೆ. So these kinds of variations can be studied and the decisions can be taken. So based upon this is nothing but simple NDY value ಅಷ್ಟೇ ಇದು. Just by NDY values only we are able to differentiate whether the crop has been measured or not. These decisions can be done. Okay.
Any questions? No. Friends, I think we're ending up with this today's session. So really it was wonderful. Today's it is almost a practical aspect related to the drone applications. So I think even KSNUAHS sir and also the Sunil sir class were fantastic. So where they are applied this drone technology into the field, and they have presented some of the case studies related. I think the principles what they have presented that can be helpful for us in what we are in the different fields can be utilized. I think we can plan as accordingly. Sir, for a wonderful presentation and also the information on behalf of our participants, behalf of the organizers, and also on behalf of our university IDP, I wholeheartedly thank you very much for your wonderful presentation. I request the senior sir to present a token of love in the form of certificate and the book to our resource person. Sir. Thank you very much, sir, once again. So we'll break and have a nice day. So tomorrow we'll meet by 9:30. So tomorrow there is a big change in the class. So instead of Virana sir, tomorrow is 5-7, no? Sure, Dr. Sharanabasappa will take the first class related to the insecticide and acaricide classification and their mode of action. Then followed by, I will going to take the design of field experiments for pesticide. Then Dr. Virana sir, then we'll go to the practical. So tomorrow we'll wind up little bit early because day after tomorrow we have to travel sharp by 5:30 here to reach RPTO and for that purpose. So tomorrow sharp by 4 o'clock or maximum 4:30 we'll be closing the sessions. Okay, thank you once again. So whatever all the documents we have given, so come with all the attachments what is requirement for claiming your traveling allowance. Okay, thank you very much.